I'm sure you all agree that machine learning is one of the hottest trends in today's market, right? Gartner predicts that by 2022, there will be at least 40% of new application development projects going on in the market that would be requiring machine learning co-developers on their team. It's expected that these projects will generate a revenue of around $3.9 trillion. Isn't it huge? So looking at the huge upcoming demand of machine learning around the world, we guys at Edureka have come up and designed a well-structured machine learning full course for you guys. But before we actually drill down over there, let me just introduce myself. Hello all, I'm Atul from Edureka, and today I'll be guiding you through this entire machine learning course. Well, this course has been designed in a way that you get the most out of it. So we'll slowly and gradually start with the beginner level and then move towards the advanced topic. So without delaying any further, let's start with the agenda of today's session. Our machine learning course has been segregated into 6 different modules. We'll start our first module with Introduction to Machine Learning. Here we'll discuss things like what exactly is machine learning, how it differs from artificial intelligence and deep learning, what are its various types, what are its various applications, and finally we'll end our first module with a basic demo in Python. Okay? Our second module focuses on stats and probability. Here we'll cover things like descriptive statistics, inferential statistics, probability theory, and so on. Our third module is on supervised learning. Well, supervised learning is one of a type of machine learning which focuses mainly on regression and classification type of problem. It deals with labeled datasets, and the algorithm which are a part of it are linear regression, logistic regression, naive Bayes, random forest, decision tree, and so on. Our fourth module is on unsupervised learning. Well, this module focuses mainly on dealing with unlabeled datasets, and the algorithm which are a part of it are K-means algorithm and a priori algorithm. As a part of fifth module, we have reinforcement learning. Here we are going to discuss about reinforcement learning in depth and also about Q-learning algorithm. Finally, in the end, it's all about to make you industry ready. Okay, so here we are going to discuss about 3 different projects which are based on supervised learning, unsupervised learning, and reinforcement learning. Finally, in the end, I'll tell you about some of the skills that you need to become a machine learning engineer. Okay, and also I'll be discussing about some of the important questions that are asked in a machine learning interview. Fine. With this, we come to the end of this agenda. Before you move ahead, don't forget to subscribe to Edureka and press the bell icon to never miss any update from us.
Hello everyone, this is Atul from Edureka and welcome to today's session on what is machine learning. As you know, we are living in a world of humans and machines. The humans have been evolving and learning from the past experience since millions of years. On the other hand, the era of machines and robots have just begun. In today's world, these machines or the robots are like they need to be programmed before they actually follow your instructions. But what if the machines started to learn on their own? And this is where machine learning comes into picture. Machine learning is the core of many futuristic technological advancement in our world. Today you can see various examples or implementation of machine learning around us, such as Tesla's self-driving car, Apple Siri, Sophia AI robot, and many more are there. So what exactly is machine learning? Well, machine learning is a subfield of artificial intelligence that focuses on the design of system that can learn from and make decisions and predictions based on the experience, which is data in the case of machines. Machine learning enables computer to act and make data-driven decisions rather than being explicitly programmed to carry out a certain task. These programs are designed to learn and improve over time when exposed to new data. Let's move on and discuss one of the biggest confusion of the people in the world. They think that all the 3 of them, the AI, the machine learning, and the deep learning, all are same. You know what? They are wrong. Let me clarify things for you. Artificial intelligence is a broader concept of machines being able to carry out tasks in a smarter way. It covers anything which enables the computer to behave like humans. Think of a famous Turing test to determine whether a computer is capable of thinking like a human being or not. If you're talking to Siri on your phone and you get an answer, you're already very close to it. So this was about the artificial intelligence. Now coming to the machine learning part. So as I already said, machine learning is a subset or a current application of AI. It is based on the idea that we should be able to give machine the access to data and let them learn from themselves. It's a subset of artificial intelligence that deals with the extraction of pattern from dataset. This means that the machine can not only find the rules for optimal behavior, but also can adapt to the changes in the world. Many of the algorithms involved have been known for decades, centuries even. Thanks to the advances in the computer science and parallel computing, they can now scale up to massive data volumes. So this was about the machine learning part. Now coming over to deep learning. Deep learning is a subset of machine learning where similar machine learning algorithms are used to train deep neural networks so as to achieve better accuracy in those cases where former was not performing up to the mark. Right. I hope now you understood that machine learning, AI, and deep learning, all three are different. Okay, moving on ahead. Let's see, in general, how a machine learning works. One of the approaches is where the machine learning algorithm is trained using a labeled or unlabeled training dataset to produce a model. New input data is introduced to the machine learning algorithm and it makes prediction based on the model. The prediction is evaluated for accuracy, and if the accuracy is acceptable, the machine learning algorithm is deployed. Now, if the accuracy is not acceptable, the machine learning algorithm is trained again and again with an augmented training dataset. This was just a high-level example, as there are many more factors and other steps involved in it. Now let's move on and subcategorize the machine learning into three different types: the supervised learning, unsupervised learning, and reinforcement learning. And let's see what each of them are, how they work, and how each of them is used in the field of banking, healthcare, retail, and other domains. Don't worry, I'll make sure that I use enough examples and implementation of all three of them to give you a proper understanding of it. So starting with supervised learning. What is it? So let's see a mathematical definition of supervised learning. Supervised learning is where you have input variables x and an output variable y, and you use an algorithm to learn the mapping function from the input to the output, that is y equal fx. The goal is to approximate the mapping function so well that whenever you have a new input data x, you could predict the output variable, that is y, for that data. Right. I think this was confusing for you. Let me simplify the definition of supervised learning. So we can rephrase the understanding of the mathematical definition as a machine learning method where each instances of a training dataset is composed of different input attribute and an expected output. The input attributes of a training dataset can be of any kind of data. It can be a pixel of image, it can be a value of a database row, or it can even be an audio frequency histogram, right? For each input instance, an expected output value is associated. The value can be discrete, representing a category, or can be a real or continuous value. In either case, the algorithm learns the input pattern that generates the expected output. Now, once the algorithm is trained, it can be used to predict the correct output of a never seen input. You can see an image on your screen, right? In this image, you can see that we are feeding raw inputs as image of apple to the algorithm. As a part of the algorithm, we have a supervisor who keeps on correcting the machine, or who keeps on training the machine. It keeps on telling him that yes, it is an apple, and no, it is not an apple. Things like that. So this process keeps on repeating until we get a final trained model. Once the model is ready, it can easily predict the correct output of a never seen input. In this slide, you can see that we are giving an image of a green apple to the machine, and the machine can easily identify it as yes, it is an apple, and it is giving the correct result, right? Let me make things more clearer to you. Let's discuss another example of it. So in this slide, the image shows an example of a supervised learning process used to produce a model which is capable of recognizing the ducks in the image. The training dataset is composed of labeled picture of ducks and non-ducks. The result of supervised learning process is a predictive model which is capable of associating a label duck or not duck to the new image presented to the model. Now, once trained, the resulting predictive model can be deployed to the production environment. You can say a mobile app, for example. Once deployed, it is ready to recognize the new pictures. Right. Now you might be wondering why this category of machine learning is named as supervised learning. Well, it is called as supervised learning because the process of an algorithm learning from the training dataset can be thought of as a teacher supervising the learning process. We know the correct answers the algorithm iteratively makes while predicting on the training data and is corrected by the teacher. The learning stops when the algorithm achieves an acceptable level of performance. Now let's move on and see some of the popular supervised learning algorithms. So we have linear regression, random forest, and support vector machines. These are just for your information. We'll discuss about these algorithms in our next video. Now let's see some of the popular use cases of supervised learning. So we have Cortana. Cortana or any other speech automation in your mobile phone trains using your voice, And once trained, it start working based on that training. This is an application of supervised learning. Suppose you are telling, okay, Google, call Sam, or you say, hey Siri, call Sam. You get an answer to it, and the action is performed, and automatically a call goes to Sam. So these are just an example of supervised learning. Next comes the weather app. Based on some of the prior knowledge, like when it is sunny, the temperature is higher. When it is cloudy, humidity is higher. Any kind of that, they predict the parameters for a given time. So this is also an example of supervised learning, as we are feeding the data to the machine and telling that whenever it is sunny, the temperature should be higher. Whenever it is cloudy, the humidity should be higher. So it's an example of supervised learning. Another example is biometric attendance, where you train the machine and after a couple of inputs of your biometric identity, be it your thumb, your iris, or your earlobe, or anything, once trained, the machine can validate your future input and can identify you. Next comes in the field of banking sector. In banking sector, supervised learning is used to predict the credit worthiness of a credit card holder by building a machine learning model to look for faulty attributes by providing it with a data on delinquent and non-delinquent customers. Next comes the healthcare sector. In the healthcare sector, it is used to predict the patient's readmission rates by building a regression model by providing data on the patient's treatment administration and readmissions to show variables that best correlate with readmission. Next comes the retail sector. In retail sector, it is used to analyze the product that a customer buy together. It does this by building a supervised model to identify frequent item sets and association rule from the transactional data. Now let's learn about the next category of machine learning, the unsupervised part. Mathematically, unsupervised learning is where you only have input data X and no corresponding output variable. The goal for unsupervised learning is to model the underlying structure or distribution in the data in order to learn more about the data. So let me rephrase you this in simple terms. In unsupervised learning approach, the data instances of a training dataset do not have an expected output associated to them. Instead, unsupervised learning algorithm detects pattern based on innate characteristics of the input data. An example of machine learning task that applies unsupervised learning is clustering. In this task, similar data instances are grouped together in order to identify clusters of data. In this slide, you can see that initially we have different varieties of fruits as input. Now these set of fruits as input X are given to the model. Now once the model is trained using unsupervised learning algorithm, the model will create clusters on the basis of its training. It will group the similar fruits and make their cluster. Let me make things more clearer to you. Let's take another example of it. So in this slide, the image below shows an example of unsupervised learning process. This algorithm processes an unlabeled training dataset, and based on the characteristics, it groups the picture into 3 different clusters of data. Despite the ability of grouping similar data into clusters, the algorithm is not capable to add labels to the group. The algorithm only knows which data instances are similar, but it cannot identify the meaning of this group. So now you might be wondering why this category of machine learning is named as unsupervised learning. So these are called as unsupervised learning because unlike supervised learning, above there are no correct answers and there is no teacher. Algorithms are left on their own to discover and present the interesting structure in the data. Let's move on and see some of the popular unsupervised learning algorithm. So we have here k-means, a priori algorithm, and hierarchical clustering. Now let's move on and see some of the examples of unsupervised learning. Suppose a friend invites you to his party and where you meet totally strangers. Now you'll classify them using unsupervised learning as you don't have any prior knowledge about them. And this classification can be done on the basis of gender, age group, dressing, educational qualification, or whatever way you might like. Now why this learning is different from supervised learning? Since you didn't use any past or prior knowledge about the people, you kept on classifying them on the go. As they kept on coming, you kept on classifying them. Yeah, this category of people belong to this group, this category of people belong to that group, and so on. Okay, let's see one more example. Let's suppose you have never seen a football match before, and by chance you watch a video on the internet. Now you can easily classify the players on the basis of different criterion, like player wearing the same kind of jersey are in one class, player wearing different kind of jersey are in different class. Or you can classify them on the basis of their playing style, like the guy is an attacker, so he's in one class. He's a defender, he's in another class. Or you can classify them whatever way you observe the things. So this was also an example of unsupervised learning. Let's move on and see how unsupervised learning is used in the sectors of banking, healthcare, and retail. So starting with banking sector. So in banking sector, it is used to segment customers by behavioral characteristic by surveying prospects and customers to develop multiple segments using clustering. In healthcare sector, it is used to categorize the MRI data by normal or abnormal images. It uses deep learning techniques to build a model that learns from different features of images to recognize a different pattern. Next is the retail sector. In retail sector, it is used to recommend the products to customer based on their past purchases. It does this by building a collaborative filtering model based on the past purchases by them. I assume you guys now have a proper idea of what unsupervised learning means. If you have any slightest doubt, don't hesitate and add your doubt to the comment section. So let's discuss the third and the last type of machine learning, that is reinforcement learning. So what is reinforcement learning? Well, reinforcement learning is a type of machine learning algorithm which allows software agents and machine to automatically determine the ideal behavior within a specific context to maximize its performance. The reinforcement learning is about interaction between two elements, the environment and the learning agent. The learning agent leverages two mechanisms, namely exploration and exploitation. When learning agent acts on trial and error basis, it is termed as exploration. And when it acts based on the knowledge gained from the environment, it is referred to as exploitation. Now, this environment rewards the agent for correct actions, which is reinforcement signal. Leveraging the rewards obtained, the agent improves its environment knowledge to select the next action. In this image, you can see that the machine is confused whether it is an apple or it's not an apple. Then the machine is trained using reinforcement learning. If it makes correct decision, it gets rewards point for it. And in case of wrong, it gets a penalty for that. Once the training is done, now the machine can easily identify which one of them is an apple. Let's see an example. Here we can see that we have an agent who has to judge from the environment to find out which of the two is a duck. The first task he did is to observe the environment. Next, he selects some action using some policy. It seems that the machine has made a wrong decision by choosing a bunny as a duck. So the machine will get penalty for it. For example, minus 50 point for a wrong answer. Right. Now the machine will update its policy and this will continue till the machine gets an optimal policy. From the next time, machine will know that bunny is not a duck. Let's see some of the use cases of reinforcement learning. But before that, let's see how Pavlov trained his dog using reinforcement learning, or how he applied the reinforcement method to train his dog. Pavlov integrated learning in 4 stages. Initially, Pavlov gave meat to his dog, and in response to the meat, the dog started salivating. Next, what he did, he created a sound with the bell. For this, the dog did not respond anything. In the third part, he tried to condition the dog by using the bell and then giving him the food. Seeing the food, the dog started salivating. Eventually, a situation came when the dog started salivating just after hearing the bell, even if the food was not given to him, as the dog was reinforced that whenever the master will ring the bell, he will get the food. Now let's move on and see how reinforcement learning is applied in the field of banking, healthcare, and retail sector. So starting with the banking sector. In banking sector, reinforcement learning is used to create a next best offer model for a call center by building a predictive model that learns over time as user accept or reject offer made by the sales staff. Fine. Now in healthcare sector, it is used to allocate the scarce medical resources to handle different type of ER cases by building a Markov decision process that learns treatment strategies for each type of ER case. Next and the last comes the retail sector. So let's see how reinforcement learning is applied to retail sector. In retail sector, it can be used to reduce excess stock with dynamic pricing by building a dynamic pricing model that adjusts the price based on customer response to the offers. I hope by now you have attained some understanding of what is machine learning and you are ready to move ahead. Welcome to today's topic of discussion on AI versus machine learning versus deep learning. These are the terms which have confused a lot of people, and if you two are one among them, let me resolve it for you. Well, artificial intelligence is a broader umbrella under which machine learning and deep learning come. You can also see in the diagram that even deep learning is a subset of machine learning. So you can say that all three of them, the AI, the machine learning, and deep learning, are just the subset of each other. So let's move on and understand how exactly they differ from each other. So let's start with artificial intelligence. The term artificial intelligence was first coined in the year 1956. The concept is pretty old, but it has gained its popularity recently. But why? Well, the reason is earlier we had very small amount of data. The data we had was not enough to predict the accurate result. But now there's a tremendous increase in the amount of data. Statistics suggest that by 2020, the accumulated volume of data will increase from 4.4 zettabytes to roughly around 44 zettabytes or 44 trillion GBs of data. Along with such enormous amount of data, now we have more advanced algorithm and high-end computing power and storage that can deal with such large amount of data. As a result, it is expected that 70% of enterprise will implement AI over the next 12 months, which is up from 40% in 2016 and 51% in 2017. Just for your understanding, what is AI? Well, it's nothing but a technique that enables the machine to act like humans by replicating the behavior and nature. With AI, it is possible for a machine to learn from the experience. The machines adjust their responses based on new input, thereby performing human-like tasks. Artificial intelligence can be trained to accomplish specific tasks by processing large amount of data and recognizing pattern in them. You can consider that building an artificial intelligence is like building a church. The first church took generations to finish, so most of the workers who were working in it never saw the final outcome. Those working on it took pride in their crafts, building bricks and chiseling stone that was going to be placed into the great structure. So as AI researchers, we should think of ourselves as humble brick makers whose job is to study how to build components, example parsers, planners, or learning algorithm, or etc. anything that someday someone and somewhere will integrate into the intelligent systems. Some of the examples of artificial intelligence from our day-to-day life are Apple Series, chess playing computer, Tesla's self-driving car, and many more. These examples are based on deep learning and natural language processing. Well, this was about what is AI and how it gains its hype. So moving on ahead, let's discuss about machine learning and see what it is and why it was even introduced. Well, machine learning came into existence in the late 80s and the early 90s. But what were the issues with the people which made the machine learning come into existence? Let us discuss them one by one. In the field of statistics, the problem was how to efficiently train large complex model. In the field of computer science and artificial intelligence, the problem was how to train more robust version of AI system. While in the case of neuroscience, problem faced by the researchers was how to design operational model of the brain. So these were some of the issues which had the largest influence and led to the existence of the machine learning. Now this machine learning shifted its focus from the symbolic approaches it had inherited from the AI and moved towards the methods and model it had borrowed from statistics and probability theory. So let's proceed and see what exactly is machine learning. Well, machine learning is a subset of AI which enables the computer to act and make data-driven decisions to carry out a certain task. These programs or algorithms are designed in a way that they can learn and improve over time when exposed to new data. Let's see an example of machine learning. Let's say you want to create a system which tells the expected weight of a person based on its height. The first thing you do is you collect the data. Let's see, this is how your data looks like. Now each point on the graph represents one data point. To start with, we can draw a simple line to predict the weight based on the height. For example, a simple line W equal H minus 100, where W is weight in kgs and H is height in centimeter. This line can help us to make the prediction. Our main goal is to reduce the difference between the estimated value and the actual value. So in order to achieve it, we try to draw a straight line that fits through all these different points and minimize the error. So our main goal is to minimize the error and make them as small as possible. Decreasing the error or the difference between the actual value and estimated value increases the performance of the model. Further on, the more data points we collect, the better our model will become. We can also improve our model by adding more variables and creating different prediction lines for them. Once the line is created, so from the next time if we feed a new data, for example height of a person to the model, it would easily predict the data for you and it will tell you what his predicted weight could be. I hope you got a clear understanding of machine learning. So moving on ahead, let's learn about deep learning. Now what is deep learning? You can consider deep learning model as a rocket engine, and its fuel is its huge amount of data that we feed to these algorithms. The concept of deep learning is not new, but recently its hype has increased and deep learning is getting more attention. This field is a particular kind of machine learning that is inspired by the functionality of our brain cells called neuron, which led to the concept of artificial neural network. It simply takes the data connection between all the artificial neurons and adjusts them according to the data pattern. More neurons are added if the size of the data is large. It automatically features learning at multiple levels of abstraction, thereby allowing a system to learn complex function mapping without depending on any specific algorithm. You know what? No one actually knows what happens inside a neural network and why it works so well. So currently you can call it as a black box. Let us discuss some of the example of deep learning and understand it in a better way. Let me start with a simple example and explain you how things happen at a conceptual level. Let us try and understand how you recognize a square from other shapes. The first thing you do is you check whether there are four lines associated with the figure or not. Simple concept, right? If yes, we further check if they are connected and closed. Again, if yes, we finally check whether it is perpendicular and all its sides are equal. Correct? If everything fulfills, yes, it is a square. Well, it is nothing but a nested hierarchy of concepts. What we did here, we took a complex task of identifying a square in this case and broke it into simpler tasks. Now this deep learning also does the same thing but at a larger scale. Let's take an example of machine which recognizes the animal. The task of the machine is to recognize whether the given image is of a cat or of a dog. What if we were asked to resolve the same issue using the concept of machine learning? What we would do? First, we would define the features such as check whether the animal has whiskers or not, or check if the animal has pointed ears or not, or whether its tail is straight or curved. In short, we will define the facial features and let the system identify which features are more important in classifying a particular animal. Now, when it comes to deep learning, it takes this to one step ahead. Deep learning automatically finds out the feature which are most important for classification, compared to machine learning, where we had to manually give out that features. By now, I guess you have understood that AI is the bigger picture and machine learning and deep learning are its subpart. So let's move on and focus our discussion on machine learning and deep learning. The easiest way to understand the difference between the machine learning and deep learning is to know that deep learning is machine learning. More specifically, it is the next evolution of machine learning. Let's take few important parameters and compare machine learning with deep learning. So starting with data dependencies. The most important difference between deep learning and machine learning is its performance as the volume of the data gets increased. From the below graph, you can see that when the size of the data is small, deep learning algorithm doesn't perform that well. But why? Well, this is because deep learning algorithm needs a large amount of data to understand it perfectly. On the other hand, the machine learning algorithm can easily work with smaller data set. Fine. Next comes the hardware dependencies. Deep learning algorithms are heavily dependent on high-end machines, while the machine learning algorithm can work on low-end machines as well. This is because the requirement of deep learning algorithm include GPUs, which is an integral part of its working. The deep learning algorithm requires GPUs as they do a large amount of matrix multiplication operations, and these operations can only be efficiently optimized using a GPU as it is built for this purpose only. Our third parameter will be feature engineering. Well, feature engineering is a process of putting the domain knowledge to reduce the complexity of the data and make patterns more visible to learning algorithms. This process is difficult and expensive in terms of time and expertise. In case of machine learning, most of the features are needed to be identified by an expert and then hand-coded as per the domain and the data type. For example, the features can be a pixel value, shapes, texture, position, orientation, or anything. Fine. The performance of most of the machine learning algorithm depends on how accurately the features are identified and extracted. Whereas in case of deep learning algorithms, it try to learn high-level features from the data. This is a very distinctive part of deep learning, which makes it way ahead of traditional machine learning. Deep learning reduces the task of developing new feature extractor for every problem. Like in the case of CNN algorithm, it first tries to learn the low-level features of the image, such as edges and lines, and then it proceeds to the parts of faces of people, and then finally to the high-level representation of the face. I hope the things are getting clear to you. So let's move on ahead and see the next parameter. So our next parameter is problem solving approach. When we are solving a problem using traditional machine learning algorithm, it is generally recommended that we first break down the problem into different subparts, solve them individually, and then finally combine them to get the desired result. So this is how the machine learning algorithm handles the problem. On the other hand, the deep learning algorithm solves the problem from end to end. Let's take an example to understand this. Suppose you have a task of multiple object detection, and your task is to identify what is the object and where it is present in the image. So let's see and compare how will you tackle this issue using the concept of machine learning and deep learning. Starting with machine learning, in a typical machine learning approach, you would first divide the problem into two steps. First, object detection and then object recognition. First of all, you would use a bounding box detection algorithm like GrabCut, for example, to scan through the image and find out all the possible objects. Now, once the objects are recognized, you would use object recognition algorithm like SVM with HOG to recognize relevant objects. Now, finally, when you combine the result, you would be able to identify what is the object and where it is present in the image. On the other hand, in deep learning approach, you would do the process from end to end. For example, in a YOLONet, which is a type of deep learning algorithm, you would pass an image and it would give out the location along with the name of the object. Now let's move on to our fifth comparison parameter. It's execution time. Usually, a deep learning algorithm takes a long time to train. This is because there are so many parameters in a deep learning algorithm that makes the training longer than usual. The training might even last for 2 weeks or more than that if you're training completely from the scratch. Whereas in the case of machine learning, it relatively takes much less time to train, ranging from a few weeks to few hours. Now the execution time is completely reversed when it comes to the testing of data. During testing, the deep learning algorithm takes much less time to run. Whereas if you compare it with the KNN algorithm, which is a type of machine learning algorithm, the test time increases as the size of the data increase. Last but not the least, we have interpretability as a factor for comparison of machine learning and deep learning. This factor is the main reason why deep learning is still thought 10 times before anyone uses it in the industry. Let's take an example. Suppose we use deep learning to give automated scoring to essays. The performance it gives in scoring is quite excellent and is near to the human performance. But there's an issue with it. It does not reveal why it has given that score. Indeed, mathematically it is possible to find out that which node of a deep neural network were activated, but we don't know what the neurons were supposed to model and what these layers of neuron were doing collectively. So we fail to interpret the result. On the other hand, machine learning algorithm like decision tree gives us a crisp rule for why it chose and what it chose. So it is particularly easy to interpret the reasoning behind it. Therefore, the algorithms like decision tree and linear or logistic regression are primarily used in industry for interpretability. Let me summarize things for you. Machine learning uses algorithm to parse the data, learn from the data, and make informed decision based on what it has learned. Fine. Now this deep learning structures algorithms in layers to create artificial neural network that can learn and make intelligent decisions on their own. Finally, deep learning is a subfield of machine learning, while both fall under the broad category of artificial intelligence. Deep learning is usually what's behind the most human-like artificial intelligence.
Now, in early days, scientists used to have a lab notebook to record tests, progress, results, and conclusions. Now, Jupyter is a modern-day tool that allows data scientists to record their complete analysis process, much in the same way other scientists use a lab notebook. Now, the Jupyter product was originally developed as a part of IPython project. The IPython project was used to provide interactive online access to Python. Over time, it became useful to interact with other data analysis tools such as R in the same manner. With the split from Python, the tool grew into its current manifestation of Jupyter. Now, IPython is still an active tool that's available for use. The name Jupyter itself is derived from the combination of Julia, Python, and R. While Jupyter runs code in many programming languages, Python is a requirement for installing the Jupyter Notebook itself. Now, to download Jupyter Notebook, there are a few ways. In their official website, it is strongly recommended installing Python and Jupyter using Anaconda distribution. which includes Python, the Jupyter Notebook, and other commonly used packages for scientific computing as well as data science. Although one can also do so using the pip installation method. Personally, what I would suggest is downloading Anaconda Navigator, which is a desktop graphical user interface included in Anaconda. Now, this allows you to launch application and easily manage Conda packages, environments, and channels without the need to use command line commands. So all you need to do is go to anaconda.org, and inside you go to Anaconda Navigator. So as you can see here, we have the Conda installation code, which you're going to use to install it in your particular PC. So either you can use these installers. So once you download the Anaconda Navigator, it looks something like this. So as you can see here, we have Jupyter Lab, Jupyter Notebook, we have Qt Console, which is IPython console. We have Spyder, which is somewhat similar to RStudio in terms of Python. Again, we have RStudio also, we have Orange 3, we have GlueWiz, and we have VS Code. Our focus today would be on this Jupyter Notebook itself. Now, when you launch the Navigator, you can see there are many options available for launching Python as well as R instances. Now, by definition, a Jupyter Notebook is fundamentally a JSON file with a number of annotations. Now, it has three main parts, which are the metadata, the notebook format, and the list of cells. Now, you should get yourself acquainted with the environment. The Jupyter user interface has a number of components. So it's important to know what all components you should be using on a daily basis, and you should get acquainted with it. So as you can see here, our focus today will be on the Jupyter Notebook. So let me just launch the Jupyter Notebook. Now what it does is creates an online Python instance for you to use it over the web. So let it launch. Now as you can see, we have Jupyter on the top left as expected. And this acts as a button to go to your home page. Whenever you click on this, you get back to your particular home page, that is the dashboard. Now there are three tabs displayed, which are the files, running, and clusters. And what we'll do is we'll understand all of these three and understand what are the importance of these three tabs. The file tab shows the list of the current files in the directory. So as you can see, we have so many files here. Now the running tab presents another screen of the currently running processes and the notebooks. Now the drop-down list for the terminals and notebooks are populated with their running numbers. So as you can see inside, we do not have any running terminals, or there are no running notebooks as of now. And the cluster tab presents another screen to display the list of clusters available. So in the top right corner of the screen, there are three buttons, which are upload, new, and the refresh button. Let me go back here. So as you can see here, we have the upload, new, and the refresh button. Now the upload button is used to add files to the notebook space, and you may also just drag and drop as you would when handling files. Similarly, you can drag and drop notebooks into specific folders as well. Now the menu with the new in the top presents a further menu of text file, folders, terminal, and Python 3. Now the text file option is used to add a text file to the current directory. Now Jupyter will open a new browser window for you for the running new text editor. Now the text entered is automatically saved and will be displayed in your notebook's files display. Now the folder option, what it does is creates a new folder with the name untitled folder, and remember, all the files and folder names are editable. Now the terminal option allows you to start an IPython session. The notebook options available will be activated when additional notebooks are available in your environment. The Python 3 option is used to begin Python 3 session interactively in your notebook. The interface looks like the following screenshot. Now what you have is full file editing capabilities for your script, including saving as new file. You also have a complete working ID for your Python script. Now if we come to the refresh button, the refresh button is used to update the display. It's not really necessary as the display is reactive to any changes in the underlying file structure. And at the top of the Files tab item, there is a checkbox, a drop-down menu, and a home button. As you can see here, we have the checkbox, the drop-down menu, and the home button. Now the checkbox is used to toggle all the checkboxes in the item list. So as you can see, you can select all of these. You can either move or either delete all of the files selected, or what you can do is select all and deselect some of the files. That's your wish. Now the drop-down menu presents a list of choices available, which are the folders, all notebooks, running, and files. So the folder section will select all the folders in the display and present a count of the folders in the small box. So as you can see here, we have 18 number of folders. Now all the notebook section will change the count of the number of notebooks and provide you with three options. So you can see here it has selected all the given notebooks, which are 18 in number, and you get the option to either duplicate the current notebook, you need to move it, view it, edit it, or delete it. Now the running section will select any running scripts. As you can see here, we have 0 running scripts and update the count to the number selected. Now the files section will select all the files in the notebook display and update the counts accordingly. So if you select the files here, we have 7 files. As you can see here, we have 7 files, some data sets, CSV files, and text files. Now the home button brings you back to the home screen of the notebook. So all you need to do is click on the Jupyter Notebook logo. It will bring you back to the Jupyter Notebook dashboard. Now, as you can see on the left hand side of every item is a checkbox, an icon, and the item's name. The checkbox is used to build a set of files to operate upon, and the icon is indicative of the type of the item. And in this case, all of the items are folder here. Coming down, we have the running notebooks, and finally we have certain files, which are the text files and the CSV files. Now, a typical workflow of any Jupyter notebook is to first of all create a notebook for the project or your data analysis, add your analysis step, coding and output, and surround your analysis with organization and presentation markdown to communicate an entire story. Now, interactive notebooks that include widgets and display modules would then be used by others by modifying parameters and the data to note the effects of their changes. Now, if we talk about security, Jupyter notebooks are created in order to be shared with other users, in many cases over the internet. However, Jupyter Notebook can execute arbitrary code and generate arbitrary code. This can be a problem if malicious aspects have been placed in the notebook. Now, the default security mechanism for Jupyter notebooks include raw HTML, which is always sanitized and checked for malicious coding. Another aspect is you cannot run external JavaScripts. Now, the cell contents, especially the HTML and the JavaScripts, are not trusted. It requires user validation to continue, and the output from any cell is not trusted. All other HTML or JavaScript is never trusted, and clearing the output will cause the notebook to become trusted when saved. Now, notebooks can also use a security digest to ensure the correct user is modifying the contents. So for that, what you need to do is a digest. What it does is takes into the account the entire contents of the notebook and a secret which is only known by the notebook creator. Now, this combination ensures that malicious coding is not going to be added to the notebook. So you can add security digest to notebook using the following command, which I have given here. So it's Jupyter, the profile, what you have selected, and inside what you need to do is security and notebook secret. So what you can do is replace the notebook secret with your part of the secret, and that will act as a key for the particular notebook. So what you need to do is share that particular key with all your colleagues or whoever you want to share that particular notebook with. And in that case, it keeps the notebook secured and away from other malicious coders and all. Another aspect of Jupyter is configuration. So you can configure some of the display parameters used when presenting notebooks. Now, these are configurable due to the use of product known as CodeMirror to present and modify the notebook. So CodeMirror, what it basically is, it is a JavaScript based editor for the use within the web pages and notebooks. So what you do is CodeMirror. So as you can see here, CodeMirror is a versatile text editor implemented in JavaScript for the browser. So what it does is allow you to configure the options for Jupyter. So now let's execute some Python code and understand the notebook in a better way. Jupyter does not interact with your scripts as much as it executes your script and records the result. So I think this is how Jupyter notebooks have been extended to other languages besides Python, as it just takes a script, runs it against a particular language engine, and records the output from the engine, all the while not really knowing what kind of a script is being executed. Now the new window shows an empty cell for you to enter the Python code. Now what you need to do is under new, you select the Python 3. And what it will do is open a new notebook. Now this notebook is untitled, so let's give the new work area a name Python code. So as you can see, we have renamed this particular cell. Now autosave option should be on the next to the title. As you can see, last checkpoint a few days ago, unsaved changes. The autosave option is always on. What we do is with an accurate name, we can find the selection and this particular notebook very easily from the notebook homepage. So if you select your browser's home tab and refresh, you will find this new window name displayed here again. So if you just go to the notebook home, and as you can see, I mentioned it, Python codes. And under running also you have the Python codes here. So let's get back to the particular page or the notebook. One thing to note here that it has an item icon versus a folder icon. The automatically assigned extension, as you can see here, is IPYNB, the IPython node. And since the item is in a browser in a Jupyter environment, it is marked as running. And there is a file by that name in your directory as well. So if you go to your directory, let me go and check it. So as you can see, if you go into the users, here you can see we have the in-class projects, the Python codes. So you can see we automatically have that particular IPython notebook created in our working environment and the local disk space also. So if you open the IPYNB file in the text editor, you will see basic context of a Jupyter code. As you can see, if I'm opening it, the cells are empty, nothing is there. So let's type in some code here. So for example, I'm going to put in name equals Edureka. Next, what I'm going to do is provide subscribers that equals 700k. And to run this particular cell, what you need to do is click on the run icon. And as you can see here, we have 1. So this is the first cell to be executed. In the second cell, we enter Python code that references the variables from the first cell. So as you can see here, we have print name has string subscribers. So let me just run this particular. So as you can see here, note that we have an output here that Edureka has 700k YouTube subscriber now. So it's more than 700k. Now, to know more about Jupyter and other technologies, what you can do is subscribe to our channel and get updates on the latest trending technologies. So note that Jupyter color codes your Python just as a decent editor would, and we have empty braces to the left of each code block. So as you can see here, if we execute the cell, the results are displayed in line. Now it's interesting that Jupyter keeps track of the output last generated in the saved version of the file and is a saved checkpoints. Now if you were to rerun your cells using the rerun or the run all, the output would be generated and saved via autosave. Now the cell number is incremented, and as you can see, if I rerun this, you see the cell number changed from 1 to 3, and if I rerun this, the cell number will change from 2 to 4. So what Jupyter does is keeps a track of the latest version of each cell. So similarly, if you were to close the browser tab, refresh the display in the home tab, you will find a new item we created, which is the Python code. Yeah, notebook saved, auto saved. As you can see here in the bracket, it has auto saved. So if we close this in the home button, you can see here we have Python codes. So as you can see, if we click it, it opens the same notebook. It has the previously displayed items will be always there, showing the outputs that we generated in the last run. Now that we have seen how Python works in Jupyter, including the underlying encoding, then how does Python access a last dataset or a dataset work in Jupyter? So let me create another new Python notebook. So what I'm going to do is name this as pandas. So from here, what we'll do is read in last dataset and compute some standard statistics of data. Now what we are interested in seeing how to use the pandas in Jupyter, how well the script performs, and what information is stored in the metadata, especially if it's a large dataset. So our Python script accesses the iris dataset here that's built into one of the Python packages. Now all we are looking into to do is to read in slightly large number of items and calculate some basic operations on the dataset. So first of all, what we need to do is from sklearn, import the dataset. So sklearn is scikit-learn, and it is another library of Python. It contains a lot of datasets for machine learning and all the algorithms which are present for machine learning and the datasets which are there. So our import was successful. So what we're going to do now is pull in the iris data. What we're going to do is iris underscore dataset equals dataset dot load underscore iris. Now this should do, and I'm sorry, it's datasets.load. So as you can see here, the number here is considered 3 now because in the second run we encountered an error. It was dataset, not dataset. So what we're gonna do is grab the first 2 columns of the data. So let's pretend x equals. If you press the tab, it automatically detects what you're gonna write as .datasets.data, and what we're gonna do is take the first 2 rows, comma. Now to run it from your keyboard, all you need to do is press Shift and Enter. So next what we're going to do is calculate some basic statistics. So what we're going to do is x underscore count equals x. We're going to use the length function. I said that we're going to use x dot flat. Similarly, we're going to see x min and x max and the mean. Now to display our results, what we're going to do is display the results now. So as you can see, the count is 300. The minimum value is 3.8, the maximum value is 8.4, and the mean is 5.84333.
So let me connect you to the real life and tell you what all are the things which you can easily do using the concepts of machine learning. So you can easily get answer to the questions like which types of house lies in this segment, or what is the market value of this house, or is this a mail, a spam, or not a spam? Is there any fraud? Well, these were some of the questions you could ask to the machine. But for getting an answer to these, you need some algorithm. The machine need to train on the basis of some algorithm. Okay, but how will you decide which algorithm to choose and when? Okay, so the best option for us is to explore them one by one. So the first is classification algorithm, where the category is predicted using the data. If you have some question like, is this person a male or a female? Or is this a male a spam or not a spam? Then these category of question would fall under the classification algorithm. Classification is a supervised learning approach in which the computer program learns from the input given to it and then uses this learning to classify new observation. Some examples of classification problems are speech recognition, handwriting recognition, biometric identification, document classification, etc. So next is the anomaly detection algorithm, where you identify the unusual data point. So what is anomaly detection? Well, it's a technique that is used to identify unusual patterns that do not conform to expected behavior, or you can say the outliers. It has many applications in business, like intrusion detection, like identifying strange patterns in the network traffic that could signal a hack, or system health monitoring, that is spotting a deadly tumor in the MRI scan. Or you can even use it for fraud detection in credit card transaction, or to deal with fault detection in operating environment. So next comes the clustering algorithm. You can use this clustering algorithm to group the data based on some similar condition. Now you can get answer to which type of houses lies in this segment or what type of customer buys this product. The clustering is the task of dividing the population or data points into a number of groups such that the data point in the same groups are more similar to other data points in the same group than those in the other groups. In simple words, the aim is to segregate groups with similar trait and assign them into cluster. Now this clustering is a task of dividing the population or data points into a number of groups such that the data points in the X group is more similar to the other data points in the same group rather than those in the other group. In other words, the aim is to segregate the groups with similar traits and assign them into different clusters. Let's understand this with an example. Suppose you're the head of a rental store and you wish to understand the preference of your customer to scale up your business. So is it possible for you to look at the detail of each customer and design a unique business strategy for each of them? Definitely not, right? But what you can do is to cluster all your customer, say into 10 different groups based on their purchasing habit, and you can use a separate strategy for customers in each of these 10 different groups. And this is what we call clustering. Next, we have regression algorithm, where the data itself is predicted. Question you may ask to this type of model is like, what is the market value of this house? Or is it going to rain tomorrow or not? So regression is one of the most important and broadly used machine learning and statistics tool. It allows you to make prediction from data by learning the relationship between the features of your data and some observed continuous valued response. Regression is used in a massive number of applications. You know what? Stock prices prediction can be done using regression. Now you know about different machine learning algorithm. How will you decide which algorithm to choose and when? So let's cover this part using a demo. So in this demo part, what we'll do, we'll create 6 different machine learning model and pick the best model and build the confidence such that it has the most reliable accuracy. So for our demo part, we'll be using the IRIS dataset. This dataset is quite very famous and is considered one of the best small project to start with. You can consider this as a hello world dataset for machine learning. So this dataset consists of 150 observation of iris flower. There are 4 columns of measurement of flowers in centimeters, the 5th column being the species of the flower observed. All the observed flowers belong to one of the 3 species of Iris setosa, Iris virginica, and Iris versicolor. Well, this is a good project because it is so well to understand. The attributes are numeric, so you have to figure out how to load and handle the data. It is a classification problem, thereby allowing you to practice with perhaps an easier type of supervised learning algorithm. It has only 4 attributes and 150 rows, meaning it is very small and can easily fit into the memory. And even all of the numeric attributes are in the same unit and the same scale. It means you do not require any special scaling or transformation to get started with. So let's start coding, and as I told earlier, for the demo part, I'll be using Anaconda with Python 3.0 installed on it. So when you install Anaconda, how your navigator would look like. So this is my homepage of my Anaconda navigator. On this, I'll be using the Jupyter Notebook, which is a web-based interactive computing notebook environment, which will help me to write and execute my Python codes on it. So let's hit the launch button and execute our Jupyter Notebook. So as you can see that my Jupyter Notebook is starting on localhost 8890. Okay, so this is my Jupyter Notebook. What I'll do here, I'll select new notebook Python 3. This is my environment where I can write and execute all my Python codes on it. So let's start by checking the version of the libraries. In order to make this video short and more interactive and more informative, I've already written the set of code. So let me just copy and paste it down. I'll explain you then one by one. So let's start by checking the version of the Python libraries. Okay, so there's the code. Let's just copy it, and let's paste it. Okay, first let me summarize things for you. What we are doing here, we are just checking the version of the different libraries. Starting with Python, we'll first check what version of Python we are working on. Then we'll check what are the version of SciPy we are using. Then NumPy, Matplotlib, then Panda, then scikit-learn. Okay, so let's execute the run button and see what are the various versions of the libraries which we are using. Hit the run. So we are working on Python 3.6.4, SciPy 1.0, NumPy 1.14, Matplotlib 2.12, Pandas 0.22, and scikit-learn of version 0.19. Okay, so these are the version which I'm using. Ideally, your version should be more recent or it should match. But don't worry if you lag few versions behind, as the APIs do not change so quickly. Everything in this tutorial will very likely still work for you. Okay, but in case you are getting an error, stop and try to fix that error. In case you are unable to find the solution for the error, feel free to reach out Edureka even after this class. Let me tell you this, if you're not able to run the script properly, you will not be able to complete this tutorial. Okay, so whenever you get a doubt, reach out to Edureka and just resolve it. Now if everything is working smoothly, then now it's the time to load the dataset. So as I said, I'll be using the Iris Flower dataset for this tutorial. But before loading the dataset, let's import all the modules, function, and the object which we are going to use in this tutorial. Same, I've already written the set of code, so let's just copy and paste them. Let's load all the libraries. So these are the various libraries which we'll be using in our tutorial. So everything should work fine without an error. If you get an error, just stop. You need to work on your SciPy environment before you continue any further. So I guess everything should work fine. Let's hit the run button and see. Okay, it worked. So let's now move ahead and load the data. We can load the data direct from the UCI machine learning repository. First of all, let me tell you, we are using Panda to load the data. Okay, so let's say my URL is this. So this is my URL for the UCI machine learning repository from where I'll be downloading the data set. Okay. Now what I'll do, I'll specify the name of each column when loading the data. This will help me later to explore the data. Okay. So I'll just copy and paste it down. Okay. So I'm defining a variable names which consist of various parameters including sepal length, sepal width, petal length, petal width, and class. So these are just the name of column from the data set. Okay. Now let's define the data set. So dataset equals panda.read_csv. Inside that, we are defining URL and the names that is equal to name. As I already said, we'll be using Panda to load the data. All right. So we are using panda.read_csv. So we are reading the CSV file, and inside that, from where that CSV is coming from the URL. Which URL? So this is my URL. Okay. And names equal names. It's just specifying the names of that various columns in that particular CSV file. Okay. So let's move forward and execute it. So even our data set is loaded. In case you have some network issues, just go ahead and download the Iris data file into your working directory and load it using the same method. But yeah, make sure that you change the URL to the local name or else you might get an error. Okay. Yeah, our data set is loaded. So let's move ahead and check our data set. Let's see how many columns or rows we have in our data set. Okay. So let's print the number of rows and columns in our data set. So our data set is dataset.shape. What this will do, it will just give you the numbers of total number of rows and total number of column, or you can say the total number of instances or attributes in your data set. Fine. So print dataset.shape. What you're getting? 150 and 5. So 150 is the total number of rows in your dataset and 5 is the total number of columns. Fine. So moving on ahead, what if I want to see the sample dataset? Okay. So let me just print the first 30 instances of the dataset. Okay. So print dataset.head. What I want is the first 30 instances. Fine. This will give me the first 30 result of my data set. Okay. So when I hit the run button, what I'm getting is the first 30 result. Okay. 0 to 29. So this is how my sample data set looks like. Sepal length, sepal width, petal width, and the class. Okay. So this is how our data set looks like. Now let's move on and look at the summary of each attribute. What if I want to find out the count, mean, the minimum and the maximum values and some other percentiles as well? So what should I do then? For that, print dataset.describe. What it will give, let's see. So you can see that all the numbers are the same scales of similar range between 0 to 8 centimeters, right? The mean value, the standard deviation, the minimum value, the 25 percentile, 50 percentile, 75 percentile, the maximum value, all these values lies in the range between 0 to 8 centimeter. Okay. So what we just did is we just took a summary of each attribute. Now let's look at the number of instances that belong to each class. So for that, what we'll do, print dataset first of all. So let's print dataset and I want to group it, group by using class, and I want the size of it, size of each class. Fine. And let's hit the run. Okay, so what I want to do, I want to print what? Data set. How I want to get it? I want it by class. So group by class. Okay, now I want the size of each class. Find the size of each class. So group by class dot size. Execute the run. So you can see that I have 50 instances of Iris setosa, 50 instances of Iris versicolor, and 50 instances of Iris virginica. Okay, all are of data type integer of base 64. Fine. So now we have a basic idea of our data. Now let's move ahead and create some visualization for it. So for this, we are going to create two different types of plot. First would be the univariate plot and the next would be the multivariate plot. So we'll be creating univariate plots to better understand about each attribute. And the next we'll be creating the multivariate plot to better understand the relationship between different attributes. Okay, so we start with some univariate plot, that is plot of each individual variable. So given that the input variables are numeric, we can create box and whiskers plot for it. Okay, so let's move ahead and create a box and whiskers plot. So dataset.plot, what kind I want? It's a box. Okay, and do I need a subplot? Yeah, I need subplots for that. So subplots equal true. What type of layout do I want? So my layout structure is 2 cross 2. Next, do I want to share my coordinates, x and y coordinates? No, I don't want to share it. So share x equal false. And even share y, that too equals false. Okay, so we have here dataset.plot kind equal box. My subplots is true, layout 2 cross 2. And then what I want to do it, I want to see it. So plot dot show, whatever I created, show it. Okay, execute it. Now this gives us a much clearer idea about the distribution of the input attribute. Now what if I had given the layout to 2 cross 2? Instead of that, I would have given it 4 cross 4. So what it will result, just see. Fine, everything would be printed in just one single row. Hold on guys, Arya has a doubt. He's asking that why we are using the share x and share y values. What are these? Why we have assigned false values to it? Okay Arya, so in order to resolve this query, I need to show you what will happen if I give true values to them. Okay, so be with me. So share x equal true and share y that equals true. So let's see what result we'll get. You're getting it. The x and y coordinates are just shared among all the 4 visualization, right? So Arya, you can see that the sepal length and sepal width has y values ranging from 0.0 to 7.5, which are being shared among both the visualization. So is with the petal length, it has a shared value between 0.0 to 7.5. Okay, so that is why I don't want to share the value of x and y. So it's just giving us a cluttered visualization. So Arya, why I'm doing this? I'm just doing it because I don't want my x and y coordinates to be shared among any visualization. Okay, that is why my share x and share y value are false. Okay, let's execute it. So this is a Pretty much clear visualization, which gives a clear idea about the distribution of the input attributes. Now, if you want, you can also create a histogram of each input variable to get a clear idea of the distribution. So let's create a histogram for it. So dataset.hist. Okay, I would need to see it. So plot.show. Let's see. So there's my histogram, and it seems that we have two input variables that have a Gaussian distribution. So this is useful to note as we can use the algorithms that can exploit this assumption. Okay, so next comes the multivariate plot. Now that we have created the univariate plot to understand about each attribute, let's move on and look at the multivariate plot and see the interaction between the different variables. So first, let's look at the scatter plot of all the attributes. This can be helpful to spot structured relationship between input variables. Okay, so let's create a scatter matrix. So for creating a scatter plot, we need scatter matrix, and we need to pass our data set into it. Okay, and then what I want to see it. So plot.show. So this is how my scatter matrix looks like. It's like that the diagonal grouping of some pair, right? So this suggests a high correlation and a predictable relationship. All right, this was our multivariate plot. Now let's move on and evaluate some algorithm. Now it's time to create some model of the data and estimate their accuracy on the basis of unseen data. Okay, so now we know all about our data set, right? We know how many instances and attributes are there in our data set. We know the summary of each attribute. Now I guess we have seen much about our data set. Now let's move on and create some algorithm and estimate their accuracy based on the unseen data. Okay, now what we'll do, we'll create some model of the data and estimate their accuracy based on some unseen data. Okay, so for that, first of all, let's create a validation data set. What is a validation data set? Validation data set is your training data set that will be using it to train our model. Fine. All right, so how we'll create a validation data set? For creating a validation data set, what we are going to do is we are going to split our data set into two parts. Okay, so the very first thing we'll do is to create a validation data set. So why do we even need a validation data set? So we need a validation data set to know that the model we created is any good. Later, what we'll do, we'll use the statistical method to estimate the accuracy of the model that we create on the unseen data. We also want a more concrete estimate of the accuracy of the best model on unseen data by evaluating it on the actual unseen data. Okay, confused? Let me simplify this for you. What we'll do, we'll split the loaded data into two parts. The first 80% of the data, we'll use it to train our model, and the rest 20% will hold back as the validation data set that will use it to verify our trained model. Okay, fine. So let's define an array. This is my array. What it will consist of? It will consist of all the values from the dataset. So dataset dot values. Okay. Next, I'll define a variable x, which will consist of all the column from the array from 0 to 4, starting from 0 to 4. And the next variable y, which would consist of the array starting from this. So first of all, we'll define a variable x that will consist of the values in the array starting from the beginning 0 till 4. Okay, so these are the column which will include in the x variable. And for a y variable, I'll define it as a class or the output. So what I just need the fourth column, that is my class column. So I'll start it from the beginning and I just want the fourth column. Okay, now I'll define my validation size, validation underscore size. I'll define it as 0.20 and I'll use a seed. I'll define seed equals 6. So this method seed sets the integer starting value used in generating random number. Okay, I'll define the value of seed equals 6. I'll tell you what is the importance of it later on. Okay, so let me define first few variables such as x underscore train test, y underscore train, and y underscore test. Okay, so what we want to do is select some model. Okay, so model underscore selection. But before doing that, what we have to do is split our training data set into two halves. Okay, so dot train underscore test underscore split. What we want to split is the value of x and y. Okay, and my test size is equals to validation size, which is a 0.20, correct? And my random state is equal to seed. So what the seed is doing here, it's helping me to keep the same randomness in the training and testing data set. Fine. So let's execute it and see what is our result. It's executed. Next, we'll create a test harness. For this, we'll use 10-fold cross validation to estimate the accuracy. So what it will do, it will split our data set into 10 parts, train on the 9 part and test on the 1 part. And this will repeat for all combination of train and test splits. Okay. So for that, let's define again my seed, that was 6 already defined, and scoring equals accuracy. Fine. So we are using the metric of accuracy to evaluate the model. So what is this? This is a ratio of number of correctly predicted instances divided by the total number of instances in the data set multiplied by 100, giving a percentage. Example, it's 98% accurate or 99% accurate, things like that. Okay. So we'll be using this scoring variable when we run the build and evaluate each model in the next step. So our next part is building model. Till now, we don't know which algorithm would be good for this problem or what configuration to use. So let's begin with 6 different algorithms. I'll be using logistic regression, linear discriminant analysis, k-nearest neighbor, classification and regression trees, naive Bayes, and support vector machine. Well, these algorithms which I'm using is a good mixture of simple linear or non-linear algorithms. In simple linears, which included the logistic regression and the linear discriminant analysis, or the non-linear part, which included the KNN algorithm, the CART algorithm, the naive Bayes, and the support vector machines. Okay, so we reset the random number seed before each run to ensure that evaluation of each algorithm is performed using exactly the same data splits. It ensures the results are directly comparable. Okay, so let me just copy and paste it. Okay. So what we are doing here, we are building 5 different types of model. We are building logistic regression, linear discriminant analysis, k-nearest neighbor, decision tree, Gaussian naive Bayes, and the support vector machine. Okay. Next, what we'll do, we'll evaluate model in each turn. Okay. So what is this? So we have 6 different model and accuracy estimation for each one of them. Now we need to compare the model to each other and select the most accurate of them all. So running this script, we saw the following result. So we can see some of the result on the screen. What is this? It is just the accuracy score using different set of algorithms. Okay, when we are using logistic regression, what is the accuracy rate? When we are using linear discriminant algorithm, what is the accuracy, and so and so. Okay, so from the output, it seems that LDA algorithm was the most accurate model that we tested. Now we want to get an idea of the accuracy of the model on our validation set or the testing data set. So this will give us an independent final check on the accuracy of the best model. It is always valuable to keep a testing data set for just in case you made a overfitting to the testing data set or you made a data leak. Both will result in an overly optimistic result. Okay. You can run the LDA model directly on the validation set and summarize the result as a final score, a confusion matrix, and a classification report.
Statistics and probability are essential because these disciples form the basic foundation of all machine learning algorithms, deep learning, artificial intelligence, and data science. In fact, mathematics and probability is behind everything around us. From shapes, patterns, and colors to the count of petals in a flower, mathematics is embedded in each and every aspect of our lives. So I'm going to go ahead and discuss the agenda for today with you all. We're going to begin this session by understanding what is data. After that, we'll move on and look at the different categories of data like quantitative and qualitative data. Then we'll discuss what exactly statistics is, the basic terminologies in statistics, and a couple of sampling techniques. Once we're done with that, we'll discuss the different types of statistics which involve descriptive and inferential statistics. Then in the next session, we'll mainly be focusing on descriptive statistics. Here we'll understand the different measures of center, measures of spread, information gain, and entropy. We'll also understand all of these measures with the help of a use case. And finally, we'll discuss what exactly a confusion matrix is. Once we've covered the entire descriptive statistics module, we'll discuss the probability module. Here we'll understand what exactly probability is, the different terminologies in probability. We'll also study the different probability distributions. Then we'll discuss the types of probability, which include marginal probability, joint, and conditional probability. Then we'll move on and discuss a use case wherein we'll see examples that show us how the different types of probability work. And to better understand Bayes' theorem, we'll look at a small example. Also, I forgot to mention that at the end of the descriptive statistics module, we'll be running a small demo in the R language. So for those of you who don't know much about R, I'll be explaining every line in depth. But if you want to have a more in-depth understanding about R, I'll leave a couple of blogs and a couple of videos in the description box. You all can definitely check out that content. Now, after we've completed the probability module, we'll discuss the inferential statistics module. We'll start this module by understanding what is point estimation. We'll discuss what is confidence interval and how you can estimate the confidence interval. We'll also discuss margin of error, and we'll understand all of these concepts by looking at a small use case. We'll finally end the inferential statistic module by looking at what hypothesis testing is. Hypothesis testing is a very important part of inferential statistics. So we'll end the session by looking at a use case that discusses how hypothesis testing works. And to sum everything up, we'll look at a demo that explains how inferential statistics works. All right, so guys, there's a lot to cover today. So let's move ahead and take a look at our first topic, which is what is data. Now, this is a quite simple question. If I ask any of you what is data, you'll say that it's a set of numbers or some sort of documents that I've stored in my computer. Now, data is actually everything. All right, look around you. There is data everywhere. Each click on your phone generates more data than you know. Now, this generated data provides insights for analysis and helps us make better business decisions. This is why data is so important. To give you a formal definition, data refers to facts and statistics collected together for reference or analysis. All right, this is the definition of data in terms of statistics and probability. So as we know, data can be collected, it can be measured and analyzed, it can be visualized by using statistical models and graphs. Now, data is divided into two major subcategories. All right. So first we have qualitative data and quantitative data. These are the two different types of data. Under qualitative data, we have nominal and ordinal data, and under quantitative data, we have discrete and continuous data. Now let's focus on qualitative data. Now this type of data deals with characteristics and descriptors that can't be easily measured but can be observed subjectively. Now qualitative data is further divided into nominal and ordinal data. So nominal data is any sort of data that doesn't have any order or ranking. Okay. An example of nominal data is gender. Now there is no ranking in gender. There's only male, female, or other, right? There is no 1, 2, 3, 4, or any sort of ordering in gender. Race is another example of nominal data. Now, ordinal data is basically an ordered series of information. Okay, let's say that you went to a restaurant. Okay, your information is stored in the form of customer ID. All right, so basically you are represented with a customer ID. Now, you would have rated their service as either good or average. All right, that's how ordinal data is. And similarly, they'll have a record of other customers who visit the restaurant along with their ratings. All right. So any data which has some sort of sequence or some sort of order to it is known as ordinal data. All right. So guys, this is pretty simple to understand. Now let's move on and look at quantitative data. So quantitative data basically deals with numbers and things. Okay. You can understand that by the word quantitative itself. Quantitative is basically quantity, right? So it deals with numbers. It deals with anything that you can measure objectively. All right. So there are two types of quantitative data. There is discrete and continuous data. Now, discrete data is also known as categorical data, and it can hold a finite number of possible values. Now, the number of students in a class is a finite number. All right, you can't have infinite number of students in a class. Let's say in your fifth grade, there were 100 students in your class. All right, there weren't infinite number, but there was a definite finite number of students in your class. Okay, that's discrete data. Next, we have continuous data. Now, this type of data can hold infinite number of possible values. Okay, so when you say weight of a person is an example of continuous data, what I mean to say is my weight can be 50 kgs, or it can be 50.1 kgs, or it can be 50.001 kgs, or 50.0001, or it's 50.023, and so on, right? There are infinite number of possible values. Right? So this is what I mean by continuous data. All right, this is the difference between discrete and continuous data. And also I'd like to mention a few other things over here. Now, there are a couple of types of variables as well. All right, we have a discrete variable and we have a continuous variable. Discrete variable is also known as a categorical variable. All right, it can hold values of different categories. Let's say that you have a variable called a message. And there are two types of values that this variable can hold. Let's say that your message can either be a spam message or a non-spam message. Okay, that's when you call a variable as discrete or categorical variable. All right, because it can hold values that represent different categories of data. Now, continuous variables are basically variables that can store infinite number of values. So the weight of a person can be denoted as a continuous variable. All right, let's say there is a variable called weight and it can store infinite number of possible values. That's why we'll call it a continuous variable. So guys, basically variable is anything that can store a value, right? So if you associate any sort of data with a variable, then it will become either discrete variable or continuous variable. There is also dependent and independent type of variables. Now we won't discuss all of that in depth because that's pretty understandable. I'm sure all of you know what is independent variable and dependent variable, right? Dependent variable is any variable whose value depends on any other independent variable. So guys, that much knowledge I expect all of you to have. All right. So now let's move on and look at our next topic, which is what is statistics. Now coming to the formal definition of statistics, statistics is an area of applied mathematics which is concerned with data collection, analysis, interpretation, and presentation. Now, usually when I speak about statistics, people think statistics is all about analysis. But statistics has other parts to it. It has data collection is also a part of statistics. Data interpretation, presentation, visualization, all of this comes into statistics. All right, you're going to use statistical methods to visualize data, to collect data, to interpret data. All right. So the area of mathematics deals with understanding how data can be used to solve complex problems. Okay. Now I'll give you a couple of examples that can be solved by using statistics. Okay, let's say that your company has created a new drug that may cure cancer. How would you conduct a test to confirm the drug's effectiveness? Now, even though this sounds like a biology problem, this can be solved with statistics. All right, you will have to create a test which can confirm the effectiveness of the drug. All right, this is a common problem that can be solved using statistics. Let me give you another example. You and a friend are at a baseball game, and out of the blue, he offers you a bet that neither team will hit a home run in that game. Should you take the bet? All right, here you'll just discuss the probability of whether you'll win or lose. All right, this is another problem that comes under statistics. Let's look at another example. The latest sales data has just come in, and your boss wants you to prepare a report for management on places where the company could improve its business. What should you look for and what should you not look for? Now, this problem involves a lot of data analysis. You'll have to look at the different variables that are causing your business to go down, or that you have to look at a few variables that are increasing the performance of your models and thus growing your business. All right. So this involves a lot of data analysis, and the basic idea behind data analysis is to use statistical techniques in order to figure out the relationship between different variables or different components in your business. Okay. So now let's move on and look at our next topic, which is basic terminologies in statistics. Now, before you dive deep into statistics, it is important that you understand the basic terminologies used in statistics. The two most important terminologies in statistics are population and sample. So throughout the statistics course or throughout any problem that you're trying to solve with statistics, you will come across these two words, which is population and sample. Now, population is a collection or a set of individuals or objects or events whose properties are to be analyzed. Okay, so basically you can refer to population as a subject that you're trying to analyze. Now, a sample is just like the word suggests, it's a subset of the population. So you have to make sure that you choose the sample in such a way that it represents the entire population. All right, it shouldn't focus at one part of the population. Instead, it should represent the entire population. That's how your sample should be chosen. So a well-chosen sample will contain most of the information about a particular population parameter. Now you must be wondering, how can one choose a sample that best represents the entire population? Now, sampling is a statistical method that deals with the selection of individual observations within a population. So sampling is performed in order to infer statistical knowledge about a population. All right, if you want to understand the different statistics of a population, like the mean, the median, the mode, or the standard deviation, or the variance of a population, then you're going to perform sampling. All right, because it's not reasonable for you to study a large population and find out the mean, median, and everything else. So why is sampling performed? You might ask, what is the point of sampling? We can just study the entire population. Now, guys, think of a scenario wherein you're asked to perform a survey about the eating habits of teenagers in the US. So, at present, there are over 42 million teens in the US, and this number is growing as we are speaking right now, correct? Is it possible to survey each of these 42 million individuals about their health? Is it possible? Well, it might be possible, but this will take forever to do. Now, obviously, it's not. It's not reasonable to go around knocking each door and asking for what does your teenage son eat and all of that. All right, this is not very reasonable. That's why sampling is used. It's a method wherein a sample of the population is studied in order to draw inference about the entire population. So it's basically a shortcut to studying the entire population. Instead of taking the entire population and finding out all the solutions, you're just going to take a part of the population that represents the entire population, and you're going to perform all your statistical analysis, your inferential statistics on that small sample. All right. And that sample basically represents the entire population. All right. So I'm sure I've made this clear to you all, what is sample and what is population. Now, there are two main types of sampling techniques that I'll discuss today. We have probability sampling and non-probability sampling. Now, in this video, we'll only be focusing on probability sampling techniques because non-probability sampling is not within the scope of this video. All right, we'll only discuss the probability part because we're focusing on statistics and probability, correct? Now again, under probability sampling, we have three different types. We have random sampling, systematic, and stratified sampling. All right. And just to mention the different types of non-probability samplings, we have snowball, quota, judgment, and convenience sampling. All right. Now guys, in this session, I'll only be focusing on probability. So let's move on and look at the different types of probability sampling. So what is probability sampling? It is a sampling technique in which samples from a large population are chosen by using the theory of probability. All right. So there are three types of probability sampling. All right. First, we have the random sampling. Now, in this method, each member of the population has an equal chance of being selected in the sample. All right, so each and every individual or each and every object in the population has an equal chance of being a part of the sample. That's what random sampling is all about. Okay, you're randomly going to select any individual or any object. So this way, each individual has an equal chance of being selected. Correct? Next, we have systematic sampling. Now, in systematic sampling, every nth record is chosen from the population to be a part of the sample. All right. Now, refer this image that I've shown over here. Out of these six groups, every second group is chosen as a sample. Okay, so every second record is chosen here. And this is how systematic sampling works. Okay, you're randomly selecting the nth record and you're going to add that to your sample. Next, we have stratified sampling. Now, in this type of technique, a stratum is used to form samples from a large population. So what is a stratum? A stratum is basically a subset of the population that shares at least one common characteristics. So let's say that your population has a mix of both male and female. So you can create two stratums out of this. One will have only the male subset and the other will have the female subset. All right, this is what stratum is. It is basically a subset of the population that shares at least one common characteristics. All right. In our example, it is gender. So after you've created a stratum, you're going to use random sampling on these stratums and you're going to choose a final sample. So random sampling meaning that all of the individuals in each of the stratum will have an equal chance of being selected in the sample. Correct? So guys, these were the three different types of sampling techniques. Now let's move on and look at our next topic, which is the different types of statistics. So after this, we'll be looking at the more advanced concepts of statistics. All right, so far we discussed the basics of statistics, which is basically what is statistics, the different sampling techniques, and the terminologies in statistics. All right, now we look at the different types of statistics. So there are two major types of statistics: descriptive statistics and inferential statistics. In today's session, we'll be discussing both of these types of statistics in depth. All right, we'll also be looking at a demo which I'll be running in the R language in order to make you understand what exactly descriptive and inferential statistics is. So guys, we're just going to look at the basics, so don't worry if you don't have much knowledge. I'm explaining everything from the basic level. All right. So guys, descriptive statistics is a method which is used to describe and understand the features of specific data set by giving a short summary of the data. Okay, so it is mainly focused upon the characteristics of data. It also provides a graphical summary of the data. Now, in order to make you understand what descriptive statistics is, let's suppose that you want to gift all your classmates a t-shirt. So to study the average shirt size of a student in a classroom, so if you were to use descriptive statistics to study the average shirt size of students in your classroom, then what you would do is you would record the shirt size of all students in the class, and then you would find out the maximum, minimum, and average shirt size of the class. Okay. So coming to inferential statistics makes inferences and predictions about a population based on the sample of data taken from the population. Okay. So in simple words, it generalizes a large data set and it applies probability to draw a conclusion. Okay. So it allows you to infer data parameters based on a statistical model by using sample data. So if we consider the same example of finding the average shirt size of students in a class, in inferential statistics, you will take a sample set of the class, which is basically a few people from the entire class. All right. You already have had grouped the class into large, medium, and small. All right. In this method, you basically build a statistical model and expand it for the entire population in the class. So guys, that was a brief understanding of descriptive and inferential statistics. So that's the difference between descriptive and inferential. Now, in the next section, we'll go in depth about descriptive statistics. All right. So let's discuss more about descriptive statistics. So like I mentioned earlier, descriptive statistics is a method that is used to describe and understand the features of a specific data set by giving short summaries about the sample and measures of the data. There are two important measures in descriptive statistics. We have measure of central tendency, which is also known as measure of center, and we have measures of variability. This is also known as measures of spread. So measures of center include mean, median, and mode. Now, what is measures of center? Measures of the center are statistical measures that represent the summary of a data set. Okay, the three main measures of center are mean, median, and mode. Coming to measures of variability or measures of spread, we have range, interquartile range, variance, and standard deviation. All right. So now let's discuss each of these measures in a little more depth, starting with the measures of center. Now, I'm sure all of you know what the mean is. Mean is basically the measure of the average of all the values in a sample. Okay, so it's basically the average of all the values in a sample. How do you measure the mean? I hope all of you know how the mean is measured. If there are 10 numbers and you want to find the mean of these 10 numbers, all you have to do is you have to add up all the 10 numbers and you have to divide it by 10. 10 here represents the number of samples in your data set. All right, since we have 10 numbers, we're going to divide this by 10. All right, this will give us the average or the mean. So to better understand the measures of central tendency, let's look at an example. Now the data set over here is basically the cars data set, and it contains a few variables. All right, it has something known as cars. It has mileage per gallon, cylinder type, displacement, horsepower, and real axle ratio. All right, all of these measures are related to cars. Okay. So what you're going to do is you're going to use descriptive analysis and you're going to analyze each of the variables in the sample data set for the mean, standard deviation, median, mode, and so on. So let's say that you want to find out the mean or the average horsepower of the cars among the population of cars. Like I mentioned earlier, what you'll do is you'll check the average of all the values. So in this case, we'll take the sum of the horsepower of each car and we'll divide that by the total number of cars. Okay, that's exactly what I've done here in the calculation part. So this 110 basically represents the horsepower for the first car. Alright, similarly, I've just added up all the values of horsepower for each of the cars and I've divided it by 8. Now 8 is basically the number of cars in our data set. Alright, so 103.625 is what our mean is or the average of horsepower is. Alright. Now let's understand what median is with an example. Okay, so to define median is basically a measure of the central value of the sample set is called the median. All right, you can say that it is a middle value. So if you want to find out the center value of the mileage per gallon among the population of cars, first what we'll do is we'll arrange the MPG values in ascending or descending order and choose a middle value. Alright, in this case, since we have 8 values, right, we have 8 values, which is an even entry. So whenever you have even number of data points or samples in your data set, then you're going to take the average of the two middle values. If we had 9 values over here, we can easily figure out the middle value and choose that as a median. But since there are even number of values, we're going to take the average of the two middle values. All right. So 22.8 and 23 are my two middle values, and I'm taking the mean of those two, and hence I get 22.9, which is my median. All right. Lastly, let's look at how mode is calculated. So what is mode? Now, the value that is most recurrent in the sample set is known as mode, or basically the value that occurs most often. Okay, that is known as mode. So let's say that we want to find out the most common type of cylinder among the population of cars. All we have to do is we will check the value which is repeated the most number of times. Here we can see that the cylinders come in two types. We have cylinder of type 4 and cylinder of type 6, right? So take a look at the data set. You can see that the most recurring value is 6, right? We have 1, 2, 3, 4, and 5. We have 5, 6, and we have 1, 2, 3. Yeah, we have 3, 4 type cylinders and 5, 6 type cylinders. So basically we have 3, 4 type cylinders and we have 5, 6 type cylinders. Alright, so our mode is going to be 6 since 6 is more recurrent than 4. So guys, those were the measures of the center or the measures of central tendency. Now let's move on and look at the measures of the spread. Alright. Now, what is the measure of spread? A measure of spread, sometimes also called as measure of dispersion, is used to describe the variability in a sample or population. Okay, you can think of it as some sort of deviation in the sample. Alright, so you measure this with the help of the different measure of spreads. We have range, interquartile range, variance, and standard deviation. Now, range is pretty self-explanatory, right? It is the given measure of how spread apart the values in a data set are. The range can be calculated as shown in this formula. So you're basically going to subtract the maximum value in your data set from the minimum value in your data set. That's how you calculate the range of the data. All right. Next, we have interquartile range. So before we discuss interquartile range, let's understand what a quartile is. Alright, so quartiles basically tell us about the spread of a data set by breaking the data set into different quartiles. Okay, just like how the median breaks the data into two parts, the quartile will break it into different quartiles. So to better understand how quartile and interquartile are calculated, let's look at a small example. Now, this data set basically represents the marks of 100 students ordered from the lowest to the highest scores. Alright, so the quartiles lie in the following ranges. Now, the first quartile, which is also known as Q1, it lies between the 25th and the 26th observation. Alright, so if you look at this, I've highlighted the 25th and the 26th observation. So how you can calculate Q1 or first quartile is by taking the average of these two values. Alright, since both the values are 45, when you add them up and divide them by 2, you'll still get 45. Now the second quartile or Q2 is between the 50th and the 51st observation. So you're going to take the average of 58 and 59 and you'll get a value of 58.5. Now this is my second quarter. The third quartile or Q3 is between the 75th and the 76th observation. Here again you'll take the average of the two values, which is the 75th value and the 76th value. Alright, and you'll get a value of 71. Alright, so guys, this is exactly how you calculate the different quartiles. Now let's look at what is interquartile range. So IQR or the interquartile range is a measure of variability based on dividing a dataset into quartiles. Now the interquartile range is calculated by subtracting the Q1 from Q3. So basically Q3 minus Q1 is your IQR. So your IQR is your Q3 minus Q1. Alright. Now this is how each of the quartiles are. Each quartile represents a quarter, which is 25%. Alright. So guys, I hope all of you are clear with interquartile range and what are quartiles. Now let's look at variance. Now variance is basically a measure that shows how much a random variable differs from its expected value. Okay, it's basically the variance in any variable. Now variance can be calculated by using this formula. Right here, X basically represents any data point in your data set. N is the total number of data points in your data set, and X bar is basically the mean of data points. Alright, this is how you calculate variance. Variance is basically computing the squares of deviations. Okay, that's why it says S squared there. Now let's look at what is deviation. Deviation is just the difference between each element from the mean. Okay, so it can be calculated by using this simple formula where xi basically represents a data point and mu is the mean of the population. Alright, this is exactly how you calculate deviation. Now, population variance and sample variance are very specific to whether you're calculating the variance in your population dataset or in your sample dataset. That's the only difference between population and sample variance. So the formula for population variance is pretty explanatory. So xi is basically each data point, mu is the mean of the population, n is the number of samples in your dataset. All right. Now let's look at sample variance. Now sample variance is the average of square differences from the mean. Alright, here xi is any data point or any sample in your data set. X bar is the mean of your sample. Alright, it's not the mean of your population. It's the mean of your sample. And if you notice, n here is a smaller n, it's the number of data points in your sample. And this is basically the difference between sample and population variance. I hope that is clear. Coming to standard deviation is the measure of dispersion of a set of data from its mean. Alright, so it's basically the deviation from your mean. That's what standard deviation is. Now, to better understand how the measures of spread are calculated, let's look at a small use case. So let's say Daenerys has 20 dragons. They have the numbers 9, 2, 5, 4, and so on, as shown on the screen. What you have to do is you have to work out the standard deviation. Alright, in order to calculate the standard deviation, you need to know the mean, right? So first you're going to find out the mean of your sample set. So how do you calculate the mean? You add all the numbers in your data set divided by the total number of samples in your data set. So you get a value of 7 here. Then you calculate the RHS of your standard deviation formula. Alright, so from each data point, you're going to subtract the mean and you're going to square that. Alright, so when you do that, you'll get the following result. You'll basically get this 425, 4, 9, 25, and so on. So finally, you'll just find the mean of these squared differences. Alright, so your standard deviation will come up to 2.983 once you take the square root. So guys, this is pretty simple. It's a simple mathematic technique. All you have to do is you have to substitute the values in the formula. Alright, I hope this was clear to all of you. Now let's move on and discuss the next topic, which is information gain and entropy. Now this is one of my favorite topics in statistics. It's very interesting. And this topic is mainly involved in machine learning algorithms like decision trees and random forest. All right, it's very important for you to know how information gain and entropy really work and why they're so essential in building machine learning models. We'll focus on the statistic parts of information gain and entropy. And after that, we'll discuss a use case and see how information gain and entropy is used in decision trees. So for those of you who don't know what a decision tree is, it is basically a machine learning algorithm. You don't have to know anything about this. I'll explain everything in depth, so don't worry. Now let's look at what exactly entropy and information gain is. Now guys, entropy is basically the measure of any sort of uncertainty that is present in the data. Alright, so it can be measured by using this formula. So here S is the set of all instances in the data set or all the data items in the data set. N is the different type of classes in your data set. Pi is the event probability. Now this might seem a little confusing to you all, but when we go through the use case, you'll understand all of these terms even better. Alright. Coming to information gain, as the word suggests, information gain indicates how much information a particular feature or a particular variable gives us about the final outcome. Okay, it can be measured by using this formula. So again, here h of S is the entropy of the whole data set S. Sj is the number of instances with the j value of an attribute A. S is the total number of instances in the data set. V is the set of distinct values of an attribute A. H of Sj is the entropy of subset of instances, and H of A, S is the entropy of an attribute A. Even though this seems confusing, I'll clear out the confusion. Alright, let's discuss a small problem statement where we'll understand how information gain and entropy is used to study the significance of a model. So like I said, information gain and entropy are very important statistical measures that let us understand the significance of a predictive model. Okay, to get a more clear understanding, let's look at a use case. Alright, now suppose we're given a problem statement. Alright, the statement is that you have to predict whether a match can be played or not by studying the weather conditions. So the predictor variables here are outlook, humidity, wind. Day is also a predictor variable. The target variable is basically play. Alright, the target variable is the variable that you're trying to predict. Okay. Now the value of the target variable will decide whether or not a game can be played. Alright, so that's why the play has two values. It has no and yes. No meaning that the weather conditions are not good and therefore you cannot play the game. Yes meaning that the weather conditions are good and suitable for you to play the game. Alright, so that was a problem statement. I hope the problem statement is clear to all of you. Now to solve such a problem, we make use of something known as decision trees. So guys, think of an inverted tree and each branch of the tree denotes some decision. Alright, each branch is known as the branch node, and at each branch node you're going to take a decision in such a manner that you'll get an outcome at the end of the branch. Alright, now this figure here basically shows that out of 14 observations, 9 observations result in a yes, meaning that out of 14 days the match can be played only on 9 days. Alright, so here if you see on day 1, day 2, day 8, day 9 and day 11, the outlook has been sunny. Alright, so basically we're trying to cluster our data set depending on the outlook. So when the outlook is sunny, this is our data set. When the outlook is overcast, this is what we have. And when the outlook is rain, this is what we have. Alright, so when it is sunny, we have 2 yeses and 3 no's. Okay, when the outlook is overcast, we have all 4 as yeses, meaning that on the 4 days when the outlook was overcast, we can play the game. Alright, now when it comes to rain, we have 3 yeses and 2 no's. Alright, so if you notice here, the decision is being made by choosing the outlook variable as the root node. Okay, so the root node is basically the topmost node in a decision tree. Now what we've done here is we've created a decision tree that starts with the outlook node. Alright, then you're splitting the decision tree further depending on other parameters like sunny, overcast and rain. Alright, now like we know that outlook has 3 values: sunny, overcast and rain. So let me explain this in a more in-depth manner. Okay, so what you're doing here is you're making the decision tree by choosing the outlook variable at the root node. The root node is basically the topmost node in a decision tree. Now the outlook node has 3 branches coming out from it, which is sunny, overcast and rain. So basically outlook can have 3 values. Either it can be sunny, it can be overcast or it can be rainy. Okay, now these 3 values are assigned to the immediate branch nodes, and for each of these values, the possibility of play is equal to yes is calculated. So the sunny and the rain branches will give you an impure output, meaning that there is a mix of yes and no, right? There are two yeses here, three no's here. There are three yeses here and two no's over here. But when it comes to the overcast variable, it results in a 100% pure subset. All right. This shows that the overcast variable will result in a definite and certain output. This is exactly what entropy is used to measure. All right. It calculates the impurity or the uncertainty. All right. So the lesser the uncertainty or the entropy of a variable, more significant is that variable. So when it comes to overcast, there's literally no impurity in the data set. It is a 100% pure subset, right? So we want variables like these in order to build a model. All right. Now we don't always get lucky and we don't always find variables that will result in pure subsets. That's why we have the measure entropy. So the lesser the entropy of a particular variable, the more significant that variable will be. So in a decision tree, the root node is assigned the best attribute so that the decision tree can predict the most precise outcome. Meaning that on the root node, you should have the most significant variable. All right, that's why we've chosen outlook. All right, now some of you might ask me, why haven't you chosen overcast? Now guys, overcast is not a variable. It is a value of the outlook variable. All right, that's why we've chosen outlook here, because it has a 100% pure subset, which is overcast. All right, now the question in your head is, how do I decide which variable or attribute best splits the data? Now right now I know I looked at the data and I told you that here we have a 100% pure subset. But what if it's a more complex problem and you're not able to understand which variable will best split the data? So guys, when it comes to decision trees, information gain and entropy will help you understand which variable will best split the data set. All right, or which variable you have to assign to the root node. Because whichever variable is assigned to the root node, it will best split the data set, and it has to be the most significant variable. All right, so how we can do this is we need to use information gain and entropy. So from the total of the 14 instances that we saw, 9 of them said yes, and 5 of the instances said no, that you cannot play on that particular day. All right, so how do you calculate the entropy? So this is the formula. You just substitute the values in the formula. So when you substitute the values in the formula, you'll get a value of 0.940. All right, this is the entropy, or this is the uncertainty of the data present in our sample. Now, in order to ensure that we choose the best variable for the root node, let us look at all the possible combinations that you can use on the root node. Okay, so these are all the possible combinations. You can either have outlook, you can have windy, humidity, or temperature. Okay, these are our 4 variables, and you can have any one of these variables as your root node. But how do you select which variable best fits the root node? That's what we are going to see by using information gain and entropy. So guys, now the task at hand is to find the information gain for each of these attributes. All right, so for outlook, for windy, for humidity, and for temperature, we're going to find out the information gain. All right. Now, a point to remember is that the variable that results in the highest information gain must be chosen because it will give us the most precise and output information. All right. So the information gain for attribute windy, we'll calculate that first. Here we have 6 instances of true and 8 instances of false. Okay, so when you substitute all the values in the formula, you'll get a value of 0.048. So we get a value of 0.048. Now this is a very low value for information gain. All right, so the information that you're going to get from windy attribute is pretty low. So let's calculate the information gain of attribute outlook. All right, so from the total of 14 instances, we have 5 instances which say sunny, 4 instances which are overcast, and 5 instances which are rainy. All right, for sunny, we have 3 yeses and 2 no's. For overcast, we have all the 4 as yes. For rainy, we have 3 yes and 2 no's. Okay, so when you calculate the information gain of the outlook variable, you'll get a value of 0.247. Now compare this to the information gain of the windy attribute. This value is actually pretty good, right? We have 0.247, which is a pretty good value for information gain. Now let's look at the information gain of attribute humidity. Now over here we have 7 instances which say high and 7 instances which say normal, right? And under the high branch node, we have 3 instances which say yes, and the rest 4 instances which say no. Similarly, under the normal branch, we have 1, 2, 3, 4, 5, 6, 7 instances which say yes, and 1 instance which says no. All right. So when you calculate the information gain for the humidity variable, you're going to get a value of 0.151. Now this is also a pretty decent value, but when you compare it to the information gain of the attribute outlook, it is less, right? Now let's look at the information gain of attribute temperature. All right, so the temperature can hold, repeat. So basically the temperature attribute can hold hot, mild, and cool. Okay, under hot we have 2 instances which says yes and 2 instances for no. Under mild we have 4 instances of yes and 2 instances of no. And under cool we have 3 instances of yes and 1 instance of no. Alright, now when you calculate the information gain for this attribute, you'll get a value of 0.029, which is again very less. So what you can summarize from here is, if we look at the information gain for each of these variables, we'll see that for Outlook we have the maximum gain. Alright, we have 0.247, which is the highest information gain value. And you must always choose a variable with the highest information gain to split the data at the root node. So that's why we assign the Outlook variable at the root node. Alright, so guys, I hope this use case was clear. If any of you have doubts, please keep commenting those doubts. Now let's move on and look at what exactly a confusion matrix is. Now the confusion matrix is the last topic for descriptive statistics. Alright, after this I'll be running a short demo where I'll be showing you how you can calculate mean, median, mode, and standard deviation, variance, and all of those values by using R. Okay, so let's talk about confusion matrix. Now guys, what is a confusion matrix? Now don't get confused, this is not any complex topic. Now a confusion matrix is a matrix that is often used to describe the performance of a model. Alright, and this is specifically used for classification models or a classifier. And what it does is it will calculate the accuracy, or it will calculate the performance of your classifier by comparing your actual results and your predicted results. Alright, so this is what it looks like: true positive plus true negative and all of that. Now this is a little confusing. I'll get back to what exactly true positive, true negative, and all of this stands for. For now, let's look at an example and let's try and understand what exactly confusion matrix is. So guys, I made sure that I put examples after each and every topic because it's important you understand the practical part of statistics. Alright, statistics has literally nothing to do with theory. You need to understand how calculations are done in statistics. Okay, so here what I've done is, now let's look at a small use case. Okay, let's consider that you're given data about 165 patients, out of which 105 patients have a disease and the remaining 50 patients don't have a disease. Okay, so what you're going to do is you'll build a classifier that predicts by using these 165 observations. You'll feed all of these 165 observations to your classifier and it will predict the output every time a new patient's detail is fed to the classifier. Right? Now, out of these 165 cases, let's say that the classifier predicted yes 110 times and no 55 times. All right. So yes basically stands for yes, the person has a disease, and no stands for no, the person does not have a disease. All right. That's pretty self-explanatory. But yeah, so it predicted that 110 times the patient has a disease and 55 times that no, the patient doesn't have a disease. However, in reality, only 105 patients in the sample have the disease and 60 patients do not have the disease, right? So how do you calculate the accuracy of your model? You basically build the confusion matrix, all right? This is how the matrix looks like. N basically denotes the total number of observations that you have, which is 165 in our case. Actual denotes the actual values in the data set, and predicted denotes the predicted values by the classifier. So the actual value is no here and the predicted value is no here. So your classifier was correctly able to classify 50 cases as no. Alright, since both of these are no, so 50 it was correctly able to classify, but 10 of these cases it incorrectly classified, meaning that your actual value here is no, but your classifier predicted it as yes. Alright, that's why there's 10 over here. Similarly, it wrongly predicted that 5 patients do not have diseases, whereas they actually did have diseases, and it correctly predicted 100 patients which had the disease. All right, I know this is a little bit confusing, but if you look at these values, no, no, 50, meaning that it correctly predicted 50 values. No, yes means that it wrongly predicted yes for the values that it was supposed to predict no. All right. Now, what exactly is this true positive, true negative, and all of that? I'll tell you what exactly it is. So, true positive are the cases in which we predicted a yes and they do not actually have the disease. All right. So, it is basically this value. All right. We predicted a yes here, even though they did not have the disease. So, we have 10 true positives, right? Similarly, true negative is we predicted no and they don't have the disease, meaning that this is correct. False positive is we predicted yes, but they do not actually have the disease. All right, this is also known as type 1 error. False negative is we predicted no, but they actually do not have the disease. So, guys, basically, false negative and true negatives are basically correct classifications. All right. So this was confusion matrix, and I hope this concept is clear. Again, guys, if you have doubts, please comment your doubts in the comment section. So guys, that was the entire descriptive statistics module. And now we'll discuss about probability. Okay, so before we understand what exactly probability is, let me clear out a very common misconception. People often tend to ask me this question: what is the relationship between statistics and probability? So probability and statistics are related fields, all right? So probability is a mathematical method used for statistical analysis. Therefore, we can say that probability and statistics are interconnected branches of mathematics that deal with analyzing the relative frequency of events. So they're very interconnected fields, and probability makes use of statistics and statistics makes use of probability. All right, they're very interconnected fields. So that is the relationship between statistics and probability. Now let's understand what exactly is probability. So probability is the measure of how likely an event will occur. To be more precise, it is the ratio of desired outcome to the total outcomes. Now the probability of all outcomes always sum up to 1. Now the probability will always sum up to 1. Probability cannot go beyond 1. Okay, so either your probability can be 0 or it can be 1, or it can be in the form of decimals like 0.52 or 0.55, or it can be in the form of 0.5, 0.7, 0.9, but its value will always stay between the range 0 and 1. Okay, now the famous example of probability is rolling a dice example. So when you roll a dice, you get 6 possible outcomes, right? You get 1, 2, 3, 4, and 5, 6 phases of a dice. Now each possibility only has one outcome. So what is the probability that on rolling a dice you'll get 3? The probability is 1 by 6, right? Because there's only one phase which has the number 3 on it. Out of 6 phases, there's only one phase which has the number 3. So the probability of getting 3 when you roll a dice is 1 by 6. Similarly, if you want to find the probability of getting a number 5, again the probability is going to be 1 by 6. All right. So all of this will sum up to 1. All right. So guys, this is exactly what probability is. It's a very simple concept. We all learned it in 8th standard onwards, right? Now let's understand the different terminologies that are related to probability. Now there are 3 terminologies that you often come across when we talk about probability. We have something known as the random experiment. Okay, it's basically an experiment or a process for which the outcomes cannot be predicted with certainty. All right, that's why you use probability. You're going to use probability in order to predict the outcome with some sort of certainty. Sample space is the entire possible set of outcomes of a random experiment. An event is one or more outcomes of an experiment. So if you consider the example of rolling a dice, now let's say that you want to find out the probability of getting a 2 when you roll a dice. Okay, so finding this probability is the random experiment. The sample space is basically your entire possibility. Okay, so 1, 2, 3, 4, 5, 6 phases are there, and out of that you need to find the probability of getting a 2, right? So all the possible outcomes will basically represent your sample space. Okay, so 1 to 6 are all your possible outcomes. This represents your sample space. Now, event is one or more outcome of an experiment. So in this case, my event is to get a 2 when I roll a dice, right? So my event is the probability of getting a 2 when I roll a dice. So guys, this is basically what random experiment, sample space, and event really means. All right. Now, let's discuss the different types of events. There are two types of events that you should know about. There is disjoint and non-disjoint events. Disjoint events are events that do not have any common outcome. For example, if you draw a single card from a deck of cards, it cannot be a king and a queen, correct? It can either be king or it can be queen. Now, non-disjoint events are events that have common outcomes. For example, a student can get 100 marks in statistics and 100 marks in probability. All right. And also the outcome of a ball delivered can be a no ball and it can be a 6. Right. So this is what non-disjoint events are. All right. These are very simple to understand. Right. Now let's move on and look at the different types of probability distribution. All right. I'll be discussing the three main probability distribution functions. I'll be talking about probability density function, normal distribution, and central limit theorem. Okay. Probability density function, also known as PDF, is concerned with the relative likelihood for a continuous random variable to take on a given value. All right. So the PDF gives the probability of a variable that lies between the range A and B. So basically what you're trying to do is you're going to try and find the probability of a continuous random variable over a specified range. Okay, now this graph denotes the PDF of a continuous variable. Now this graph is also known as the bell curve. All right, it's famously called the bell curve because of its shape. And there are three important properties that you need to know about a probability density function. Now the graph of a PDF will be continuous over a range. This is because you're finding the probability that a continuous variable lies between the ranges A and B, right? The second property is that the area bounded by the curve of a density function and the x-axis is equal to 1. Basically, the area below the curve is equal to 1, all right, because it denotes probability. Again, the probability cannot range more than 1. It has to be between 0 and 1. Property number 3 is that the probability that a random variable assumes a value between A and B is equal to the area under the PDF bounded by A and B. Okay, now what this means is that the probability value is denoted by the area of the graph. All right, so whatever value that you get here, which is basically 1, is the probability that a random variable will lie between the range A and B. All right, so I hope all of you have understood the probability density function. It's basically the probability of finding the value of a continuous random variable between the range A and B. All right. Now let's look at our next distribution, which is normal distribution. Now, normal distribution, which is also known as the Gaussian distribution, is a probability distribution that denotes the symmetric property of the mean, right? Meaning that the idea behind this function is that the data near the mean occurs more frequently than the data away from the mean. So what it means to say is that the data around the mean represents the entire data set. Okay, so if you just take a sample of data around the mean, it can represent the entire data set. Now, similar to the probability density function, the normal distribution appears as a bell curve. All right. Now, when it comes to normal distribution, there are two important factors. All right, we have the mean of the population and the standard deviation. Okay, so the mean in the graph determines the location of the center of the graph, right? And the standard deviation determines the height of the graph. Okay, so if the standard deviation is large, the curve is going to look something like this. All right, it'll be short and wide. And if the standard deviation is small, the curve is tall and narrow. All right. So this was it about normal distribution. Now let's look at the central limit theory. Now the central limit theory states that the sampling distribution of the mean of any independent random variable will be normal or nearly normal if the sample size is large enough. Now that's a little confusing. Okay, let me break it down for you. Now in simple terms, if we had a large population and we divided it into many samples, then the mean of all the samples from the population will be almost equal to the mean of the entire population. All right, meaning that each of the sample is normally distributed, right? So if you compare the mean of each of the sample, it will almost be equal to the mean of the population, right? So this graph basically shows a more clear understanding of the central limit theorem, right? You can see each sample here and the mean of each sample is almost along the same line, right? Okay, so this is exactly what the central limit theorem states. Now, the accuracy or the resemblance to the normal distribution depends on two main factors, right? So the first is the number of sample points that you consider, all right? And the second is the shape of the underlying population. Now, the shape obviously depends on the standard deviation and the mean of a sample, correct? So guys, central limit theorem basically states that each sample will be normally distributed in such a way that the mean of each sample will coincide with the mean of the actual population. All right, in short terms, that's what central limit theorem states. All right, and this holds true only for a large data set. Mostly for a small data set, there are more deviations when compared to a large data set. It's because of the scaling factor, right? The smallest deviation in a small data set will change the value very drastically. But in a large data set, a small deviation will not matter at all. Now let's move on and look at our next topic, which is the different types of probability. Now this is an important topic because most of your problems can be solved by understanding which type of probability should I use to solve this problem, right? So we have three important types of probability. We have marginal, joint, and conditional probability. So let's discuss each of these. Now, the probability of an event occurring unconditioned on any other event is known as marginal probability or unconditional probability. So let's say that you want to find the probability that a card drawn is a heart. All right. So if you want to find the probability that a card drawn is a heart, the probability will be 13 by 52. Since there are 52 cards in a deck and there are 13 hearts in a deck of cards, right? And there are 52 cards in a total deck. So your marginal probability will be 13 by 52. That's about marginal probability. Now let's understand what is joint probability. Now, joint probability is a measure of two events happening at the same time. Okay, let's say that the two events are A and B. So the probability of event A and B occurring is the intersection of A and B. So for example, if you want to find the probability that a card is a 4 and a red, that would be joint probability. All right, because you're finding a card that is 4 and the card has to be red in color. So for the answer, this will be 2 by 52 because we have 1, 2 in hearts and we have 1, 2 in diamonds, correct? So both of these are red in color, therefore our probability is 2 by 52. And if you further down it, it is 1 by 26, right? So this is what joint probability is all about. Moving on, let's look at what exactly conditional probability is. So if the probability of an event or an outcome is based on the occurrence of a previous event or an outcome, then you call it as a conditional probability. Okay. So the conditional probability of an event B is the probability that the event will occur given that an event A has already occurred, right? So if A and B are dependent events, then the expression for conditional probability is given by this. Now, this first term on the left hand side, which is P B of A, is basically the probability of event B occurring given that event A has already occurred. All right. So like I said, if A and B are dependent events, then this is the expression. But if A and B are independent events, then the expression for conditional probability is like this, right? So guys, P of A and P of B is obviously the probability of A and probability of B, right? Now let's move on. Now, in order to understand conditional probability, joint probability, and marginal probability, let's look at a small use case. Okay. Now, basically, we're going to take a data set which examines the salary package and training undergone by candidates. Okay. Now, in this, there are 60 candidates without training and 45 candidates which have enrolled for Edureka's training. Right. Now, the task here is you have to assess the training with the salary package. Okay, let's look at this in a little more depth. So in total, we have 105 candidates, out of which 60 of them have not enrolled for Edureka's training and 45 of them have enrolled for Edureka's training. All right, this is a small survey that was conducted and this is the rating of the package or the salary that they got, right? So if you read through the data, you can understand. there were 5 candidates without Edureka training who got a very poor salary package. Okay, similarly, there are 30 candidates with Edureka training who got a good package, right? So guys, basically you're comparing the salary package of a person depending on whether or not they've enrolled for Edureka training, right? This is our data set. Now let's look at our problem statement. Find the probability that a candidate has undergone Edureka's training. Quite simple. Which type of probability is this? This is marginal probability, right? So the probability that a candidate has undergone Edureka's training is obviously 45 divided by 105. Since 45 is the number of candidates with Edureka training and 105 is the total number of candidates. So you get a value of approximately 0.42. All right, that's the probability of a candidate that has undergone Edureka's training. Next question. Find the probability that a candidate has attended Edureka's training and also has good package. Now this is obviously a joint probability problem, right? So how do you calculate this? Now since our table is quite formatted, we can directly find that people who have gotten a good package along with Edureka training are 30, right? So out of 105 people, 30 people have Edureka training and a good package, right? They're specifically asking for people with Edureka training. Remember that, right? The question is find the probability that a candidate has attended Edureka's training and also has a good package. All right, so you need to consider two factors. That is a candidate who's attended Edureka's training and who has a good package. So clearly that number is 30. 30 divided by total number of candidates, which is 105, right? So here you get the answer clearly. Next, we have find the probability that a candidate has a good package given that he has not undergone training. Okay, now this is clearly conditional probability because here you're defining a condition. You're saying that you want to find the probability of a candidate who has a good package given that he's not undergone any training, right? The condition is that he's not undergone any training. All right. So the number of people who have not undergone training are 60, and out of that, 5 of them have got a good package, right? So that's why this is 5 by 60 and not 5 by 105, because here they've clearly mentioned has a good package given that he has not undergone training. So you have to only consider people who have not undergone training, right? So only 5 people who have not undergone training have gotten a good package, right? So 5 divided by 60, you get a probability of around 0.08, which is pretty low, right? Okay, so this was all about the different types of probability. Now let's move on and look at our last topic in probability, which is Bayes' theorem. Now guys, Bayes' theorem is a very important concept when it comes to statistics and probability. It is majorly used in naive Bayes algorithm. Those of you who aren't aware, naive Bayes is a supervised learning classification algorithm, and it is mainly used in Gmail spam filtering, right? A lot of you might have noticed that if you open up Gmail, you'll see that you have a folder called spam, right? All of that is carried out through machine learning, and the algorithm used there is naive Bayes, right? So now let's discuss what exactly the Bayes theorem is and what it denotes. The Bayes theorem is used to show the relation between one conditional probability and its inverse. All right. Basically, it's nothing but the probability of an event occurring based on prior knowledge of conditions that might be related to the same event. Okay, so mathematically, the Bayes theorem is represented like this, right? Like shown in this equation. The left-hand term is referred to as the likelihood ratio, which measures the probability of occurrence of event B given an event A. Okay. On the left-hand side is what is known as the posterior. Alright, it is referred to as posterior, which means that the probability of occurrence of A given an event B. Right. The second term is referred to as the likelihood ratio. Alright, this measures the probability of occurrence of B given an event A. Now, P of A is also known as the prior, which refers to the actual probability distribution of A, and P of B is again the probability of B, right? This is the Bayes theorem. Now, in order to better understand the Bayes theorem, let's look at a small example. Let's say that we have 3 bowls. We have bowl A, bowl B, and bowl C. Okay, bowl A contains 2 blue balls and 4 red balls. Bowl B contains 8 blue balls and 4 red balls. Bowl C contains 1 blue ball and 3 red balls. Now, if we draw one ball from each bowl, what is the probability to draw a blue ball from a bowl A if we know that we drew exactly a total of 2 blue balls? Right? If you didn't understand the question, please reread it. I shall pause for a second or two. Right? So I hope all of you have understood the question. Okay, now what I'm going to do is I'm going to draw a blueprint for you and tell you how exactly to solve the problem. But I want you all to give me the solution to this problem, right? I'll draw a blueprint. I'll tell you what exactly the steps are, but I want you to come up with the solution on your own, right? The formula is also given to you. Everything is given to you. All you have to do is come up with a final answer, right? Let's look at how you can solve this problem. So first of all, what we'll do is let's consider A. All right, let A be the event of picking a blue ball from bag A, and let X be the event of picking exactly 2 blue balls, right? Because these are the two events that we need to calculate the probability of. Now there are two probabilities that you need to consider here. One is the event of picking a blue ball from bag A, and the other is the event of picking exactly 2 blue balls. Okay, so these two are represented by A and X respectively. So what we want is the probability of occurrence of event A given X, which means that given that we're picking exactly 2 blue balls, what is the probability that we are picking a blue ball from bag A? So by the definition of conditional probability, this is exactly what our equation will look like, correct? This is basically occurrence of event A given an event X, and this is the probability of A and X, and this is the probability of X alone, correct? Now what we need to do is we need to find these two probabilities, which is probability of A and X occurring together and probability of X. Okay, this is the entire solution. So how do you find P, probability of X? This you can do in 3 ways. So first is white ball from A, either white from B or red from C. Now, first is to find the probability of X. X basically represents the event of picking exactly 2 blue balls, right? So these are the 3 ways in which it is possible. So you'll pick one blue ball from bowl A and one from bowl B. In the second case, you can pick one from A and another blue ball from C. In the third case, you can pick a blue ball from bag B and a blue ball from bag C, right? These are the 3 ways in which it is possible. So you need to find the probability of each of this. Step 2 is that you need to find the probability of A and X occurring together. This is the sum of terms 1 and 2. Okay, this is because in both of these events, we are picking a ball from bag A, correct? So guys, find out this probability and let me know your answer in the comment section. All right, we'll see if you get the answer right. I gave you the entire solution to this. All you have to do is substitute the value, right? If you want a second or two, I'm going to pause on the screen so that you can go through this in a more clearer way, right? Remember that you need to calculate two probabilities. The first probability that you need to calculate is the event of picking a blue ball from bag A given that you're picking exactly 2 blue balls. Okay. The second probability you need to calculate is the event of picking exactly 2 blue balls. All right. These are the two probabilities you need to calculate. So remember that, and this is the solution. All right, so guys, make sure you mention your answers in the comment section. For now, let's move on and look at our next topic, which is the inferential statistics. So guys, we just completed the probability module, right? Now we'll discuss inferential statistics, which is the second type of statistics. We discussed descriptive statistics earlier, all right? So like I mentioned earlier, inferential statistics, also known as statistical inference, is a branch of statistics that deals with forming inferences and predictions about a population based on a sample of data taken from the population. All right. Now, the question you should ask is, how does one form inferences or predictions on a sample? The answer is you use point estimation. Okay. Now, you must be wondering, what is point estimation? Point estimation is concerned with the use of the sample data to measure a single value which serves as an approximate value or the best estimate of an unknown population parameter. That's a little confusing. Let me break it down to you. For example, in order to calculate the mean of a huge population, what we do is we first draw out the sample of the population and then we find the sample mean, right? The sample mean is then used to estimate the population mean. This is basically point estimate. You're estimating the value of one of the parameters of the population, right? Basically, the mean, you're trying to estimate the value of the mean. This is what point estimation is. There are two main terms in point estimation. There's something known as the estimator and there's something known as the estimate. Estimator is a function of the sample that is used to find out the estimate. All right. In this example, it's basically the sample mean, right? So a function that calculates the sample mean is known as the estimator, and the realized value of the estimator is the estimate, right? So I hope point estimation is clear. Now, how do you find the estimates? There are four common ways in which you can do this. The first one is method of moments. Here what you do is you form an equation in the sample data set and then you analyze a similar equation in the population data set as well, like the population mean, population variance, and so on. So in simple terms, what you're doing is you're taking down some known facts about the population and you're extending those ideas to the sample. All right. Once you do that, you can analyze the sample and estimate more essential or more complex values. Right. Next, we have maximum of likelihood. Now, this method basically uses a model to estimate a value. All right. Now, a maximum of likelihood is majorly based on probability. So there's a lot of probability involved in this method. Next, we have the Bayes estimator. This works by minimizing the errors or the average risk. Okay. The Bayes estimator has a lot to do with the Bayes theorem. All right. Let's not get into the depth of these estimation methods. Finally, we have the best unbiased estimators. In this method, there are several unbiased estimators that can be used to approximate a parameter. Okay. So guys, these were a couple of methods that are used to find the estimate. But the most well-known method to find the estimate is known as the interval estimation. Okay, this is one of the most important estimation methods. All right, this is where confidence interval also comes into the picture, right? Apart from interval estimation, we also have something known as margin of error. So I'll be discussing all of this in the upcoming slides. So first, let's understand what is interval estimate. Okay, an interval or range of values which are used to estimate a population parameter is known as an interval estimation. Right, that's very understandable. Basically, what they're trying to say is you're going to estimate the value of a parameter. Let's say you're trying to find the mean of a population. What you're going to do is you're going to build a range and your value will lie in that range or in that interval. All right, so this way your output is going to be more accurate because you've not predicted a point estimation. Instead, you have estimated an interval within which your value might occur, right? Okay, now this image clearly shows how point estimate and interval estimate are different. So guys, interval estimate is obviously more accurate because you're not just focusing on a particular value or a particular point in order to predict the probability. Instead, you're saying that the value might be within this range between the lower confidence limit and the upper confidence limit. All right, this just denotes the range or the interval. Okay, if you're still confused about interval estimation, let me give you a small example. If I stated that I will take 30 minutes to reach the theater, this is known as point estimation. Okay, but if I stated that I will take between 45 minutes to an hour to reach the theater, this is an example of interval estimation. All right, I hope it's clear now. Now, interval estimation gives rise to two important statistical terminologies. One is known as confidence interval and the other is known as margin of error. All right. So guys, it's important that you pay attention to both of these terminologies. Confidence interval is one of the most significant measures that are used to check how essential a machine learning model is. All right. So what is confidence interval? Confidence interval is the measure of your confidence that the interval estimated contains the population parameter or the population mean or any of those parameters, right? Now, statisticians use a confidence interval to describe the amount of uncertainty associated with a sample estimate of a population parameter. Now, guys, this is a lot of definition. Let me just make you understand confidence interval with a small example. Okay, let's say that you perform a survey and you survey a group of cat owners to see how many cans of cat food they purchase in 1 year. Okay. You test your statistics at the 99% confidence level and you get a confidence interval of 100, 200. This means that you think that the cat owners buy between 100 to 200 cans in a year. And also, since the confidence level is 99%, it shows that you're very confident that the results are correct. Okay, I hope all of you are clear with that. Right, so your confidence interval here will be 100 and 200, and your confidence level will be 99%. Right, that's the difference between confidence interval and confidence level. So within your confidence interval, your value is going to lie, and your confidence level will show how confident you are about your estimation. Right, I hope that was clear. Let's look at margin of error. Now, margin of error for a given level of confidence is the greatest possible distance between the point estimate and the value of the parameter that it is estimating. You can say that it is a deviation from the actual point estimate. Right? Now, the margin of error can be calculated using this formula. Now, ZC here denotes the critical value or the confidence interval, and this is multiplied by standard deviation divided by root of the sample size. All right, n is basically the sample size. Now, let's understand how you can estimate the confidence intervals. So, guys, the level of confidence, which is denoted by C, is the probability that the interval estimate contains a population parameter. Let's say that you're trying to estimate the mean. All right. So the level of confidence is the probability that the interval estimate contains the population parameter. So this interval between minus ZC and ZC, or the area beneath this curve, is nothing but the probability that the interval estimate contains a population parameter. All right. It should basically contain the value that you are predicting. Right. Now, these are known as critical values. This is basically your lower limit and your higher limit confidence level. Also, there's something known as the z-score. Now, this score can be calculated by using the standard normal table. All right, if you look it up anywhere on Google, you'll find the z-score table or the standard normal table. Okay, to understand how this is done, let's look at a small example. Okay, let's say that the level of confidence is 90%. This means that you are 90% confident that the interval contains the population mean. Okay. So the remaining 10%, which is out of 100%, the remaining 10% is equally distributed on these tail regions. Okay, so you have 0.05 here and 0.05 over here, right? So on either side of C, you'll distribute the other leftover percentage. Now these z-scores are calculated from the table as I mentioned before. All right, 1.645 is calculated from the standard normal table. Okay, so guys, this is how you estimate the level of confidence. So to sum it up, let me tell you the steps that are involved in constructing a confidence interval. First, you'll start by identifying a sample statistic. Okay, this is the statistic that you will use to estimate a population parameter. This can be anything like the mean of the sample. Next, you will select a confidence level. Now, the confidence level describes the uncertainty of a sampling method, right? After that, you'll find something known as the margin of error, right? We discussed margin of error earlier. So you find this based on the equation that I explained in the previous slide. Then you'll finally specify the confidence interval. All right. Now let's look at a problem statement to better understand this concept. A random sample of 32 textbook prices is taken from a local college bookstore. The mean of the sample is so and so, and the sample standard deviation is this. Use a 95% confident level and find the margin of error for the mean price of all textbooks in the bookstore. Okay, now this is a very straightforward question. If you want, you can read the question again. All you have to do is you have to just substitute the values into the equation. All right. So guys, we know the formula for margin of error. You take the z-score from the table. After that, we have deviation, which is 23.44, right? And that's standard deviation. And n stands for the number of samples. Here the number of samples is 32, basically 32 textbooks. So approximately your margin of error is going to be around 8.12. This is a pretty simple question. All right, I hope all of you understood this. Now that you know the idea behind confidence interval, let's move ahead to one of the most important topics in statistical inference, which is hypothesis testing, right? So basically, statisticians use hypothesis testing to formally check whether the hypothesis is accepted or rejected. Okay. Hypothesis testing is an inferential statistical technique used to determine whether there is enough evidence in a data sample to infer that a certain condition holds true for an entire population. So, to understand the characteristics of a general population, we take a random sample and we analyze the properties of the sample, right? We test whether or not the identified conclusion represents the population accurately, and finally, we interpret their results. Now, whether or not to accept the hypothesis depends upon the percentage value that we get from the hypothesis. Okay, so to better understand this, let's look at a small example. Before that, there are a few steps that are followed in hypothesis testing. You begin by stating the null and the alternative hypothesis. All right, I'll tell you what exactly these terms are. And then you formulate an analysis plan. All right, after that, you analyze the sample data. And finally, you can interpret the results. Right. Now, to understand the entire hypothesis testing, we'll look at a good example. Okay. Now, consider four boys: Nick, John, Bob, and Harry. These boys were caught bunking a class and they were asked to stay back at school and clean their classroom as a punishment. Right? So, what John did is he decided that four of them would take turns to clean their classrooms. He came up with a plan of writing each of their names on chits and putting them in a bowl. Now, every day they had to pick up a name from the bowl and that person had to clean the class. Right? That sounds pretty fair enough. Now, it has been 3 days and everybody's name has come up except John's. Assuming that this event is completely random and free of bias, what is the probability of John not cheating? Right? What is the probability that he's not actually cheating? This can be solved by using hypothesis testing. Okay, so we'll begin by calculating the probability of John not being picked for a day. Right, so we're going to assume that the event is free of bias. So we need to find out the probability of John not cheating, right? First, we'll find the probability that John is not picked for a day, right? We get 3 out of 4, which is basically 75%. Now, 75% is fairly high. So if John is not picked for 3 days in a row, the probability will drop down to approximately 42%. Okay, so 3 days in a row meaning the probability drops down to 42%. Now let's consider a situation where John is not picked for 12 days in a row. The probability drops down to 3.2%. Okay, thus the probability of John cheating becomes fairly high, right? So in order for statisticians to come to a conclusion, they define what is known as the threshold value, right? Considering the above situation, if the threshold value is set to 5%, it would indicate that if the probability lies below 5%, then John is cheating his way out of detention. But if the probability is above the threshold value, then John is just lucky and his name isn't getting picked. So the probability and hypothesis testing give rise to two important components of hypothesis testing, which is null hypothesis and alternate hypothesis. Null hypothesis is basically approving the assumption. Alternate hypothesis is when your result disapproves the assumption. Right? Therefore, in our example, if the probability of an event occurring is less than 5%, which it is, then the event is biased. Hence, it proves the alternate hypothesis. So guys, with this, we come to the end of this session.
Let's go ahead and understand what exactly is supervised learning. So supervised learning is where you have the input variable X and the output variable Y, and you use an algorithm to learn the mapping function from the input to the output, as I mentioned earlier with the example of face detection. So it is called supervised learning because the process of an algorithm learning from the training dataset can be thought of as a teacher supervising the learning process. So if we have a look at the supervised learning steps, or what we'd rather say the workflow. So the model is used, as you can see here, we have the historic data, then we have the random sampling. We split the data into training data set and the testing data set. Using the training dataset, with the help of machine learning, which is supervised machine learning, we create statistical model. And then after we have a model which is being generated with the help of the training dataset, what we do is use the testing dataset for prediction and testing. What we do is get the output, and finally we have the model validation outcome. That was the training and testing. So if we have a look at the prediction part of any particular supervised learning algorithm, so the model is used for predicting outcome of a new data set. So whenever performance of the model degraded, the model is retrained, or if there are any performance issues, the model is retrained with the help of the new data. Now, when we talk about supervised learning, there are not just one, but quite a few algorithms here. So we have linear regression, logistic regression, decision tree, we have random forest, we have naive Bayes classifiers. So linear regression is used to estimate real values, for example, the cost of houses, the number of calls, the total sales, based on the continuous variables. So that is what linear regression is. Now, when we talk about logistic regression, it is used to estimate discrete values, for example, which are binary values like 0 and 1, yes or no, true and false, based on the given set of independent variables. So, for example, when we are talking about something like the chances of winning, or if we talk about winning, which can be the true or false, if will it rain today, it can be the yes or no. So it cannot be like when the output of a particular algorithm or the particular question is either yes, no, or a binary, then only we use a logistic regression. Now, next we have decision trees. So now these are used for classification problems. It works for both categorical and continuous dependent variables. And if we talk about random forest, so random forest is an ensemble of a decision tree. It gives better prediction and accuracy than decision trees. So that is another type of supervised learning algorithm. And finally, we have the naive Bayes classifier. So it is a classification technique based on the Bayes theorem with an assumption of independence between predictors.
A linear regression is one of the easiest algorithm in machine learning. It is a statistical model that attempts to show the relationship between two variables with a linear equation. But before we drill down to linear regression algorithm in depth, I'll give you a quick overview of today's agenda. So we'll start our session with a quick overview of what is regression, as linear regression is one of a type of regression algorithm. Once we learn about regression, its use case, the various types of it, next we'll learn about the algorithm from scratch, where I'll teach you its mathematical implementation first, then we'll drill down to the coding part and implement linear regression using Python. In today's session, we'll deal with linear regression algorithm using least square method, check its goodness of fit or how close the data is to the fitted regression line using the R-square method. And then finally, what we'll do, we'll optimize it using the gradient descent method. In the last part, on the coding session, I'll teach you to implement linear regression using Python. And the coding session would be divided into two parts. The first part would consist of linear regression using Python from scratch, where you will use the mathematical algorithm that you have learned in this session. And in the next part of the coding session, we'll be using scikit-learn for direct implementation of linear regression. So let's begin our session with what is regression? Well, regression analysis is a form of predictive modeling technique which investigates the relationship between a dependent and independent variable. A regression analysis involves graphing a line over a set of data points that most closely fits the overall shape of the data. A regression shows the changes in a dependent variable on the y-axis to the changes in the explanatory variable on the x-axis. Fine. Now you'd ask, what are the uses of regression? Well, there are major three uses of regression analysis. The first being determining the strength of predicators. The regression might be used to identify the strength of the effect that the independent variables have on the dependent variable. For example, you can ask question like, what is the strength of relationship between sales and marketing spending? Or what is the relationship between age and income? Second is forecasting an effect. In this, the regression can be used to forecast effects or impact of changes. That is, the regression analysis help us to understand how much the dependent variable changes with the change in one or more independent variable. Fine. For example, you can ask question like, how much additional sale income will I get for each $1,000 spent on marketing? Third is trend forecasting. In this, the regression analysis predict trends and future values. The regression analysis can be used to get point estimates. In this, you can ask questions like, what will be the price of Bitcoin in next 6 months, right? So next topic is linear versus logistic regression. By now, I hope that you know what a regression is. So let's move on and understand its type. So there are various kinds of regression like linear regression, logistic regression, polynomial regression, and others. All right. But for this session, we'll be focusing on linear and logistic regression. So let's move on and let me tell you what is linear regression and what is logistic regression. Then what we'll do, we'll compare both of them. All right. So starting with linear regression. In simple linear regression, we are interested in things like y equal mx plus c. So what we are trying to find is the correlation between x and y variable. This means that every value of x has a corresponding value of y in it if it is continuous. Alright. However, in logistic regression, we are not fitting our data to a straight line like linear regression. Instead, what we are doing, we are mapping y versus x to a sigmoid function. In logistic regression, what we find out is y 1 or 0 for this particular value of x. So thus we are essentially deciding true or false value for a given value of x. Fine. So as a core concept of linear regression, you can say that the data is modeled using a straight line, where in the case of logistic regression, the data is modeled using a sigmoid function. The linear regression is used with continuous variables. On the other hand, the logistic regression, it is used with categorical variable. The output or the prediction of a linear regression is the value of the variable. On the other hand, the output or prediction of a logistic regression is the probability of occurrence of the event. Now, how will you check the accuracy and goodness of fit? In case of linear regression, you have various methods like measured by loss, R squared, adjusted R squared, etc. While in the case of logistic regression, you have accuracy, precision, recall, F1 score, which is nothing but the harmonic mean of precision and recall. Next is ROC curve for determining the probability threshold for classification or the confusion matrix, etc. There are many. All right. So summarizing the difference between linear and logistic regression, you can say that the type of function you are mapping to is the main point of difference between linear and logistic regression. A linear regression maps a continuous x to a continuous y. On the other hand, a logistic regression maps a continuous x to the binary y. So we can use logistic regression to make category or true-false decisions from the data. Fine, so let's move on ahead. Next is linear regression selection criteria, or you can say when will you use linear regression. So the first is classification and regression capabilities. Regression models predict a continuous variable, such as the sales made on a day, or predict the temperature of a city. Their reliance on a polynomial like a straight line to fit a data set poses a real challenge when it comes towards building a classification capability. Let's imagine that you fit a line with the training points that you have. Now imagine you add some more data points to it. But in order to fit it, what do you have to do? You have to change your existing model. That is, maybe you have to change the threshold itself. So this will happen with each new data point you add to the model. Hence, the linear regression is not good for classification models. Fine. Next is data quality. Each missing value removes one data point that could optimize the regression. In simple linear regression, the outliers can significantly disrupt the outcome. Just for now, you can know that if you remove the outliers, your model will become very good. All right. So this is about data quality. Next is computational complexity. The linear regression is often not computationally expensive as compared to the decision tree or the clustering algorithm. The order of complexity for n training example and x features usually falls in either big O of x square or big O of xn. Next is comprehensible and transparent. The linear regression are easily comprehensible and transparent in nature. They can be represented by a simpler mathematical notation to anyone and can be understood very easily. So these are some of the criteria based on which you'll select the linear regression algorithm. Alright, next is where is linear regression used? First is evaluating trends and sales estimate. Well, linear regression can be used in business to evaluate trends and make estimates or forecasts. For example, if a company's sales have increased steadily every month for past few years, then conducting a linear analysis on the sales data with monthly sales on the y-axis and time on the x-axis. This will give you a line that predicts the upward trends in the sale. After creating the trend line, the company could use the slope of the lines to forecast sale in future months. Next is analyzing the impact of price changes. Well, linear regression can be used to analyze the effect of pricing on consumer behavior. For instance, if a company changes the price on a certain product several times, then it can record the quantity itself for each price level and then perform a linear regression with sold quantity as a dependent variable and price as the independent variable. This would result in a line that depicts the extent to which the customer reduced their consumption of the product as the price is increasing. So this result would help us in future pricing decisions. Next is assessment of risk in financial services and insurance domain. Well, linear regression can be used to analyze the risk. For example, a health insurance company might conduct a linear regression algorithm. How it can do? It can do it by plotting the number of claims per customer against its age. And they might discover that the old customers tend to make more health insurance claim. Well, the result of such analysis might guide important business decisions. All right. So by now you have just a rough idea of what linear regression algorithm is, like what it does, where it is used, when you should use it. All right. Now let's move on and understand the algorithm in depth. So suppose you have independent variable on the x-axis and dependent variable on the y-axis. All right. Suppose this is the data point on the x-axis. The independent variable is increasing on the x-axis, and so does the dependent variable on the y-axis. So what kind of linear regression line you would get? You'd get a positive linear regression line. All right, as the slope would be positive. Next is, suppose you have an independent variable on the x-axis, which is increasing. And on the other hand, the dependent variable on the y-axis, that is decreasing. So what kind of line will you get in that case? You'll get a negative regression line in this case, as the slope of the line is negative. And this particular line, that is line of y equal mx plus c, is a line of linear regression, which shows the relationship between independent variable and dependent variable. And this line is only known as line of linear regression. Okay. So let's add some data points to our graph. So these are some observation or data points on our graphs. Let's plot some more. Okay. Now all our data points are plotted. Now our task is to create a regression line or the best fit line. All right. Now, once our regression line is drawn, now it's the task of prediction. Now, suppose this is our estimated value or the predicted value, and this is our actual value. Okay. So what we have to do, our main goal is to reduce this error, that is to reduce the distance between the estimated or the predicted value and the actual value. The best fit line would be the one which had the least error or the least difference in estimated value and the actual value. All right. In other words, we have to minimize the error. This was a brief understanding of linear regression algorithm. Soon we'll jump to its mathematical implementation. But for then, let me tell you this. Suppose you draw a graph with speed on the x-axis and distance covered on the y-axis with the time remaining constant. If you plot a graph between the speed traveled by the vehicle and the distance traveled in a fixed unit of time, then you'll get a positive relationship. All right. So suppose the equation of line is y equal mx plus c. Then in this case, y is the distance traveled in a fixed duration of time. X is the speed of vehicle, m is the positive slope of the line, and c is the y-intercept of the line. All right. Suppose the distance remaining constant, you have to plot a graph between the speed of the vehicle and the time taken to travel a fixed distance. Then in that case, you'll get a line with a negative relationship. All right. The slope of the line is negative. Here the equation of line changes to y equal minus of mx plus c, where y is the time taken to travel a fixed distance, x is the speed of vehicle, m is the negative slope of the line, and c is the y-intercept of the line. All right. Now let's get back to our independent and dependent variable. So in that term, y is our dependent variable and x, that is our independent variable. Now let's move on and see the mathematical implementation of the things. All right. So we have x equal 1, 2, 3, 4, 5. Let's plot them on the x-axis. So 0, 1, 2, 3, 4, 5, 6. All right. And we have y as 3, 4, 2, 4, 5. All right. So let's plot 1, 2, 3, 4, 5 on the y-axis. Now let's plot our coordinates one by one. So x equal 1 and y equal 3. So we have here x equal 1 and y equal 3. So this is our point 1, 3. So similarly, we have 1, 3, 2, 4, 3, 2, 4, 4, and 5, 5. All right. So moving on ahead, let's calculate the mean of x and y and plot it on the graph. All right. So mean of x is 1 plus 2 plus 3 plus 4 plus 5 divided by 5, that is 3. All right. Similarly, mean of y is 3 plus 4 plus 2 plus 4 plus 5, that is 18. So 18 divided by 5, that is nothing but 3.6. All right. So next what we'll do, we'll plot our mean, that is 3, 3.6 on the graph. Okay. So there's a point 3, 3.6. See, our goal is to find or predict the best fit line using the least square method. Alright. So in order to find that, we first need to find the equation of line. So let's find the equation of our regression line. Alright. So let's suppose this is our regression line, y equal mx plus c. Now we have an equation of line. So all we need to do is find the value of m and c, where m equals summation of x minus x bar multiplied by y minus y bar upon the summation of x minus x bar whole square. Don't get confused. Let me resolve it for you. All right. So moving on ahead, as a part of formula, what we are going to do, we'll calculate x minus x bar. So we have x as 1 minus x bar as 3. So 1 minus 3, that is minus 2. Next we have x equal 2 minus its mean 3, that is minus 1. Similarly, we have 3 minus 3 is 0, 4 minus 3 1, 5 minus 3 2. Alright. So x minus x bar, it's nothing but the distance of all the points through the line y equal 3. And what does this y minus y bar implies? It implies the distance of all the points from the line x equal 3.6. Fine. So let's calculate the value of y minus y bar. So starting with y equal 3 minus value of y bar, that is 3.6. So it is 3 minus 3.6. How much? Minus of 0.6. Next is 4 minus 3.6. That is 0.4. Next 2 minus 3.6. That is minus of 1.6. Next is 4 minus 3.6. That is 0.4. Again 5 minus 3.6. That is 1.4. Alright. So now we are done with y minus y bar. Fine. Now next we'll calculate x minus x bar whole square. So let's calculate x minus x bar whole square. So it is minus 2 whole square, that is 4, minus 1 whole square, that is 1, 0 square 0, 1 square 1, 2 square 4. Fine. So now in our table we have x minus x bar, y minus y bar, and x minus x bar whole square. Now what we need the product of x minus x bar multiplied by y minus y bar. Alright. So let's see the product of x minus x bar multiplied by y minus y bar. That is minus of 2 multiplied by minus of 0.6, that is 1.2. Minus of 1 multiplied by 0.4, that is minus of 0.4. 0 multiplied by minus of 1.6, that is 0. 1 multiplied by 0.4, that is 0.4. And next 2 multiplied by 1.4, that is 2.8. Alright. Now almost all the parts of our formula is done. So now what we need to do is get the summation of last two columns. Alright. So the summation of x minus x bar whole square is 10, and the summation of x minus x bar multiplied by y minus y bar is 4. So the value of m will be equal to 4 by 10. Fine. So let's put this value of m equals 0.4 in our line y equal mx plus c. So let's fill all the points into the equation and find the value of c. So we have y as 3.6. Remember the mean y? M as 0.4, which we calculated just now. X as the mean value of x, that is 3. And we have the equation as 3.6 equals 0.4 multiplied by 3 plus c. Alright. That is 3.6 equal 1.2 plus c. So what is the value of c? That is 3.6 minus 1.2. That is 2.4. Alright. So what we had m equals 0.4, c as 2.4. And then finally, when we calculate the equation of regression line, what we get is y equal 0.4 times of x plus 2.4. So this is the regression line. All right. So this is how you are plotting your points. This is your actual point. All right. Now for given m equals 0.4 and c equal 2.4, let's predict the value of y for x equal 1, 2, 3, 4, and 5. So when x equal 1, the predicted value of y will be 0.4 multiplied by 1 plus 2.4, that is 2.8. Similarly, when x equal 2, predicted value of y will be 0.4 multiplied by 2 plus 2.4, that equals to 3.2. Similarly, x equal 3, y will be 3.6. X equal 4, y will be 4.0. X equal 5, y will be 4.4. So let's plot them on the graph, and the line passing through all these predicting points and cutting y-axis at 2.4 is the line of regression. Now your task is to calculate the distance between the actual and the predicted value, and your job is to reduce the distance. Alright? Or in other words, you have to reduce the error between the actual and the predicted value. The line with the least error will be the line of linear regression or regression line, and it will also be the best fit line. All right. So this is how things work in computer. So what it do, it performs n number of iteration for different values of m. For different values of m, it will calculate the equation of line where y equal mx plus c, right? So as the value of m changes, the line is changing. So iteration will start from 1, all right, and it will perform n number of iteration. So after every iteration, what it will do, it will calculate the predicted value according to the line and compare the distance of actual value to the predicted value. And the value of m for which the distance between the actual and the predicted value is minimum will be selected as the best fit line. All right. Now that we have calculated the best fit line, now it's time to check the goodness of fit or to check how good a model is performing. So in order to do that, we have a method called R-square method. So what is this R-square? Well, R-squared value is a statistical measure of how close the data are to the fitted regression line. In general, it is considered that a high R-squared value model is a good model. But you can also have a low R-squared value for a good model as well, or a high R-squared value for a model that does not fit at all. All right. It is also known as coefficient of determination or the coefficient of multiple determination. Let's move on and see how R-square is calculated. So these are our actual values plotted on the graph. We had calculated the predicted values of y as 2.8, 3.2, 3.6, 4.0, 4.4. Remember when we calculated the predicted values of y for the equation y predicted equals 0.4 times of x plus 2.4 for every x equal 1, 2, 3, 4, and 5. From there, we got the predicted values of y. All right. So let's plot it on the graph. So these are a point, and the line passing through these points are nothing but the regression line. All right. Now, what you need to do is you have to check and compare the distance of actual minus mean versus the distance of predicted minus mean. All right. So basically what you're doing, you're calculating the distance of actual value to the mean to distance of predicted value to the mean. All right. So there's nothing but R square. And mathematically, you can represent R square as summation of y predicted values minus y bar whole square divided by summation of y minus y bar whole square, where y is the actual value, yp is the predicted value, and y bar is the mean value of y. That is nothing but 3.6. So remember, this is our formula. So next what we'll do, we'll calculate y minus y bar. So we have y as 3, y bar as 3.6. So we'll calculate it as 3 minus 3.6, that is nothing but minus of 0.6. Similarly, for y equal 4 and y bar equal 3.6, we have y minus y bar as 0.4. Then 2 minus 3.6, it is 1.6. 4 minus 3.6, again 0.4. And 5 minus 3.6, it is 1.4. So we got the value of y minus y bar. Now, what we have to do, we have to take it square. So we have minus of 0.6 square as 0.36, 0.4 square as 0.16, minus of 1.6 square as 2.56, 0.4 square as 0.16, and 1.4 square as 1.96. Now as a part of formula, what we need our yp minus y bar value. So these are yp values and we have to subtract it from the mean of y. So 2.8 minus 3.6, that is minus 0.8. Similarly, we'll get 3.2 minus 3.6, that is 0.4. And 3.6 minus 3.6, that is 0. 4.0 minus 3.6, that is 0.4. Then 4.4 minus 3.6, that is 0.8. So we calculated the value of yp minus y bar. Now it's our turn to calculate the value of yp minus y bar whole square. Next we have minus of 0.8 square as 0.64. Minus of 0.4 square as 0.16, 0 square 0, 0.4 square as again 0.16, and 0.8 square as 0.64. Alright, now as a part of formula, what it suggests me to take the summation of yp minus y bar whole square and summation of y minus y bar whole square. Alright, let's see. So on summating y minus y bar whole square, what you get is 5.2. And summation of yp minus y bar whole square, you get 1.6. So the value of R square can be calculated as 1.6 upon 5.2. Fine. So the result which you'll get is approximately equal to 0.3. Well, this is not a good fit. All right. So it suggests that the data points are far away from the regression line. All right. So this is how your graph will look like when R square is 0.3. When you increase the value of R square to 0.7, so you'll see that the actual value would lie closer to the regression line. When it reaches to 0.9, it comes more close. And when the value approximately equals to 1, then the actual values lies on the regression line itself. For example, in this case, if you get a very low value of r square, suppose 0.02, so in that case, what you'll see that the actual values are very far away from the regression line. Or you can say that there are too many outliers in your data. You cannot forecast anything from the data, all right? So this was all about the calculation of r square. Now you might get a question like, are low values of r square always bad? Well, in some field, it is entirely expected that our R square value will be low. For example, any field that attempts to predict human behavior, such as psychology, typically has R squared values lower than around 50%, through which you can conclude that humans are simply harder to predict than the physical process. Furthermore, if your R squared value is low, but you have statistically significant predicators, then you can still draw important conclusion about how changes in the predicator values are associated with the changes in the response value. Regardless of the R squared, the significant coefficient still represent the mean change in the response for 1 unit of change in the predicator, while holding other predicators in the model constant. Obviously, this type of information can be extremely valuable. Alright? Alright, so this was all about the theoretical concept. Now let's move on to the coding part and understand the code in depth. So for implementing linear regression using Python, I'll be using Anaconda with Jupyter Notebook installed on it. So alright, this is our Jupyter Notebook and we are using Python 3.0 on it. Alright, so we are going to use a data set consisting of head size and human brain of different people. Alright, so let's import our data set. %matplotlib inline. We are importing NumPy as NP, Pandas as PD, and Matplotlib. And from Matplotlib, we are importing PyPlot of that as PLT. Alright. Next, we'll import our data headbrain.csv and store it in the data variable. Let's execute the run button and see the output. So this asterisk symbol, it symbolizes that it's still executing. So there's our output. Our data set consists of 237 rows and 4 columns. We have columns as gender, age range, head size in centimeter cube, and brain weights in gram. Fine. So this is our sample data set. This is how it looks. It consists of all these data set. So now that we have imported our data, so as you can see, there are 237 values in the training set. So we can find a linear relationship between the head size and the brain weights. So now what we'll do, we'll collect X and Y. The X would consist of the head size values and the Y would consist of brain weight values. So collecting X and Y, let's execute the run. Done. Next, what we'll do, we need to find the values of B1 or B0, or you can say M and C. So we'll need the mean of X and Y values. First of all, what we'll do, we'll calculate the mean of X and Y. So mean X equal np.meanX. So mean is a predefined function of NumPy. Similarly, mean underscore y equal np.mean of y. So what it will return? It will return the mean values of y. Next, we'll check the total number of values. So m equal length of x. Alright. Then we'll use the formula to calculate the values of b1 and b0 or m and c. Alright. Let's execute the run button and see what is the result. So as you can see here on the screen, we have got b1 as 0.263 and b0 as 325.57. Alright, so now that we have our coefficient, so comparing it with the equation y equal mx plus c, you can say that brain weight equals 0.263 multiplied by head size plus 325.57. So you can say that the value of m here is 0.263 and the value of c here is 325.57. Alright, so this is our linear model. Now let's plot it and see graphically. Let's execute it. So this is how our plot looks like. This model is not so bad, but we need to find out how good our model is. So in order to find it, there are many methods like root mean square method, the coefficient or determination, or the R square method. So in this tutorial, I have told you about R square method. So let's focus on that and see how good our model is. So let's calculate the R square value. Alright. Here SS underscore T is the total sum of square. SS underscore R is the total sum of square of residuals. And R square as per formula is 1 minus total sum of squares upon total sum of square of residuals. Alright. Next, when you execute it, you'll get the value of R square as 0.63, which is pretty very good. Now that you have implemented simple linear regression model using least square method, Let's move on and see how will you implement the model using machine learning library called scikit-learn. Alright. So this scikit-learn is a simple machine learning library in Python. Building machine learning model are very easy using scikit-learn. So suppose this is your Python code. So using the scikit-learn libraries, your code shortens to this length. Alright. So let's execute the run button and see. You'll get the same R2 score.
So today we'll be discussing logistic regression. So let's move forward and understand the what and why of logistic regression. Now this algorithm is most widely used when the dependent variable, or you can say the output, is in the binary format. So here you need to predict the outcome of a categorical dependent variable. So the outcome should be always discrete or categorical in nature. Now by discrete, I mean the value should be binary, or you can say you just have two values. It can either be 0 or 1. It can either be yes or a no, either be true or false, or high or low. So only these can be the outcomes. So the value which you need to predict should be discrete, or you can say categorical in nature. Whereas in linear regression, we have the value of y, or you can say the value you need to predict is in a range. So that is how there is a difference between linear regression and logistic regression. Now you must be having a question, why not linear regression? Now guys, in linear regression, the value of y, or the value which you need to predict, is in a range. But in our case, as in the logistic regression, we just have two values. It can be either 0 or it can be 1. It should not entertain the values which is below 0 or above 1. But in linear regression, we have the value of y in the range. So here, in order to implement logistic regression, we need to clip this part. So we don't need the value that is below 0, or we don't need the value which is above 1. So since the value of y will be between only 0 and 1, that is the main rule of logistic regression, the linear line has to be clipped at 0 and 1. Now once we clip this graph, it would look somewhat like this. So here you are getting a curve which is nothing but three different straight lines. So here we need to make a new way to solve this problem. So this has to be formulated into an equation, and hence we come up with logistic regression. So here the outcome is either 0 or 1, which is the main rule of logistic regression. So with this, our resulting curve cannot be formulated. So hence our main aim to bring the values to 0 and 1 is fulfilled. So that is how we came up with logistic regression. Now here, once it gets formulated into an equation, it looks somewhat like this. So guys, this is nothing but a S-curve, or you can say the sigmoid curve or sigmoid function curve. So this sigmoid function basically converts any value from minus infinity to infinity to your discrete values, which a logistic regression wants, or you can say the values which are in binary format, either 0 or 1. So if you see here, the values are either 0 or 1, and this is nothing but just a transition of it. But guys, there's a catch over here. So let's say I have a data point that is 0.8. Now how can you decide whether your value is 0 or 1? Now here you have the concept of threshold, which basically divides your line. So here threshold value basically indicates the probability of either winning or losing. So here by winning, I mean the value is equals to 1, and by losing, I mean the value is equals to 0. But how does it do that? Let's say I have a data point which is over here. Let's say my cursor is at 0.8. So here I'll check whether this value is less than my threshold value or not. Let's say if it is more than my threshold value, it should give me the result as 1. If it is less than that, then it should give me the result as 0. So here my threshold value is 0.5. Now I need to define that if my value, let's say 0.8, it is more than 0.5, then the value shall be rounded off to 1. And let's say if it is less than 0.5, let's say I have a value 0.2, then should reduce it to 0. So here you can use the concept of threshold value to find your output. So here it should be discrete, it should be either 0 or it should be 1. So I hope you caught this curve of logistic regression. So guys, this is the sigmoid S curve. So to make this curve, we need to make an equation. So let me address that part as well. So let's see how an equation is formed to imitate this functionality. So over here we have an equation of a straight line, which is y is equals to mx plus c. So in this case, I just have only one independent variable. But let's say if we have many independent variables, then the equation becomes m1x1 plus m2x2 plus m3x3 and so on till mnxn. Now let us put in b and x. So here the equation becomes y is equals to b1x1 plus b2x2 plus b3x3 and so on till bnxn plus c. So guys, your equation of the straight line has a range from minus infinity to infinity. But in our case, or you can say in logistic equation, the value which we need to predict, or you can say the y value, it can have the range only from 0 to 1. So in that case, we need to transform this equation. So to do that, what we had done, we have just divided the equation by 1 minus y. So now our y is equals to 0. So 0 over 1 minus 0 which is equals to 1. So 0 over 1 is again 0. And if we take y is equals to 1, then 1 over 1 minus 1 which is 0. So 1 over 0 is infinity. So here my range is now between 0 to infinity. But again we want the range from minus infinity to infinity. So for that what we'll do, we'll have the log of this equation. So let's go ahead and have the logarithmic of this equation. So here we have just transform it further to get the range between minus infinity to infinity. So over here we have log of y over 1 minus 1, and this is your final logistic regression equation. So guys, don't worry, you don't have to write this formula or memorize this formula. In Python you just need to call this function which is logistic regression and everything will be automatically for you. So I don't want to scare you with the maths and the formulas behind it, but it's always good to know how this formula was generated. So I hope you guys are clear with how logistic regression comes into the picture. Next, let us see what are the major differences between linear regression versus logistic regression. Now, first of all, in linear regression, we have the value of y as a continuous variable, or the variable which we need to predict are continuous in nature. Whereas in logistic regression, we have the categorical variable. So here the value which you need to predict should be discrete in nature. It should be either 0 or 1, or it should have just two values to it. So for example, whether it is raining or it is not raining. Is it humid outside or it is not humid outside? Now, does it going to snow or it is not going to snow? So these are the few examples where you need to predict where the values are discrete, or you can just predict whether this is happening or not. Next, linear regression solves your regression problems. So here you have a concept of independent variable and a dependent variable. So here you can calculate the value of y which you need to predict using the value of x. So here your y variable, or you can say the value that you need to predict, are in a range. But whereas in logistic regression you have discrete values. So logistic regression basically solves your classification problem. So it can basically classify it and it can just give you result whether this event is happening or not. So I hope it is pretty much clear till now. Next, in linear regression, the graph that you have seen is a straight line graph. So over here you can calculate the value of y with respect to the value of x. Whereas in logistic regression, the curve that we got was a S curve, or you can say the sigmoid curve. So using the sigmoid function, you can predict your y values. Moving ahead, let us see the various use cases wherein logistic regression is implemented in real life. So the very first is weather prediction. Now logistic regression helps you to predict your weather. For example, it is used to predict whether it is raining or not, whether it is sunny, is it cloudy or not. So all these things can be predicted using logistic regression. Whereas you need to keep in mind that both linear regression and logistic regression can be used in predicting the weather. So in that case, linear regression helps you to predict what will be the temperature tomorrow. Whereas logistic regression will only tell you whether it's going to rain or not, or whether it's cloudy or not, whether it's going to snow or not. So these values are discrete. Whereas if you apply linear regression, you'll be predicting things like what is the temperature tomorrow, or what is the temperature day after tomorrow, and all those things. So these are the slight differences between linear regression and logistic regression. Now moving ahead, we have classification problem. So Python performs multi-class classification. So here it can help you tell whether it's a bird or it's not a bird. Then you can classify different kind of mammals. Let's say whether it's a dog or it's not a dog. Similarly, you can check it for reptile, whether it's a reptile or not a reptile. So in logistic regression, it can perform multi-class classification. So this point I have already discussed that it is used in classification problems. Next, it also helps you to determine the illness as well. So let me take an example. Let's say a patient goes for a routine checkup in a hospital. So what doctor will do, it will perform various tests on the patient and will check whether the patient is actually ill or not. So what will be the features? So doctor can check the sugar level, the blood pressure, then what is the age of the patient, is it very small or is it an old person, then what is the previous medical history of that patient, and all of these features will be recorded by the doctor. And finally, doctor checks the patient data and determines the outcome of an illness and the severity of illness. So using all the data, a doctor can identify whether a patient is ill or not. So these are the various use cases in which you can use logistic regression. Now I guess enough of theory part, so let's move ahead and see some of the practical implementation of logistic regression. So over here I'll be implementing two projects wherein I have the data set of a Titanic. So over here we'll predict what factors made people more likely to survive the sinking of the Titanic ship. And in my second project, we'll see the data analysis on the SUV cars. So over here we have the data of the SUV cars, who can purchase it, and what factors made people more interested in buying SUV. So these will be the major questions as to why you should implement logistic regression and what output will you get by it. So let's start by the very first project, that is Titanic data analysis. So some of you might know that there was a ship called as Titanic which basically hit an iceberg and it sunk to the bottom of the ocean. And it was a big disaster at that time because it was the first voyage of the ship and it was supposed to be really strongly built and one of the best ships of that time. So it was a big disaster of that time, and of course, there's a movie about this as well. So many of you might have watched it. So what we have data of the passengers, those who survived and those who did not survive in this particular tragedy. So what you have to do, you have to look at this data and analyze which factors would have been contributed the most to the chances of a person's survival on the ship or not. So using the logistic regression, we can predict whether the person survived or the person died. Now, apart from this, we'll also have a look with the various features along with that. So first, let us explore the data set. So over here, we have the index value. Then the first column is passenger ID. Then my next column is survived. So over here, we have two values, a 0 and a 1. So 0 stands for did not survive and 1 stands for survived. So this column is categorical where the values are discrete. Next, we have passenger class. So over here, we have three values, 1, 2, and 3. So this basically tells you that whether a passenger is traveling in the first class, second class, or third class. Then we have the name of the passenger, we have the sex, or you can say the gender of the passenger, whether passenger is a male or female. Then we have the age, we have the SIB SP. So this basically means the number of siblings or the spouses aboard the Titanic. So over here we have values such as 1, 0, and so on. Then we have Patch. So Patch is basically the number of parents or children aboard the Titanic. So over here we also have some values. Then we have the ticket number, we have the fare, we have the cabin number, and we have the embarked column. So in my embarked column, we have three values. We have S, C, and Q. So S basically stands for Southampton, C stands for Cherbourg, and Q stands for Queenstown. So these are the features that we'll be applying our model on. So here we'll perform various steps and then we'll be implementing logistic regression. So now these are the various steps which are required to implement any algorithm. So now in our case we are implementing logistic regression. So our very first step is to collect your data or to import the libraries that are used for collecting your data and then taking it forward. Then my second step is to analyze your data. So over here I can go to the various fields and then I can analyze the data. I can check did the females or children survive better than the males, or did the rich passenger survive more than the poor passenger, or did the money matter, as in who paid more to get into the ship, were they evacuated first, and what about the workers, does the worker survived, or what is the survival rate if you were the worker in the ship and not just a traveling passenger. So all of these are very interesting questions and you would be going through all of them one by one. So in this stage you need to analyze your data and explore your data as much as you can. Then my third step is to wrangle your data. Now data wrangling basically means cleaning your data. So over here you can simply remove the unnecessary items, or if you have a null values in the data set, you can just clear that data and then you can take it forward. So in this step you can build your model using the trained data set and then you can test it using the test. So over here you will be performing a split which basically split your data set into training and testing data set. And finally you will check the accuracy so as to ensure how much accurate your values are. So I hope you guys got these 5 steps that we're going to implement in logistic regression. So now let's go into all these steps in detail. So number one, we have to collect your data, or you can say import the libraries. So let me just show you the implementation part as well. So I'll just open my Jupyter notebook and I'll just implement all of these steps side by side. So guys, this is my Jupyter notebook. So first let me just rename the Jupyter notebook to, let's say, Titanic data analysis. Now our first step was to import all the libraries and collect the data. So let me just import all the libraries first. So first of all, I'll import pandas. So pandas is used for data analysis. So I'll say import pandas as PD. Then I'll be importing NumPy. So I'll say import NumPy as NP. So NumPy is a library in Python which basically stands for numerical Python, and it is widely used to perform any scientific computation. Next, we'll be importing Seaborn. So Seaborn is a library for statistical plotting. So I'll say import Seaborn as SNS. I'll also import Matplotlib. So Matplotlib library is again for plotting. So I'll say import matplotlib.pyplot as PLT. Now to run this library in Jupyter Notebook, all I have to write in is percentage matplotlib inline. Next, I'll be importing one module as well so as to calculate the basic mathematical functions. So I'll say import maths. So these are the libraries that I'll be needing in this Titanic data analysis. So now let me just import my data set. So I'll take a variable, let's say Titanic data. And using the pandas, I will just read my CSV, or you can say the data set. I'll write the name of my data set, that is titanic.csv. Now I have already showed you the data set. So over here, let me just print the top 10 rows. So for that, I'll just say, I'll take the variable Titanic data dot head and I'll say the top 10 rows. So now I'll just run this. So to run this, I just have to press Shift plus Enter, or else you can just directly click on this cell. So over here, I have the index, we have the passenger ID, which is nothing but again the index which is starting from 1. Then we have the survived column, which has the categorical values, or you can say the discrete values, which is in the form of 0 or 1. Then we have the passenger class, we have the name of the passenger, sex, age, and so on. So this is the dataset that I'll be going forward with. Next, let us print the number of passengers which are there in this original dataset. So for that, I'll just simply type in print. I'll say number of passengers. And using the length function, I can calculate the total length. So I'll say length, and inside this, I'll be passing this variable, which is Titanic data. So I'll just copy it from here. I'll just paste it dot index. And next, so let me just print this one. So here the number of passengers which are there in the original data set we have is 891. So around this number were traveling in the Titanic ship. So over here my first step is done, where you have just collected data, imported all the libraries, and find out the total number of passengers which are traveling in Titanic. So now let me just go back to presentation and let's see what is my next step. So we're done with the collecting data. Next step is to analyze your data. So over here we'll be creating different plots to check the relationship between variables, as in how one variable is affecting the other. So you can simply explore your dataset by making use of various columns, and then you can plot a graph between them. So you can either plot a correlation graph, you can plot a distribution graph. It's up to you guys. So let me just go back to my Jupyter notebook and let me analyze some of the data. Over here, my second part is to analyze data. So I just put this in header 2. Now to put this in header 2, I just have to go on code, click on markdown, and I just run this. So first let us plot a count plot, where you compare between the passengers who survived and who did not survive. So for that, I'll be using the Seaborn library. So over here, I have imported Seaborn as SNS. So I don't have to write the whole name. I'll simply say sns.countplot. I'll say X is who survived. And the data that I'll be using is the Titanic data. Or you can say the name of variable in which you have stored your data set. So now let me just run this. So over here, as you can see, I have survived column on my x-axis, and on the y-axis, I have the count. So 0 basically stands for did not survive, and 1 stands for the passengers who did survive. So over here, you can see that around 550 of the passengers who did not survive, and there were around 350 passengers who only survived. So here you can basically conclude that there are very less survivors than non-survivors. So this was the very first plot. Now let us plot another plot to compare the sex as to whether out of all the passengers who survived and who did not survive, how many were men and how many were female. So to do that, I'll simply say sns.countplot. I'll add the hue as sex. So I want to know how many females and how many males survived. Then I'll be specifying the data, so I'm using Titanic data set. And let me just run this. Okay, I've done a mistake over here. So over here you can see I have survived column on the x-axis and I have the count on the y. Now, so here your blue color stands for your male passengers and orange stands for your female. So as you can see here, the passengers who did not survive, that has a value 0. So we can see that majority of males did not survive. And if we see the people who survived, here we can see the majority of females survived. So this basically concludes the gender of the survival rate. So it appears on average women were more than 3 times more likely to survive than men. Next, let us plot another plot where we have the hue as the passenger class. So over here we can see which class that the passenger was traveling in, whether it was traveling in class 1, 2 or 3. So for that, I'll just write the same command. I'll say sns.countplot. I'll keep my x-axis as subject only. I'll change my hue to passenger class. So my variable is named as P class. And the data set that I'll be using is Titanic data. So this is my result. So over here you can see I have blue for first class, orange for second class, and green for the third class. So here the passengers who did not survive were majorly of the third class, or you can say the lowest class or the cheapest class to get into the Titanic. And the people who did survive majorly belong to the higher classes. So here 1 and 2 has more rise than the passenger who were traveling in the third class. So here we have concluded that the passengers who did not survive were majorly of third class, or you can say the lowest class. and the passengers who were traveling in first and second class would tend to survive more. Next, let us plot a graph for the age distribution. Over here, I can simply use my data. So I'll be using pandas library for this. I'll declare an array and I'll pass in the column that is age. So I plot and I want a histogram. So I'll say plot.hist. So you can notice over here that we have more of young passengers, or you can say the children between the ages 0 to 10. And then we have the average age people. And if you go ahead, lesser would be the population. So this is the analysis on the age column. So we saw that we have more young passengers and more mediocre age passengers which are traveling in the Titanic. So next, let me plot a graph of fare as well. So I'll say Titanic data. I'll say fare. And again, I'll plot a histogram. So I'll say hist. So here you can see the fare size is between 0 to 100. Now let me add the bin size so as to make it more clear. So over here I'll say bin is equals to, let's say, 20, and I'll increase the figure size as well. So I'll say fixed size. Let's say I'll give the dimensions as 10 by 5. Okay, so it is bins. So this is more clear now. Next, let us analyze the other columns as well. So I'll just type in Titanic data, and I want the information as to what all columns are left. So here we have passenger ID, which I guess it's of no use. Then we have to see how many passengers survived and how many did not. We also see the analysis on the gender basis. We saw whether female tend to survive more or the men tend to survive more. Then we saw the passenger class, whether passenger is traveling in the first class, second class, or third class. Then we have the name. So in name we cannot do any analysis. We saw the sex, we saw the age as well. Then we have SIB-SP. So this stands for the number of siblings or the spouses which are aboard the Titanic. So let us do this as well. So I'll say sns.countplot. I'll mention X as SIB-SP, and I'll be using the Titanic data. So you can see the plot over here. So over here you can conclude that it has the maximum value on 0. So you can conclude that neither a children nor a spouse was on board the Titanic. Now second most highest value is 1. And then we have very less values for 2, 3, 4, and so on. Next, if I go above, we saw this column as well. Similarly, you can do for Parj. So next we have Parj, or you can say the number of parents or children which were aboard the Titanic. So similarly, you can do this as well. Then we have the ticket number. So I don't think so any analysis is required for ticket. Then we have fare. So fare we have already discussed. As in the people who tend to travel in the first class usually pay the highest fare. Then we have the cabin number and we have embarked. So these are the columns that we'll be doing data wrangling on. So we have analyzed the data and we have seen quite a few graphs in which we can conclude which variable is better than the another, or what is the relationship they hold. So third step is my data wrangling. So data wrangling basically means cleaning your data. So if you have a large data set, you might be having some null values, or you can say NaN values. So it's very important that you remove all the unnecessary items that are present in your data set. So removing this directly affects your accuracy. So I'll just go ahead and clean my data by removing all the NaN values and unnecessary columns which has a null value in the data set. So next I'll be performing data wrangling. So first of all, I'll check whether my data set is null or not. So I'll say Titanic data, which is the name of my data set, and I'll say is null. So this will basically tell me what all values are null and it will return me a Boolean result. So this basically checks the missing data and your result will be in Boolean format, as in the result will be true or false. So false means if it is not null and true means if it is null. So let me just run this. So over here you can see the values as false or true. So false is where the value is not null and true is where the value is null. So over here you can see in the cabin column we have the very first value which is null. So we have to do something on this. So you can see that we have a large data set, so the counting does not stop, and we can actually see the sum of it. We can actually print the number of passengers who have the NaN value in each column. So I'll say Titanic underscore data is null and I want the sum of it. So I'll say dot sum. So this will basically print the number of passengers who have the NaN values in each column. So we can see that we have missing values in each column, that is 177. Then we have the maximum value in the cabin column. And we have very less in the embarked column, that is 2. So here if you don't want to see these numbers, you can also plot a heat map and then you can visually analyze it. So let me just do that as well. So I'll say sns.heatmap. I'll say white tick labels. false. So I'll just run this. So as we have already seen that there were 3 columns in which missing data value was present. So this might be age. So over here, almost 20% of age column has a missing value. Then we have the cabin columns. So this is quite a large value. And then we have 2 values for embarked column as well. Add a CMAP for color coding. So I'll say CMAP. So if I do this, so the graph becomes more attractive. So over here, your yellow stands for true, or you can say the values are null. So here we have concluded that we have the missing value of age, we have a lot of missing values in the cabin column, and we have very less value which is not even visible in the embarked column as well. So to remove these missing values, you can either replace the values and you can put in some dummy values to it, or you can simply drop the column. So here let us first pick the age column. So first let me just plot a box plot and they will analyze with having a column as age. So I'll say sns dot box plot. I'll say X is equals to passenger class. So it's P class. I'll say Y is equals to age. And the data set that I'll be using is Titanic set. So I'll say data is equals to Titanic data. You can see the age in first class and second class tends to be more older rather than we have it in the third class. Well, that depends on the experience, how much you earn, or might be there n number of reasons. So here we concluded that passengers who were traveling in class 1 and class 2 tend to be older than what we have in the class 3. So we have found that we have some missing values in M. Now one way is to either just drop the column or you can just simply fill in some values to that. So this method is called as imputation. Now to perform data wrangling or cleaning, let us first print the head of the data set. So I'll say Titanic.head, sorry, it's Titanic underscore data. Let's say I just want the 5 rows. So here we have survive, which is again categorical. So in this particular column, I can apply logistic regression. So this can be my Y value or the value that I need to predict. Then we have the passenger class, we have the name, then we have ticket number, fare, cabin. So over here we have seen that in cabin we have a lot of null values, or you can say the NaN values, which is quite visible as well. So first of all, we'll just drop this column. So for dropping it, I'll just say Titanic underscore data, and I'll simply type in drop and the column which I need to drop. So I have to drop the cabin column. I'll mention the axis equals to 1 and I'll say in place also to true. So now again I'll just print the head and let us see whether this column has been removed from the data set or not. So I'll say Titanic.head. So as you can see here, we don't have cabin column anymore. Now you can also drop the NA values. So I'll say Titanic data dot drop all the NA values, or you can say NaN, which is not a number. And I'll say in place is equals to true. It's Titanic. So over here, let me again plot the heat map and let's say what the values which were before showing a lot of null values, has it been removed or not. So I'll say sns.heatmap, I'll pass in the data set. I'll check it is null. I'll say y tick labels is equals to false. And I don't want color coding, so again I'll say false. So this will basically help me to check whether my values has been removed from the data set or not. So as you can see here, I don't have any null values. So it's entirely black. Now you can actually know the sum as well. So I'll just go above. So I'll just copy this part and I'll just use the sum function to calculate the sum. So here that tells me that data set is clean, as in the data set does not contain any null value or any NaN value. So now we have wrangled our data, or you can say clean our data. So here we have done just one step in data wrangling, that is just removing one column out of it. Now you can do a lot of things. You can actually fill in the values with some other values, or you can just calculate the mean and then you can just fit in the null values. But now if I see my data set, so I'll say Titanic data.head. But now if I see over here, I have a lot of string values. So this has to be converted to categorical variables in order to implement logistic regression. So what we will do, we will convert this to categorical variable into some dummy variables. And this can be done using pandas, because logistic regression just take 2 values. So whenever you apply machine learning, you need to make sure that there are no string values present, because it won't be taking these as your input variables. So using string, you don't have to predict anything. But in my case, I have the survived columns. So I need to predict how many people tend to survive and how many did not. So 0 stands for did not survive and 1 stands for survive. So now let me just convert these variables into dummy variables. So I'll just use pandas and I'll say pd.getDummies. You can simply press tab to autocomplete. I'll say Titanic data and I'll pass the sex. So you can just simply click on Shift plus Tab to get more information on this. So here we have the type data frame and we have the passenger ID survived and the passenger class. So if you run this, you'll see that 0 basically stands for not a female and 1 stands for it is a female. Similarly for male, 0 stands for it's not male and 1 stands for male. Now we don't require both these columns because one column itself is enough to tell us whether it's male or you can say female or not. So let's say if I want to keep only male, I'll say if the value of male is 1, so it is definitely a male and it is not a female. So that is how you don't need both of these values. So for that, I'll just remove the first column, let's say female. So I'll say drop first and true. So over here it has given me just one column which is male and has the value 0 and 1. Now let me just set this as a variable, let's say sex. So over here I can say sex dot head. I just want to see the first 5 rows. Oh, sorry, it's dot. So this is how my data looks like. Now here we have done it for sex. Then we have the numerical values in age. We have the numerical values in spouses. Then we have the ticket number. We have the fare and we have embarked as well. So in embarked, the values are in S, C and Q. So here also we can apply this get dummy function. So let's say I'll take a variable, let's say embark. I'll use the pandas library. I'll enter the column name that is embarked. So let me just print the head of it. So I'll say embark.head. So over here we have C, Q and S. Now here also we can drop the first column because these two values are enough whether the passenger is either traveling for Q, that is Queenstown, S for Southampton, and if both the values are 0 then definitely the passenger is from Cherbourg, that is the third value. So you can again drop the first value. So I'll say drop and true. Let me just run this. So this is how my output looks like. Now similarly you can do it for passenger class as well. So here also we have 3 classes, 1, 2 and 3. So I'll just copy the whole statement. So let's say I want the variable name, let's say PCL. I'll pass in the column name that is P class and I'll just drop the first column. So here also the values would be 1, 2 or 3 and I'll just remove the first column. So here we just left with 2 and 3. So if both the values are 0, then definitely the passenger is traveling in the first class. Now we have made the values as categorical. Now my next step would be to concatenate all these new rows into a data set. Or you can say Titanic data. Using the pandas, we'll just concatenate all these columns. So I'll say pd.concat and I'll say we have to concatenate sex, we have to concatenate embark and PCL. And then I'll mention the access to 1. I'll just run this. Okay, I need to print the head. So over here you can see that these columns have been added over here. So we have the male column which basically tells whether a person is male or it's a female. Then we have the embarked which is basically Q and S. So if it's traveling from Queenstown, the value would be 1, else it would be 0. And if both of these values are 0, it is definitely traveling from Cherbourg. Then we have the passenger class as 2 and 3. So if the value of both these is 0, then the passenger is traveling in class 1. So I hope you got this till now. Now these are the irrelevant columns that we have it over here. So we can just drop these columns. We'll dropping P class, the embarked column, and the sex column. So I'll just type in Titanic data dot drop and I'll mention the columns that I want to drop. So I'll say I'll even delete the passenger ID because it's nothing but just the index value which is starting from 1. So I'll drop this as well. Then I don't want name as well, so I'll delete name as well. Then what else we can drop? We can drop the ticket as well. And then I'll just mention the access and I'll say in place is equals to true. Okay, so my column name starts from uppercase. So these has been dropped. Now let me just print my data set again. So this is my final data set, guys. We have the survived column which has the value 0 and 1. Then we have the passenger class. Oh, we forgot to drop this as well. So no worries, I'll drop this again. So now let me just run this. So over here we have the survived, we have the age, we have the SIB SP, we have the parch, we have fair, male, and these we have just converted. So here we have just performed data wrangling, or you can say clean the data, and then we have just converted the values of gender to male, then embarked to QNS and the passenger class to 2 and 3. So this was all about my data wrangling or just cleaning the data. Then my next step is training and testing your data. So here we will split the dataset into train subset and test subset. And then what we'll do, we'll build a model on the train data and then predict the output on your test dataset. So let me just go back to Jupyter and let us implement this as well. Over here, I need to train my dataset. So I'll just put this in heading 3. So over here, you need to define your dependent variable and independent variable. So here my y is the output, or you can say the value that I need to predict. So over here I'll write Titanic data. I'll take the column which is survived. So basically I have to predict this column whether the passenger survived or not. And as you can see, we have the discrete outcome, which is in the form of 0 and 1. And rest all the things we can take it as a features, or you can say independent variable. So I'll say Titanic data dot drop. So we'll just simply drop this survived and all the other columns will be my independent variable. So everything else are the features which leads to the survival rate. So once we have defined the independent variable and the dependent variable, next step is to split your data into training and testing subset. So for that we'll be using sklearn. I'll just type in from sklearn.cross validation import train test split. Now here, if you just click on shift and tab, you can go to the documentation and you can just see the examples over here. I'll click on plus to open it, and then I just go to examples and see how you can split your data. So over here you have xtrain, xtest, ytrain, ytest. And then using this train test split, you can just pass in your independent variable and dependent variable and just define a size and a random state to it. So let me just copy this and I'll just paste it over here. Over here we'll train, test, then we have the dependent variable train and test, and using the split function we'll pass in the independent and dependent variable, and then we'll set a split size. So let's say I'll put it at 0.3. So this basically means that your data set is divided in 0.3, that is in 70-30 ratio, and then I can add any random state to it. So let's say I'm applying 1. This is not necessary. If you want the same result as that of mine, you can add the random state. So this will basically take exactly the same sample every time. Next, I have to train and predict by creating a model. So here logistic regression will grab from the linear regression. So next I'll just type in from sklearn.linear model import logistic regression. Next I'll just create the instance of this logistic regression model. So I'll say log model is equals to logistic regression. Now I just need to fit my model, so I'll say log model dot fit, and I'll just pass in my xtrain and ytrain. Alright, so here it gives me all the details of logistic regression. So here it gives me the class weight, dual, fit, intercept, and all those things. Then what I need to do, I need to make prediction. So I'll take a variable, let's say predictions, and I'll pass on the model to it. So I'll say log model dot predict, and I'll pass in the value that is xtest. So here we have just created a model, fit that model, and then we had made predictions. So now to evaluate how my model has been performing, so you can simply calculate the accuracy, or you can also calculate a classification report. So don't worry guys, I'll be showing both of these methods. So I'll say from sklearn.metrics import classification report. So over here I'll use classification report, and inside this I'll be passing in ytest and the predictions. So guys, this is my classification report. So over here I have the precision, I have the recall, we have the F1 score, and then we have support. So here we have the value of precision as 75, 72, and 73, which is not that bad. Now, in order to calculate the accuracy as well, you can also use the concept of confusion matrix. So if you want to print the confusion matrix, I'll simply say from sklearn.metrics import confusion matrix first of all, and then we'll just print this. So here my function has been imported successfully. So I'll say confusion matrix, and I'll again pass in the same variables, which is ytest and predictions. So I hope you guys already know the concept of confusion matrix. So can you guys give me a quick confirmation as to whether you guys remember this confusion matrix concept or not? So if not, I can just quickly summarize this as well. Okay, Jagriti says a yes. Okay, Swati is not clear with this. So I'll just tell you in a brief what confusion matrix is all about. So confusion matrix is nothing but a 2 by 2 matrix which has 4 outcomes. This basically tells us that how accurate your values are. So here we have the column as predicted no, predicted y, and we have actual no and an actual yes. So this is the concept of confusion matrix. So here let me just feed in these values which we have just calculated. So here we have 105, 105, 21, 25 and 63. So as you can see here, we have got four outcomes. Now 105 is the value where a model has predicted no, and in reality it was also a no. So here we have predicted no and an actual no. Similarly, we have 63 as a predicted yes. So here the model predicted yes, and actually also it was a yes. So in order to calculate the accuracy, you just need to add the sum of these two values and just divide the whole by the sum. So here these two values tells me where the model has actually predicted the correct output. So this value is also called as true negative. This is called as false positive. This is called as true positive, and this is called as false negative. Now in order to calculate the accuracy, you don't have to do it manually. So in Python, you can just import accuracy score function and you can get the results from that. So I'll just do that as well. So I'll say from sklearn.metrics import accuracy score, and I'll simply print the accuracy. And I'll pass in the same variables, that is y-test and predictions. So over here it tells me the accuracy as 78, which is quite good. So over here, if you want to do it manually, you have to plus these two numbers, which is 105 plus 63. So this comes out to almost 168. And then you have to divide it by the sum of all the four numbers. So 105 plus 63 plus 21 plus 25. So this gives me a result of 214. So now if you divide these two numbers, you'll get the same accuracy, that is 78%, or you can say 0.78. So that is how you can calculate the accuracy. So now let me just go back to my presentation and let's see what all we have covered till now. So here we have first split our data into train and test subset. Then we have built our model on the train data and then predicted the output on the test data set. And then my fifth step is to check the accuracy. So here we have calculated accuracy to almost 78%, which is quite good. You cannot say that accuracy is bad. So here it tells me how accurate your results are. So here my accuracy score defines that, and hence we got a good accuracy. So now moving ahead, let us see the second project, that is SUV data analysis. So in this, a car company has released new SUV in the market, and using the previous data about the sales of their SUV, they want to predict the category of people who might be interested in buying this. So using the logistic regression, you need to find what factors made people more interested in buying this SUV. So for this, let us see a data set where I have user ID, I have gender as male and female, then we have the age, we have the estimated salary, and then we have the purchased column. So this is my discrete column, or you can say the categorical column. So here we just have the value, that is 0 and 1. And this column we need to predict whether a person can actually purchase a SUV or not. So based on these factors, we will be deciding whether a person can actually purchase a SUV or not. So we know the salary of a person, we know the age. And using these, we can predict whether a person can actually purchase a SUV or not. So let me just go to my Jupyter notebook and let us implement logistic regression. So guys, I will not be going through all the details of data cleaning and analyzing the part. So that part, I'll just leave it on you. So just go ahead and practice as much as you can. Alright. So my second project is SUV predictions. Alright. So first of all, I have to import all the libraries. So I say import numpy as np. And similarly, I'll do the rest of it. Alright. So now let me just print the head of this data set. So this we've already seen that we have columns as user ID, we have gender, we have the age, we have the salary, and then we have to calculate whether the person can actually purchase a SUV or not. So now let us just simply go on to the algorithm part. So we'll directly start off with the logistic regression, or how you can train a model. So for doing all those things, we first need to define an independent variable and a dependent variable. So in this case, I want my x, that is an independent variable. I say dataset.ilog. So here I'll be specifying all the rows. So colon basically stands for that. And in the columns, I want only 2 and 3 dot values. So here it should fetch me all the rows and only the second and third column, which is age and estimated salary. So these are the factors which will be used to predict the dependent variable, that is purchase. So here my dependent variable is purchase. And the dependent variable is of age and salary. So I'll say dataset.ilog. I'll have all the rows and I just want fourth column, that is my purchased column. dot values. All right, so I've just forgot one square bracket over here. All right, so over here I have defined my independent variable and dependent variable. So here my independent variable is age and salary, and dependent variable is the column purchase. Now you must be wondering, what is this ilog function? So ilog function is basically an indexer for pandas data frame, and it is used for integer based indexing, or you can also say selection by index. Now let me just print these independent variables and dependent variable. So if I print the independent variable, I have the age as well as the salary. Next, let me print the dependent variable as well. So over here, you can see I just have the values in 0 and 1. So 0 stands for did not purchase. Next, let me just divide my dataset into training and test subset. So I'll simply write in from sklearn.crossvalidation import train test. Next, I'll just press shift and tab, and over here I'll go to the examples and just copy the same line. So I'll just copy this. I'll remove the points. Now I want the text size to be, let's say, 25. So I have divided the train and test split in 75-25 ratio. Now let's say I'll take the random state as 0. So random state basically ensures the same result. Or you can say the same samples taken whenever you run the code. So let me just run this. Now you can also scale your input values for better performing. And this can be done using standard scaler. So let me do that as well. So I'll say from sklearn.preprocessing import standard scaler. Now, why do we scale it? Now, if you see our data set, we are dealing with large numbers. Well, although we are using a very small data set, so whenever you're working in a prod environment, you'll be working with large data set where you'll be using thousands and hundred thousands of tuples. So their scaling down will definitely affect the performance by a large extent. So here, let me just show you how you can scale down these input values. And then the pre-processing contains all your methods and functionality which is required to transform your data. So now let us scale down for test as well as a training data set. So I'll first make an instance of it. So I'll say standard scaler. Then I'll have xtrain. I'll say sc.fit, fit underscore transform. And I'll pass in my xtrain variable. And similarly, I can do it for test, wherein I'll pass the xtest. Alright. Now my next step is to import logistic regression. So I'll simply apply logistic regression by first importing it. So I'll say from sklearn.linear model import logistic regression. Now over here I'll be using classifier. So I'll say classifier dot is equals to logistic regression. So over here I'll just make an instance of it. So I'll say logistic regression. And over here I'll just pass in the random state which is 0. And now I'll simply fit the model. And I'll simply pass in xtrain and ytrain. So here it tells me all the details of logistic regression. Then I have to predict the value. So I'll say ypred is equals to classifier, then predict function, and then I'll just pass in xtest. So now we have created the model, we have scaled down our input values, then we have applied logistic regression, we have predicted the values, and now we want to know the accuracy. So to know the accuracy, first we need to import accuracy score. So I'll say from sklearn.metrics import accuracy score, and using this function we can calculate the accuracy, or you can manually do that by creating a confusion matrix. So I'll just pass in my y test and my y predicted. Alright, so over here I get the accuracy as 89%. So if we want to know the accuracy in percentage, so I just have to multiply it by 100, and if I run this, so it gives me 89%. So I hope you guys are clear with whatever I have taught you today. So here I have taken my independent variables as age and salary, and then we have calculated that how many people can purchase the SUV. And then we have calculated our model by checking the accuracy. So over here we get the accuracy as 89, which is great. Alright guys, so that is it for today. So I'll just discuss what all we have covered in today's training. So first of all, we had a quick introduction to what is regression and where regression is actually used. Then we have understood the types of regression and then got into the details of what and why of logistic regression. We have compared linear versus logistic regression. We have also seen the various use cases where you can implement logistic regression in real life. And then we have picked up two projects, that is Titanic data analysis and SUV prediction. So over here we have seen how you can collect your data, analyze your data, then perform modeling on that data, train the data, test the data, and then finally you have calculated the accuracy. So in your SUV prediction, you can actually analyze, clean your data, and you can do a lot of things. So you can just go ahead, pick up any data set and explore it as much as you can.
What is classification? I hope every one of you must have used Gmail. So how do you think the mail is getting classified as a spam or not a spam mail? Well, there's nothing but classification. So what it is? Well, classification is the process of dividing the data set into different categories or groups by adding label. In other way, you can say that it is a technique of categorizing the observation into different category. So basically what you're doing is you're taking the data, analyzing it, and on the basis of some condition, you finally divide it into various categories. Now, why do we classify it? Well, we classify it to perform predictive analysis on it. Like when you get the mail, the machine predicts it to be a spam or not a spam mail. And on the basis of that prediction, it adds the irrelevant or spam mail to the respective folder. In general, this classification algorithm handled questions like, is this data belongs to A category or a B category? Like, is this a male or is this a female? Something like that. Are you getting it? Okay, fine. Now the question arises, where will you use it? Well, you can use this for fraud detection or to check whether the transaction is genuine or not. Suppose I'm using a credit card here in India. Now, due to some reason, I had to fly to Dubai. Now, if I'm using the credit card over there, I'll get a notification alert regarding my transaction. They would ask me to confirm about the transaction. So this is also kind of predictive analysis, as the machine predicts that something fishy is in the transaction, as 24 hours ago, I made the transaction using the same credit card in India, and 24 hours later, the same credit card is being used for the payment in Dubai. So the machine predicts that something fishy is going on in the transaction. So in order to confirm it, it sends you a notification alert. Alright, well, this is one of the use case of classification. You can even use it to classify different items like fruits on the basis of its taste, color, size, or weight. A machine well trained using the classification algorithm can easily predict the class or the type of fruit whenever new data is given to it. Not just the fruit, it can be any item. It can be a car, it can be a house, it can be a signboard, or anything. Have you noticed that while you visit some sites or you try to log in into some, you get a picture capture for that, right? Where you have to identify whether the given image is of a car or it's of a pole or not. You have to select it. For example, there are 10 images and you're selecting 3 images out of it. So in a way, you're training the machine, right? You're telling that these 3 are the picture of a car and rest are not. So who knows, you're training it for something big, right? So moving on ahead, let's discuss the types of classification. Alright. Well, there are several different ways to perform a same task. Like in order to predict whether a given person is a male or a female, the machine had to be trained first. Alright. But there are multiple ways to train the machine, and you can choose any one of them. Just for predictive analytics, there are many different techniques, but the most common of them all is the decision tree, which we'll cover in depth in today's session. So as a part of classification algorithm, we have decision tree, random forest, naive Bayes, k-nearest neighbor, logistic regression, linear regression, support vector machines, and so on. There are many. Alright, so let me give you an idea about few of them. Starting with decision tree. Well, decision tree is a graphical representation of all the possible solution to a decision. The decisions which are made, they can be explained very easily. For example, here is a task which says that should I go to a restaurant or should I buy a hamburger? You are confused on that. So for that, what you'll do, you'll create a decision tree for it. Starting with the root node will be, first of all, you'll check whether you are hungry or not. Alright. If you're not hungry, then just go back to sleep. Right. If you are hungry and you have $25, then you'll decide to go to restaurant. And if you're hungry and you don't have $25, then you'll just go and buy a hamburger. That's it. Alright. So this is about decision tree. Now moving on ahead, let's see what is a random forest. Well, random forest build multiple decision trees and merges them together to get a more accurate and stable prediction. Alright, most of the time, random forest is trained with a bagging method. The bagging method is based on the idea that the combination of learning model increases the overall result. If you're combining the learning from different models and then clubbing it together, what it will do, it will increase the overall result. Fine. Just one more thing. If the size of your data set is huge, then in that case, one single decision tree would lead to a overfit model. Same way, like a single person might have its own perspective on the complete population, as the population is very huge, right? However, if we implement the voting system and ask different individual to interpret the data, then we would be able to cover the pattern in a much meticulous way. Even from the diagram, you can see that in section A, we have a large training data set. What we do, we first divide our training data set into n subsamples, all right, and we create a decision tree for each subsample. Now in the B part, what we do, we take the vote out of every decision made by every decision tree. And finally, we club the vote to get the random forest decision. Fine. Let's move on ahead. Next, we have naive Bayes. So naive Bayes is a classification technique which is based on Bayes' theorem. It assumes that presence of any particular feature in a class is completely unrelated to the presence of any other feature. Naive Bayes is simple and easy to implement algorithm. And due to its simplicity, this algorithm might outperform more complex model when the size of the dataset is not large enough. Alright, a classical use case of naive Bayes is a document classification. In that, what you do, you determine whether given text corresponds to one or more categories. In the text case, the features used might be the presence or absence of any keyword. So this was about naive. From the diagram, you can see that using naive Bayes, we have to decide whether we have a disease or not. First, what we do, we check the probability of having a disease and not having the disease, right? Probability of having a disease is 0.1, while on the other hand, probability of not having a disease is 0.9. Okay, first let's see when we have disease and we go to doctor, all right? So when we visited the doctor and the test is positive, so probability of having a positive test when you're having a disease is 0.80. And probability of a negative test when you already have a disease, that is 0.20. This is also a false negative statement as the test is detecting negative, but you still have the disease, right? So it's a false negative statement. Now let's move ahead when you don't have the disease at all. So probability of not having a disease is 0.9. And when you visit the doctor and the doctor is like, yes, you have the disease, but you already know that you don't have the disease. So it's a false positive statement. So probability of having a disease when you actually know there is no disease is 0.1. And probability of not having a disease when you actually know there is no disease. So, and the probability of it is around 0.90. Fine. It is same as probability of not having a disease. Even the test is showing the same result. It's a true positive statement. So it is 0.9. Alright. So let's move on ahead and discuss about KNN algorithm. So this KNN algorithm, or the K nearest neighbor, it stores all the available cases and classifies new cases based on the similarity measure. The K in the KNN algorithm is the nearest neighbor we wish to take vote from. For example, if k equal 1, then the object is simply assigned to the class of that single nearest neighbor. From the diagram, you can see the difference in the image when k equal 1, k equal 3, and k equal 5, right? Well, the modern systems are now able to use the k nearest neighbor for visual pattern recognition to scan and detect hidden packages in the bottom bin of a shopping cart at the checkout. If an object is detected which matches exactly to the object listed in the database, then the price of the spotted product could even automatically be added to the customer's bill. While this automated billing practice is not used extensively at this time, but the technology has been developed and is available for use. If you want, you can just use it. And yeah, one more thing. K nearest neighbor is also used in retail to detect patterns in the credit card users. Many new transaction scrutinizing software applications use KNN algorithms to analyze register data and spot unusual patterns that indicate suspicious activity. For example, if register data indicates that a lot of customers' information is being entered manually rather than through automated scanning and swapping, then in that case, this could indicate that the employees who are using the register are in fact stealing customers' personal information. Or if a register data indicates that a particular good is being returned or exchanged multiple times, this could indicate that employees are misusing the return policy or trying to make money from doing the fake returns, right? So this was about KNN algorithm. So starting with, what is decision tree? But first, let me tell you, why did we choose decision tree to start with? Well, these decision tree are really very easy to read and understand. It belongs to one of the few models that are interpretable where you can understand exactly why the classifier has made that particular decision. Right. Let me tell you a fact that for a given data set, you cannot say that this algorithm performs better than that. It's like you cannot say that decision tree is better than naive Bayes or naive Bayes performing better than decision tree. It depends on the data set, right? You have to apply hit and trial method with all the algorithms one by one and then compare the result. The model which gives the best result is the model which you can use it for better accuracy for your data set. Alright. So let's start with what is decision tree. Well, a decision tree is a graphical representation of all the possible solution to a decision based on certain conditions. Now you might be wondering why this thing is called as decision tree. Well, it is called so because it starts with a root and then branches off to a number of solutions just like a tree, right? Even the tree starts from a root and it starts growing its branches once it gets bigger and bigger. Similarly, in a decision tree, it has a root which keeps on growing with increasing number of decisions and the conditions. Now let me tell you a real life scenario. I won't say that all of you, but most of you must have used it. Remember, whenever you dial the toll-free number of your credit card company, it redirects you to his intelligent computerized assistant, where it asks you questions like press 1 for English, or press 2 for Hindi, press 3 for this, press 4 for that, right? Now once you select 1, now again it redirects you to a certain set of questions, like press 1 for this, press 1 for that, and similarly, right? So this keeps on repeating until you finally get to the right person, right? You might think that you are caught in a voicemail hell, but what the company was actually doing, it was just using a decision tree to get you to the right person. Alright, I'd like you to focus on this particular image for a moment. On this particular slide, you can see an image where the task is, should I accept a new job offer or not? Alright, so you have to decide that. For that, what you did, you created a decision tree. Starting with the base condition or the root node was that the basic salary or the minimum salary should be $50,000. If it is not $50,000, then you are not at all accepting the offer. Alright. So if your salary is greater than $50,000, then you will further check whether the commute is more than 1 hour or not. If it is more than 1 hour, you will just decline the offer. If it is less than 1 hour, then you are getting closer to accepting the job offer. Then further, what you'll do, you'll check whether the company is offering free coffee or not, right? If the company is not offering the free coffee, then you'll just decline the offer. And if it is offering the free coffee, then yeah, you will happily accept the offer, right? So this is just an example of a decision tree. Now let's move ahead and understand a decision tree. Well, here is a sample data set that I'll be using it to explain you about the decision tree. Alright. In this data set, each row is an example, and the first 2 columns provide features or attributes that describes the data, and the last column gives the label or the class we want to predict. And if you like, you can just modify this data by adding additional features and more example, and our program will work in exactly the same way. Fine. Now this data set is pretty straightforward except for one thing. I hope you have noticed that it is not perfectly separable. Let me tell you something more about that. As in the second and fifth examples, they have the same features but different labels. Both have yellow as their color and diameter as 3, but the labels are mango and lemon. Fine. Let's move on and see how our decision tree handles this case. Alright. In order to build a tree, we'll use a decision tree algorithm called CART. The CART algorithm stands for Classification and Regression Tree Algorithm. Alright. Let's see a preview of how it works. Alright. To begin with, we'll add a root node for the tree, and all the nodes receive a list of rows as input, and the root will receive the entire training data set. Now each node will ask true and false question about one of the feature, and in response to that question, we'll split or partition the data set into 2 different subsets. These subsets then become input to 2 child nodes we add to the tree, and the goal of the question is to finally unmix the labels as we proceed down, or in other words, to produce the purest possible distribution of the labels at each node. For example, the input of this node contains only one single type of label, so we could say that it's perfectly unmixed. There is no uncertainty about the type of label, as it consists of only grapes, right? On the other hand, the labels in this node are still mixed up. So we would ask another question to further drill it down, right? But before that, we need to understand which question to ask and when. And to do that, we need to quantify how much question helps to unmix the label. And we can quantify the amount of uncertainty at a single node using a metric called Gini impurity. And we can quantify how much a question reduces that uncertainty using a concept called information gain. We'll use these to select the best question to ask at each point. And then what we'll do, we'll iterate the steps, we'll recursively build the tree on each of the new node. We'll continue dividing the data until there are no further questions to ask. And finally, we reach to our leaf. Alright, so this was about decision tree. So in order to create a decision tree, first of all, what you have to do, you have to identify different set of questions that you can ask to the tree. Like, is this color green? And what will be these questions? These questions will be decided by your data set. Like, is this color green? Is the diameter greater than or equal to 3? Is the color yellow? Right. Questions resembles to your data set. Remember that. All right. So if my color is green, then what it will do, it will divide into two parts. First, the green mango will be in the true, while on the false, we have lemon and the mango. All right. If the color is green or the diameter is greater than or equal to 3 or the color is yellow. Now let's move on and understand about decision tree terminologies. Alright, so starting with root node. Root node is the base node of a tree. The entire tree starts from a root node. In other words, it is the first node of a tree. It represents the entire population or sample, and this entire population is further segregated or divided into two or more homogeneous sets. Fine. Next is the leaf node. Well, leaf node is the one when you reach at the end of the tree. Right, that is, you cannot further segregate it down to any other level. So that is the leaf node. Next is splitting. Splitting is dividing your root node or your node into different subpart on the basis of some condition. Alright. Then comes the branch or the subtree. Well, this branch or subtree gets formed when you split the tree. Suppose when you split a root node, it gets divided into two branches or two subtrees. Right. Next is the concept of pruning. Well, you can say that pruning is just opposite of splitting. What we are doing here, we are just removing the subnode of a decision tree. We'll see more about pruning later in this session. Alright, let's move on ahead. Next is parent or child node. Well, first of all, root node is always the parent node, and all other nodes associated with that is known as child node. Well, you can understand it in a way that all the top node belongs to a parent node, and all the bottom node which are derived from a top node is a child node. The node producing a further node is a child node, and the node which is producing it is a parent node. Simple concept, right? Let's use the CART algorithm and design a tree manually. So first of all, what do? You decide which question to ask and when. So how will you do that? So let's first of all visualize the decision tree. So this is the decision tree which we'll be creating manually. Alright, first of all, let's have a look at the data set. You have outlook, temperature, humidity, and windy as your different attributes. On the basis of that, you have to predict that whether you can play or not. So which one among them should you pick first? Answer: determine the best attribute that classifies the training data. Alright, so how will you choose the best attribute, or how does a tree decide where to split, or how the tree will decide its root node? Well, before we move on and split a tree, there are some terminologies that you should know. Alright, first being the Gini index. So what is this Gini index? This Gini index is the measure of impurity or purity used in building a decision tree in CART algorithm. Alright. Next is information gain. This information gain is the decrease in entropy after a data set is split on the basis of an attribute. Constructing a decision tree is all about finding an attribute that returns the highest information gain. Alright. So you'll be selecting the node that would give you the highest information gain. Alright. Next is reduction in variance. This reduction in variance is an algorithm which is used for continuous target variable or regression problems. The split with lower variance is selected as a criteria to split the population. See, in general term, what do you mean by variance? Variance is how much your data is varying, right? So if your data is less impure or it is more pure, then in that case, the variation would be less as all the data are almost similar, right? So this is also a way of splitting a tree. The split with lower variance is selected as a criteria to split the population, alright? Next is the chi-square. Chi-square, it is an algorithm which is used to find out the statistical significance between the differences between subnodes and the parent nodes. Fine, let's move ahead. Now the main question is, how will you decide the best attribute? For now, just understand that you need to calculate something known as information gain. The attribute with the highest information gain is considered the best. Yeah, I know your next question might be like, what is this information gain? But before we move on and see what exactly information gain is, Let me first introduce you to a term called entropy, because this term will be used in calculating the information gain. Well, entropy is just a metric which measures the impurity of something, or in other words, you can say that it's the first step to do before you solve the problem of a decision tree. As I mentioned here something about impurity, so let's move on and understand what is impurity. Suppose you have a basket full of apples and another bowl which is full of same label which says apple. Now if you are asked to pick one item from each basket and bowl, then the probability of getting the apple and its correct label is 1. So in this case you can say that impurity is 0. Alright. Now what if there are 4 different fruits in the basket and 4 different labels in the bowl? Then the probability of matching the fruit to a label is obviously not 1. It's something less than that. Well, it could be possible that I picked banana from the basket, and when I randomly pick the label from the ball, it says a cherry. Any random permutation and combination can be possible. So in this case, I would say that impurities is non-zero. I hope the concept of impurity is clear. So coming back to entropy, as I said, entropy is the measure of impurity. From the graph on your left, you can see that as the probability is 0 or 1, that is either they are highly impure or they are highly pure, then in that case the value of entropy is 0. And when the probability is 0.5, then the value of entropy is maximum. Well, what is impurity? Impurity is the degree of randomness, how random a data is. So if the data is completely pure, in that case the randomness equals 0. Or if the data is completely impure, even in that case the value of impurity will be 0. Question like why is it that the value of entropy is maximum at 0.5 might arise in your mind, right? So let me discuss about that. Let me derive it mathematically. So as you can see here on the slide, the mathematical formula of entropy is minus of probability of yes. Let's move on and see what this graph has to say mathematically. Suppose S is our total sample space and it's divided into 2 parts, yes and no. Like in our data set, the result for playing was divided into 2 parts, either yes or no, which we have to predict either we have to play or not, right? So for that particular case, you can define the formula of entropy as entropy of total sample space equals negative of probability of yes multiplied by log of probability of yes with a base 2 minus probability of no multiplied by log of probability of no with base 2, where S is your total sample space and P of yes is the probability of yes and P of no is the probability of no. Well, if the number of yes equal number of no, that is probability of S equals 0.5, right? Since you have equal number of yes and no. So in that case, value of entropy will be 1. Just put the value over there. All right. Let me just move to the next slide. I'll show you this. All right. Next is if it contains all yes or all no, that is probability of a sample space is either 1 or 0. Then in that case, entropy will be equal to 0. Let's see it mathematically one by one. So let's start with the first condition where the probability was 0.5. So this is our formula for entropy, right? So this is our first case, right? Which we discussed that when the probability of yes equal probability of no, that is in our data set, we have equal number of yes and no. All right. So probability of yes equal probability of no, and that equals 0.5. Or in other words, you can say that yes plus no equal to total sample space. All right. Since the probability is 0.5, so when you put the values in the formula, you get something like this. And when you calculate it, you'll get the entropy of the total sample space as 1. All right. Let's see for the next case. What was the next case? Either you have total yes or you have total no. So if you have total yes, let's see the formula when we have total yes. So you have all yes and 0 no. Fine. So probability of yes equal 1. And yes is the total sample space, obviously. So in the formula, when you put that thing up, you will get entropy of sample space equal negative times of 1 multiplied by log of 1. As the value of log 1 equals 0, so the total thing will result to 0. Similarly is the case with no. Even in that case, you'll get the entropy of total sample space as 0. So this was all about entropy. All right. Next is, what is information gain? Well, information gain, what it does, it measures the reduction in entropy. It decides which attribute should be selected as the decision node. If S is our total collection, then information gain equals entropy, which we calculated just now, that minus weighted average multiplied by entropy of each feature. Don't worry, we'll just see how to calculate it with an example. All right. So let's manually build a decision tree for our dataset. So this is our dataset, which consists of 14 different instances, out of which we have 9 yes and 5 no. Alright. So we have the formula for entropy, just put over that. Since 9 yes, so total probability of yes equals 9 by 14 and total probability of no equals 5 by 14. And when you put up the value and calculate the result, you will get the value of entropy as 0.94. Alright. So this was your first step, that is compute the entropy for the entire dataset. Alright. Now you have to select that out of outlook, temperature, humidity, and windy, which of the node should you select as the root node? Big question, right? How will you decide that this particular node should be chosen at the base node? And on the basis of that only, I'll be creating the entire tree. How you'll select that? Let's see. So you have to do it one by one. You have to calculate the entropy and information gain for all of the different nodes. So starting with outlook. So outlook has 3 different parameters: sunny, overcast, and rainy. So first of all, select how many number of yes and no are there in the case of sunny. Like when it is sunny, how many number of yes and how many number of no's are there. So in total, we have 2 yes and 3 no's in case of sunny. In case of overcast, we have all yes. So if it is overcast, then we'll surely go to play. It's like that. All right. And next it is rainy. Then total number of yes equal 3 and total number of no equals 2. Fine. Next, what we do, we calculate the entropy for each feature. For here, we are calculating the entropy when outlook equals sunny. First of all, we are assuming that outlook is our root node, and for that, we are calculating the information gain for it. All right. So in order to calculate the information gain, remember the formula. It was entropy of the total sample space minus weighted average multiplied by entropy of each feature. All right. So what we are doing here, we are calculating the entropy of outlook when it was sunny. So total number of yes when it was sunny was 2, and total number of no, that was 3. Fine. So let's put up in the formula. Since the probability of yes is 2 by 5 and the probability of no is 3 by 5, so you will get something like this. All right. So you are getting the entropy of sunny as 0.971. Fine. Next, you'll calculate the entropy for overcast. When it was overcast, remember it was all yes, right? So the probability of yes equal 1. And when you put over that, you'll get the value of entropy as 0. Fine. And when it was rainy, rainy has 3 yes and 2 no's. So probability of yes in case of sunny is 3 by 5 and probability of no in case of sunny is 2 by 5. And when you add the value of probability of yes and probability of no to the formula, you get the entropy of sunny as 0.971. Fine. Now you have to calculate how much information you're getting from outlook. That equals weighted average. All right. So what was this weighted average? Total number of yes and total number of no. Fine. So information from outlook equals 5 by 14. From where does this 5 came over? We are calculating the total number of sample space within that particular outlook when it was sunny, right? So in case of sunny, there was 2 yes and 3 no's. All right. So weighted average for sunny would be equal to 5 by 14. All right. Since the formula was 5 by 14 multiplied by entropy of each feature. All right. So as calculated, the entropy for sunny is 0.971, right? So what we'll do, we'll multiply 5 by 14 with 0.971, right? Well, this was a calculation for information when outlook equals sunny, but outlook even equals overcast and rainy. For in that case, what we'll do, again, similarly, we'll calculate for everything. For overcast and sunny, for overcast, weighted average is 4 by 14 multiplied by its entropy, that is 0. And for sunny, it is same 5 by 14, 3 yes and 2 no's multiplied by its entropy, that is 0.971. And finally, we'll take the sum of all of them, which equals to 0.693, right? Next, we'll calculate the information gained. This, what we did earlier was information taken from Outlook. Now we are calculating what is the information we are gaining from Outlook, right? Now this information gained, that equals to total entropy minus the information that is taken from Outlook. All right. So total entropy we had 0.94 minus information we took from Outlook is 0.693. So the value of information gained from Outlook results to 0.247. All right. So next, what we have to do, let's assume that windy is our root node. So windy consists of 2 parameters, false and true. Let's see how many yes and how many no's are there in case of true and false. So when windy has false as its parameter, then in that case, it has 6 yes and 2 no's. And when it has true as its parameter, it has 3 yes and 3 no's. All right. So let's move ahead and similarly calculate the information taken from Wendy and finally calculate the information gained from Wendy. All right. So first of all, what we'll do, we'll calculate the entropy of each feature, starting with Wendy equal true. So in case of true, we had equal number of yes and equal number of no. Well, remember the graph when we had the probability as 0.5 as total number of yes equal total number of no, and for that case the entropy equals 1. So we can directly write entropy of true when it's Wendy is 1, as we had already proved it. When probability equals 0.5, the entropy is the maximum, that equals to 1. All right. Next is entropy of false when it is Wendy. All right. So similarly, just put the probability of yes and no in the formula and then calculate the result. Since you have 6 yes and 2 no's, so in total you'll get the probability of yes as 6 by 8 and probability of no as 2 by 8. All right. So when you will calculate it, you will get the entropy of false as 0.811. All right. Now let's calculate the information from Wendy. So total information collected from Wendy equals information taken when Wendy equal true plus information taken when Wendy equal false. So we'll calculate the weighted average for each one of them and then we'll sum it up to finally get the total information taken from Wendy. So in this case, it equals to 8 by 14 multiplied by 0.811 plus 6 by 14 multiplied by 1. What is this 8? 8 is total number of yes and no in case when Wendy equals false, right? So when it was false, so total number of yes that equals to 6 and total number of no that equal to 2, that sum ups to 8. All right. So that is why the weighted average results to 8 by 14. Similarly, information taken when Wendy equals true equals to 3 plus 3, that is 3 yes and 3 no, equals 6 divided by total number of sample space, that is 14, multiplied by 1. That is entropy of true. All right. So it is 8 by 14 multiplied by 0.811 plus 6 by 14 multiplied by 1, which results to 0.892. This is information taken from Wendy. All right. Now, how much information you are gaining from Wendy? So for that, what you'll do, so total information gained from Wendy, that equals to total entropy minus information taken from Wendy. All right. That is 0.94 minus 0.892. That equals to 0.048. So 0.048 is the information gained from Wendy. All right. Similarly, we calculated for the rest too. All right. So for Outlook, as you can see, the information was 0.693 and its information gain was 0.247. In case of temperature, the information was around 0.911 and the information gain that was equal to 0.029. In case of humidity, the information gain was 0.152 and in the case of Wendy, the information gain was 0.048. So what we'll do, we'll select the attribute with the maximum mode. Fine. Now we have selected Outlook as our root node and it is further subdivided into 3 different parts: sunny, overcast and rain. So in case of overcast, we have seen that it consists of all yes. So we can consider it as a leaf node. But in case of sunny and rainy, it's doubtful as it consists of both yes and both no. So you need to recalculate the things, right? Again, for this node, you have to recalculate the things. All right. You have to again select the attribute which is having the maximum information gain. All right. So this is how your complete tree will look like. All right. So let's see when you can play. So you can play when Outlook is overcast. All right. In that case, you can always play. If the Outlook is sunny, you will further drill down to check the humidity condition. All right. If the humidity is normal, then you will play. If the humidity is high, then you won't play, right? When the Outlook predicts that it's rainy, then further you'll check whether it's windy or not. If it has a weak wind, then you'll go and opt for play. But if it has strong wind, then you won't play, right? So this is how your entire decision tree would look like at the end. Now comes the concept of pruning. It says that what should I do to play? Well, you have to do pruning. Pruning will decide how you will play. What is this pruning? Well, this pruning is nothing but cutting down the nodes in order to get the optimal solution. All right. So what pruning does, it reduces the complexity. All right. As here you can see on the screen that it's showing only the result for yes. That is, it's showing all the result which says that you can play. All right. Before we drill down to a practical session, a common question might come in your mind. You might think that a tree-based model better than linear model, right? You can think like, if I can use a logistic regression for classification problem and linear regression for regression problem, then why there is a need to use the tree? Well, many of us have this question in their mind, and well, there's a valid question too. Well, actually, as I said earlier, you can use any algorithm. It depends on the type of problem you're solving. Let's look at some key factor which will help you to decide which algorithm to use and when. So the first point being, if the relationship between dependent and independent variable is well approximated by a linear model, then linear regression will outperform tree-based model. Second case, if there is a high non-linearity and complex relationship between dependent and independent variables, a tree model will outperform a classical regression model. In third case, if you need to build a model which is easy to explain to people, a decision tree model will always do better than a linear model, as the decision tree models are simpler to interpret than linear regression. Alright? Now let's move on ahead and see how you can write a decision tree classifier from scratch in Python using the CART algorithm. Alright? For this, I'll be using Jupyter Notebook with Python 3.0 installed on it. Alright? So let's open the Anaconda and the Jupyter Notebook. Where is that? So this is our Anaconda navigator, and I'll directly jump over to Jupyter Notebook and hit the launch button. I guess everyone knows that Jupyter Notebook is a web-based interactive computing notebook environment where you can run your Python codes. So my Jupyter Notebook, it opens on my localhost 8891. So I'll be using this Jupyter Notebook in order to write my decision tree classifier using Python. For this decision tree classifier, I have already written the set of codes. Let me explain you just one by one. So we'll start with initializing our training data set. So there's our sample data set for which each row is an example. The last column is a label and the first two columns are the features. If you want, you can add some more features and example for your practice. Interesting fact is that this data set is designed in a way that the second and the fifth example have almost the same features, but they have different labels. Alright, so let's move on and see how the tree handles this case. As you can see here, both of them, the second and the fifth column, have the same features. What they differ in is just their label. Fine. So let's move ahead. So this is our training data set. Next, what we are doing, we are adding some column labels. So they are used only to print the trees. Fine. So what we'll do, we'll add header to the columns. Like the first column is of color, second is of diameter, and third is of label column. All right. Next, what we'll do, we'll define a function as unique values in which we'll pass the rows and the columns. So this function, what it will do, it will find the unique values for a column in the data set. So there's an example for that. So what we are doing here, we are passing training data as our row and column number as 0. So what we are doing, we are finding unique values in terms of color. And in this, since the row is training data and the column is 1, so what we are doing here, so we are finding the unique values in terms of diameter. Fine. So this is just an example. Next, what we'll do, we'll define a function as class count and we'll pass the rows into it. So what it does, it counts the number of each type of example within a data set. So in this function, what we are basically doing, we are counting the number of each type of example in the data set. Or what we are doing, we are counting the unique values for the label in the data set. As a sample, you can see here, we can pass that entire training data set to this particular function as class underscore count. What it will do, it will find all the different types of label within the training data set. As you can see here, the unique label consists of mango, grape, and lemon. So next, what we'll do, we'll define a function is numeric and we'll pass a value into it. So what it will do, it will just test if the value is numeric or not, and it will return if the value is an integer or a float. For example, you can see is numeric, we are passing 7, so it is an integer, so it will return an int value. And if we are passing red, it's not a numeric value, right? So moving on ahead, we'll define a class named as question. So what this question does, this question is used to partition the data set. This class, what it does, it just records a column number. For example, 0 for color, alright, and a column value, for example, green. Next, what we are doing, we are defining a match method, which is used to compare the feature value in the example to the feature value stored in the question. Let's see how. First of all, what we are doing, we are defining an init function. And inside that, we are passing the self, column, and the value as parameter. So next, what we do, we define a function as match. What it does, it compares the feature value in an example to the feature value in this question. Fine. Next, we'll define a function as REPR, which is just a helper method to print the question in a readable format. Next, what we are doing, we are defining a function partition. Well, this function is used to partition the data set. Each row in the data set, it checks if it matches the question or not. If it does, so it adds it to the true rows, or if not, then it adds to the false rows. Alright. For example, as you can see here, let's partition the training data set based on whether the rows are red or not. Here we are calling the function question and we are passing a value of 0 and red to it. So what it will do, it will assign all the red rows to true underscore rows, and everything else will be assigned to false underscore rows. Fine. Next, what we'll do, we'll define a Gini impurity function, and inside that we'll pass the list of rows. So what it will do, it will just calculate the Gini impurity for the list of rows. Next, what we are doing here, we're defining a function as information gain. So what this information gain function does, it calculates the information gain using the uncertainty of the starting node minus the weighted impurity of the child node. The next function is find the best split. Well, this function is used to find the best question to ask by iterating over every feature or value and then calculating the information gain. For the detailed explanation on the code, you can find the code in the description given below. Alright. Next, we'll define a class as leaf for classifying the data. It holds a dictionary of class like Mango for how many times it appears in the row from the training data that reaches this leaf. Alright. Next is the decision node. So this decision node, it will ask a question. This holds a reference to the question and to the two child nodes. On the basis of it, you are deciding which node to add further to which branch. Alright. So next what we are doing, we are defining a function of build tree, and inside that we are passing our number of rows. So this is the function that is used to build the tree. So initially what we did, we defined all the various functions that we'll be using in order to build a tree. So let's start by partitioning the data set for each unique attribute. Then we'll calculate the information gain and then return the question that produces the highest gain. And on the basis of that, we'll split the tree. So what we are doing here, we are partitioning the data set, calculating the information gain, and then what this is returning, it is returning the question that is producing the highest gain. All right. Now, if gain equals 0, return leaf rows. So what it will do, so if we are getting no for the gain, that is gain equals 0, then in that case, since no further question could be asked, so what it will do, it will return a leaf. Fine. Now true underscore rows or false underscore rows equal partition with rows and the question. So if we are reaching till this position, then you have already found a feature or value which will be used to partition the dataset. Then what you will do, you will recursively build the true branch and similarly recursively build the false branch. So return decision underscore node, and inside that we'll be passing question, true branch and false branch. So what it will do, it will return a question node. And this question node just records the best feature or the value to ask at this point. Fine. Now that we have built our tree, next what we'll do, we'll define a print underscore tree function which will be used to print the tree. Fine. So finally what we are doing in this particular function, that we are printing our tree. Next is the classify function, which will use it to decide whether to follow the true branch or the false branch, and then compare to the feature or value stored in the node to the example we are considering. And last, what we'll do, we'll finally print the prediction at the leaf. So let's execute it and see. Okay, so this is our testing data. All right, so we printed our leaf as well. Now that we have trained our algorithm with our training data set, now it's time to test it. So this is our testing data set. So let's finally execute it and see what is the result. So this is the result you will get. So first question which is asked by the algorithm is diameter greater than or equal to 3? If it is true, then it will further ask if the color is yellow. Again, if it is true, then it will predict mango as 1 and lemon with 1. All right. And in case it is false, then it will just predict the mango. Now this was the true part. Now next coming to if diameter is not greater than or equal to 3, then in that case it's false. And what it will do, it will just predict the grape. Fine. Okay, so this was all about the coding part. Now let's conclude this session, but before concluding, let me just show you one more thing. Now there's a scikit-learn algorithm cheat sheet which explains you which algorithm you should use and when. Alright, it's built in a decision tree format. Let's see how it is built. So first condition, it will check whether you have 50 samples or not. If your samples are greater than 50, then it will move ahead. If it is less than 50, then you need to collect more data. If your sample is greater than 50, then you have to decide whether you want to predict a category or not. If you want to predict a category, then further you will see that whether you have labeled data or not. If you have labeled data, then that would be a classification algorithm problem. If you don't have the labeled data, then it would be a clustering problem. Now, if you don't want to predict a category, then what do you want to predict? Predict a quantity? Well, if you want to predict a quantity, then in that case, it would be a regression problem. If you don't want to predict a quantity and you want to keep looking further, then in that case, you should go for dimensionality reduction problems. And still, if you don't want to look and the predicting structure is not working, then you have tough luck for that. I hope this decision tree session clarifies all your doubt over decision tree algorithm.
Now we'll try to find out the answer to this particular question as to why we need random forest. Fine. So, like human beings learn from their past experiences. So, unlike human beings, a computer does not have experiences. Then how does machine takes decisions? Where does it learn from? Well, a computer system actually learns from the data, which represents some past experiences of an application domain. So now let's see how random forest helps in building up the learning model with a very simple use case of credit risk detection. Now, needless to say that credit card companies have a very nested interest in identifying financial transactions that are illegitimate and criminal in nature. And also I would like to mention this point that according to the Federal Reserve Payments Study, Americans used credit cards to pay for 26.2 billion purchases in 2012. And the estimated loss due to unauthorized transactions that year was US $6.1 billion. Now, in the banking industry, measuring risk is very critical because the stakes are too high. So the overall goal is actually to figure out who all can be fraudulent before too much financial damage has been done. So for this, a credit card company receives thousands of applications for new cards, and each application contains information about an applicant, right? So here, as you can see that from all those applications, what we can actually figure out is our predictive variables, like what is the marital status of that person, what is the gender of the person, what is the age of the person, and the status, which is actually whether it is a default payer or a non-default payer. So default payments are basically when payments are not made in time and according to the agreement signed by the cardholder. So now that account is actually said to be in the default. So you can easily figure out the history of the particular cardholder from this. Then we can also look at the time of payment, whether he has been a regular payer or a non-regular one, what is the source of income for that particular person, and so forth. So to minimize loss, the bank actually needs certain decision rule to predict whether to approve a particular loan of that particular person or not. Now here is where the random forest actually comes into the picture, right? Now let's see how random forest can actually help us in this particular scenario. Now we have taken randomly two parameters out of all the predictive variables that we saw previously. Now we have taken two predictive variables here. The first one is the income and the second one is the age, right? And similarly, parallelly, two decision trees have been implemented upon those predicted variables. Now let's first assume the case of the income variable, right? So here we have divided our income into three categories. The first one being the person earning over $35,000, second from $15,000 to $35,000, the third one earning in the range of $0 to $15,000. Now, if a person is earning over $35,000, which is a pretty good income, pretty decent, so now we'll check out for the credit history. Now here the probability is that if a person is earning a good amount, then there is very low risk that he won't be able to pay back. Already earning good, so the probability is that his application of loan will get approved, right? So there is actually low risk or moderate risk, but there's no real issue of high risk as such. We can approve the applicant's request here. Now let's move on and watch out for the second category where the person is actually earning from $15,000 to $35,000, right? Now here the person may or may not pay back. So in such scenarios, we'll look for the credit history as to what has been his previous history. Now if his previous history has been bad, like he has been a defaulter in the previous transactions, we'll definitely not consider approving his request and he'll be at the high risk end, which is not good for the bank. If the previous history of that particular applicant is really good, then we will, just to clarify our doubt, we'll consider another parameter as well, that will be our debt. Now, if he's already in really high debt, then the risks again increases, and there are chances that he might not repay in the future. So here we'll not accept the request of the person having high debt. If the person is in the low debt and he has been a good payer in his past history, then there are chances that he might pay back, and we can consider approving the request of this particular applicant. Now let's look at the third category, which is a person earning from $0 to $15,000. Now this is something which actually raises the eyebrow, and this person will actually lie in the category of high risk. All right, so the probability is that his application of loan will probably get rejected. Now we'll get one final outcome from this income parameter, right? Now let us look at our second variable, that is age, which will lead into the second decision tree. Now let us say if the person is young, right? So now we'll look forward to if it is a student. Now if it is a student, then the chances are high that he won't be able to repay back because he has no earning source, right? So here the risks are too high, and the probability is that his application of loan will get rejected. Fine. Now if the person is young and he's not a student, then we'll probably go on and look for another variable, that is bank balance. Now let's look if the bank balance is less than 5 lakhs. So again the risk arises, and the probability is that his application of loan will get rejected. Now if the person is young, he is not a student, and he has a bank balance of greater than 5 lakhs, he's got a pretty good and stable bank balance, then the probability is that his loan of application will get approved of. Now let us take another scenario. If he's a senior, right? So if he's a senior, we'll probably go and check out for his credit history. How well has he been in his previous transactions? What kind of a person he's like, whether he's a defaulter or he's a non-defaulter. Now if he's a very fair kind of person in his previous transactions, then again the risk arises, and the probability of his application getting rejected actually increases, right? Now if he has been an excellent person as per his transactions in the previous history, so now again here there is least risk, and the probability is that his application of loan will get approved. So now here these two variables, income and age, have led to two different decision trees, right? And these two different decision trees actually led to two different results. Now what random forest does is it will actually compile these two different results from these two different decision trees, and then finally it will lead to a final outcome. That is how random forest actually works, right? So that is actually the motive of the random forest. Now let us move forward and see what is random forest, right? You can get an idea of the mechanism from the name itself, random forest. So a collection of trees is a forest, that's why called forest probably. And here also the trees are actually because being trained on subsets which are being selected at random, and therefore they're called random forests. So a random forest is a collection or an ensemble of decision trees, right? Here a decision tree is actually built using the whole data set considering all features. But actually in random forest only a fraction of the number of rows is selected, and that too at random, and a particular number of features which are actually selected at random are trained upon, and that is how the decision trees are built upon, right? So similarly, a number of decision trees will be grown, and each decision tree will result into a certain final outcome, and random forest will do nothing but actually just compile the results of all those decision trees to bring out the final result. As you can see in this particular figure, that a particular instance actually has resulted into 3 different decision trees, right? So now tree 1 results into a final outcome called class A, and tree 2 results into class B. Similarly, tree 3 results into class B. So random forest will compile the results of all these decision trees, and it will go by the call of the majority voting. Now since here 2 decision trees have actually voted into the favor of the class B, that is decision tree 2 and 3, therefore the final outcome will be in the favor of the class B. And that is how random forest actually works upon. Now, one really beautiful thing about this particular algorithm is that it is one of the versatile algorithms which is capable of performing both regression as well as classification. Now, let's try to understand random forest further with a very beautiful example. All right, this is my favorite one. So let's say you want to decide if you want to watch Edge of Tomorrow or not, right? So in this particular scenario, you will have two different actions to work upon. Either you can just straight away go to your best friend, ask him about, all right, whether should I go for Edge of Tomorrow or not? Will I like this movie? Or you can ask a bunch of friends and take their opinion in consideration, and then based on the final result, you can go out and watch Edge of Tomorrow, right? So now let's just take the first scenario. So where you go to your best friend, ask about whether you should go out to watch Edge of Tomorrow or not. So your friend will probably ask you certain questions, like the first one being here, genre. So let's say your friend asks you if you really like the adventurous kind of movies or not. So you say, yes, definitely, I would love to watch adventure kind of movie. So the probability is that you will like Edge of Tomorrow as well, since Edge of Tomorrow is also a movie of adventure and sci-fi kind of genre, right? So let's say you do not like the adventure genre movie. So then again, the probability reduces that you might really not like Edge of Tomorrow, right? So from here, you can come to a certain conclusion, right? Let's say your best friend puts you into another situation where he'll ask you, all right, do you like Emily Blunt? And you say, definitely I like Emily Blunt. And then he puts another question to you. Do you like Emily Blunt to be in the main lead? And you say, yes. Then again, the probability arises that you will definitely like Edge of Tomorrow as well, because Edge of Tomorrow has the Emily Blunt in the main lead cast. So, and if you say, oh, I do not like Emily Blunt, then again, the probability reduces that you would like Edge of Tomorrow too, right? So this is one way where you have one decision tree and your final outcome, your final decision will be based on your one decision tree, or you can say your final outcome will be based on just one friend. Now, definitely, you're not really convinced. You want to consider the options of your other friends also, so that you can make very precise and crisp decision, right? You go out and you approach some other bunch of friends of yours. So now let's say you go to 3 of your friends and you ask them the same question, whether I would like to watch Edge of Tomorrow or not. So you go and approach 3 of your friends, friend 1, friend 2, and friend 3. Now you will consider each of theirs vote, and then your decision now will be dependent on the compiled results of all of your 3 friends, right? Now here, let's say you go to your first friend and you ask him whether you would like to watch Edge of Tomorrow or not. And your first friend puts you to one question. Did you like Top Gun? And you say, yes, definitely, I did like the movie Top Gun. Then the probability is that you would like Edge of Tomorrow as well, because Top Gun is actually a military action drama, which is also Tom Cruise. So now again, the probability arises that yes, you will like Edge of Tomorrow as well. And if you say, no, I didn't like Top Gun, then again, the chances are that you wouldn't like Edge of Tomorrow, right? Then another question that he puts you across is that, do you really like to watch action movies? And you say, yes, I would love to watch them. Then again, the chances are that you would like to watch Edge of Tomorrow. So from your friend one, you can come to one conclusion. Now here, since the ratio of liking the movie to don't like is actually 2:1, so the final result is actually you would like Edge of Tomorrow. Now you go to your second friend and you ask the same question. So now your second friend asks you, did you like Far and Away when we went out and the last time when we watched it? And you say, no, I really didn't like Far and Away. Then you would say, then you are definitely going to like Edge of Tomorrow. Why it is so? Because Far and Away is actually, since most of you might not be knowing it, so Far and Away is genre of romance, and it revolves around a girl and a guy falling in love with each other and so on. So the probability is that you wouldn't like Edge of Tomorrow. So he asks you another question. Did you like Oblivion? And do you really like to watch Tom Cruise? And you say yes. And again, the probability is that you would like to watch Edge of Tomorrow. Now, why? Because Oblivion again is a science fiction casting Tom Cruise, full of strange experiences, and where Tom Cruise is the savior of the mankind. Well, that is the same kind of plot in Edge of Tomorrow as well. So here it is pure yes that you would like to watch Edge of Tomorrow. So you get another second decision from your second friend. Now you go to your third friend and ask him. So probably your third friend is not really interested in having any sort of conversation with you. So it just simply asks you, did you like Godzilla? And you say, no, I didn't like Godzilla. So he said, definitely you wouldn't like Edge of Tomorrow. Why so? Because Godzilla is also actually a science fiction movie from the adventure genre. So now you've got 3 results from 3 different decision trees from 3 different friends. Now you compile the results of all those friends and then you make a final call that yes, would you like to watch Edge of Tomorrow or not? So this is some very real time and very interesting example where you can actually implement random forest into ground reality, right? Any questions so far? No, that's good. And then we can move forward. Now let us look at various domains where random forest is actually used. So because of its diversity, random forest is actually used in various diverse domains, right? So be it banking, be it medicine, be it land use, be it marketing, name it and random forest is there. So in banking particularly, random forest is being actually used to make it out whether the applicant will be a defaulter pair or it will be a non-defaulter one, so that it can accordingly approve or reject the applications of loan, right? So that is how random forest is being used in banking. Talking about medicine, random forest is widely used in medicine field to predict beforehand what is the probability if a person will actually have a particular disease or not, right? So it's actually used to look at the various disease trends. Let's say you want to figure out what is the probability that a person will have diabetes or not. And so what would you do? You'll probably look at the medical history of the patient, and then you will see, all right, this has been the glucose concentration, what was the BMI, what was the insulin levels in the patient in the previous 3 months, what is the age of this particular person, and you will make different decision trees based on each one of these predicted variables, and then you will finally compile the results of all those variables, and then you will make a final decision as to whether the person will have diabetes in the near future or not. That is how random forest will be used in medicine sector. Now, random forest is also actually used to find out the land use. For example, I want to set up a particular industry in certain area. So what would I probably look for? I look for what is the vegetation over there, what is the urban population over there, right? And how much is the distance from the nearest modes of transport, like from the bus station or the railway station. And accordingly, I will split my parameters and I will make decision on each one of these parameters. And finally, I'll compile my decision of all these parameters, and that will be my final outcome. So that is how I'm finally going to predict whether I should put my industry at this particular location or not, right? So these 3 examples have actually been majorly around classification problem, because we are trying to classify whether or not. We're actually trying to answer this question, whether or not, right? Now let's move forward and look how marketing is revolving around random forest. So particularly in marketing, we try to identify the customer churn. So this is particularly the regression kind of problem, right? Now how? Let's see. So customer churn is nothing but actually the number of people which are actually, or the number of customers who are losing out. So who are going out of your market. Now you want to identify what will be your customer churn in near future. So most of the e-commerce industries are actually using this, like Amazon, Flipkart, etc. So they particularly look at your each behavior as to what has been your past history, what has been your purchasing history, what do you like based on your activity around certain things, around certain ads, around certain discounts, or around certain kind of materials, right? If you like a particular top, your activity will be more around that particular top. So that is how they track each and every particular move of yours, and then they try to predict whether you will be moving out or not. So that is how they identify the customer churn. So these all are various domains where random forest is used, and this is not the only list. So there are numerous other examples which actually are using random forests. That makes it so special actually. Now let's move forward and see how random forest actually works, right? So let us start with the random forest algorithm first. Let's just see it step by step as to how random forest algorithm works. So the first step is to actually select certain M features from T, where M is less than T. So here T is the total number of the predictor variables that you have in your data set, and out of those total predictor variables you will select some randomly, some few features out of those. Now why we are actually selecting a few features only? The reason is that if you will select all the predictive variables or the total predictor variables, then each of your decision tree will be same. So your model is not actually learning something new. It is learning the same previous thing because all those decision trees will be similar, right? Now, if you actually split your predicted variables and you select randomly a few predicted variables only, let's say there are 14 total number of variables, and out of those you randomly pick just 3, right? So every time you will get a new decision tree. So there will be variety, right? So the classification model will be actually much more intelligent than the previous one. Now it has got varied experiences, so definitely it will make different decisions each time. And then when you will compile all those different decisions, it will be a new, more accurate and efficient result, right? So the first important step is to select certain number of features out of all the features. Now let's move on to the second step. Let's say for any node D. Now the first step is to calculate the best split at that point. So you know that decision tree, how decision tree is actually implemented. So you pick up the most significant variable, right? And then you will split that particular node into further child nodes. That is how the split takes place, right? So you will do it for M number of variables that you have selected. Let's say you have selected 3, so you will implement the split at all those 3 nodes in one particular decision tree, right? The third step is split of the node into 2 daughter nodes. So now you can split your root node into as many nodes as you want to, but here we'll split our node into 2 daughter nodes as to this or that. So it will be an answer in terms of this or that, fine. Our fourth step will be to repeat all these 3 steps that we've done previously, and we'll repeat all this splitting until we have reached all the n number of nodes, right? So we need to repeat until we have reached till the leaf nodes of our decision tree. That is how we will do it, right? Now after these 4 steps we will have our one decision tree, but random forest is actually about multiple decision trees. So here our 5th step will come into the picture, which will actually repeat all these previous steps for D number of times. Now here D is the D number of decision trees. Let's say I want to implement 5 decision trees. So my 5th step will be to implement all the previous steps 5 times. So here the iteration is for 5 number of times, right? Now once I have created these 5 decision trees, still my task is not complete yet. Now my final task will be to compile the results of all these 5 different decision trees, and I will make a call on the majority voting, right? Here as you can see in this picture, I had n different instances, then I created n different decision trees, and finally I will compile the result of all these n different decision trees, and I will take my call on the majority voting, right? So whatever my majority vote says, that will be my final result. So this is basically an overview of the random forest algorithm, how it actually works. Let's just have a look at this example to get much better understanding of what we have learned. So let's say I have this data set which consists of 4 different instances, right? So basically it consists of the weather information of previous 14 days, right? From D1 till D14. And this basically outlook, humidity and wind, this basically gives me the weather condition of those 14 days. And finally, I have play, which is my target variable, whether match did take place on that particular day or not, right? Now my main goal is to find out whether the match will actually take place if I have following these weather conditions with me on any particular day. Let's say if the outlook is rainy that day and humidity is high and the wind is very weak. So now I need to predict whether I will be able to play the match that day or not. All right. So this is a problem statement. Fine. Now let's see how random forest is used in this to sort it out. Now here the first step is to actually split my entire data set into subsets. Here I have split my entire 14 variables into further smaller subsets, right? Now these subsets may or may not overlap, like there is certain overlapping between D1 till D3 and D3 till D6, fine? So there is an overlapping of D3. So it might happen that there might be overlapping. So you need not really worry about the overlapping. But you have to make sure that all those subsets are actually different, right? So here I have taken 3 different subsets. My first subset consists of D1 till D3. My second subset consists of D3 till D6. And my third subset consists of D7 till D now. Now I will first be focusing on my first subset. Now here let's say that particular day the outlook was overcast. Fine. If yes, it was overcast, then the probability is that the match will take place. So overcast is basically when your weather is too cloudy. So if that is the condition, then definitely the match will take place. Now let's say it wasn't overcast, then you will consider the second most probable option, that will be the wind, and you will make your decision based on this now. Whether wind was weak or strong. If wind was weak, then you will definitely go out and play the match, else you would not. So now the final outcome out of this decision tree will be play, because here the ratio between the play and no play is 2:1. So we get to a certain decision from a first decision tree. Now let us look at the second subset. Now since second subset has different number of variables, so that is why this decision tree is absolutely different from what we saw in our first subset. So let's say if it was overcast, then you will play the match. If it isn't the overcast, then you would go and look out for humidity. Now further, it will get split into 2, whether it was high or normal. Now we'll take the first case. If the humidity was high and wind was weak, then you will play the match. Else, if humidity was high but wind was too strong, then you would not go out and play the match, right? Now let us look at the second daughter node of humidity. If the humidity was normal and the wind was weak, then you will definitely go out and play the match, else you won't go out and play the match. So here, if you look at the final result, then the ratio of plays to no play is 3:2. Then again, the final outcome is actually play, right? So from second subset, we get the final decision of play. Now let us look at our third subset, which consists of D7 till D9. Here, if again the overcast is yes, then you will play match, else you will go and check out for humidity. And if the humidity is really high, then you won't play the match, else you will play the match. Again, the probability of playing the match is yes, because the ratio of no play is 2:1, right? So 3 different subsets, 3 different decision trees, 3 different outcomes, and 1 final outcome after compiling all the results from these 3 different decision trees. All right. So I hope this gives a better perspective, a better understanding of random forest, like how it really works. All right. So now let's just have a look at various features of random forest, right? So the first and the foremost feature is that it is one of the most accurate learning algorithms, right? So why it is so? Because single decision trees are actually prone to having high variance or high bias. And on the contrary, actually random forests, it averages the entire variance across the decision trees. So let's say if the variance is say X for decision tree, But for random forest, let's say we have implemented n number of decision trees parallelly. So my entire variance gets averaged upon, and my final variance actually becomes x upon n. So that is how the entire variance actually goes down as compared to other algorithms, right? Now, second most important feature is that it works well for both classification and regression problems. And by far, I have come across this is one and the only algorithm which works equally well for both of them, be it classification kind of problem or a regression kind of problem, right? Then it really runs efficient on large databases. So basically, it's really scalable. Even if you work for the lesser amount of database, or if you work for really huge volume of data, right? So that's a very good part about it. Then the fourth most important point is that it requires almost no input preparation. Now, why am I saying this is because it has got certain implicit methods which actually take care and remove all the outliers and all the missing data, and you really don't have to take care about all that thing while you are in the stages of input preparation. So random forest is all here to take care of everything else. And next is it performs implicit feature selection. Right. So while we are implementing multiple decision trees, so it has got implicit method which will automatically pick up some random features out of all your parameters, and then it will go on and implementing different decision trees. So for example, if you just give one simple command that, all right, I want to implement 500 decision trees, no matter how, so random forest will automatically take care and it will implement all those 500 decision trees, and those all 500 decision trees will be different from each other. And this is because it has got implicit methods which will automatically collect different parameters itself out of all the variables that you have, right? Then it can be easily grown in parallel. Why it is so? Because we are actually implementing multiple decision trees, and all those decision trees are running, or all those decisions trees are actually getting implemented parallelly. So if you say I want 1,000 trees to be implemented, so all those 1,000 trees are getting implemented parallelly. So that is how the computation time reduces down, right? And the last point is that it has got methods for balancing error in unbalanced data sets. Now, what exactly unbalanced data sets are? Let me just give you an example of that. So let's say you're working on a data set, fine, and you create a random forest model and get 90% accuracy immediately. Fantastic, you think, right? So now you start diving deep, you go a little deeper, and you discover that 90% of that data actually belongs to just one class. Damn, now your entire data set, your entire decision is actually biased to just one particular class. So random forest actually takes care of this thing, and it is really not biased towards any particular decision tree or any particular variable or any class. So it has got methods which looks after it, and they does all the balance of errors in your data sets. So that's pretty much about the features of random forests.
What is KNN algorithm? Well, K nearest neighbor is a simple algorithm that stores all the available cases and classify the new data or case based on a similarity measure. It suggests that if you are similar to your neighbors, then you are one of them, right? For example, if apple looks more similar to banana, orange, or melon rather than a monkey, rat, or a cat, then most likely apple belong to the group of fruits. All right? Well, in general, KNN is used in search application where you're looking for similar items. That is, when your task is some form of find items similar to this one, then you call this search as a KNN search. But what is this K in KNN? Well, this K denotes the number of nearest neighbor which are voting class of the new data or the testing data. For example, if K equal 1, then the testing data are given the same label as the closest example in the training set. Similarly, if K equal 3, the labels of the 3 closest classes are checked and the most common label is assigned to the testing data. So this is what a K in KNN algorithm means. So moving on ahead, let's see some of the example of scenarios where KNN is used in the industry. So let's see the industrial application of KNN algorithm, starting with recommender system. Well, the biggest use case of KNN search is a recommender system. This recommender system is like an automated form of a shop counter guy. When you ask him for a product, not only shows you the product, but also suggests you or displays you a relevant set of products which are related to the item you're already interested in buying. This KNN algorithm applies to recommending products like in Amazon, or for recommending media like in case of Netflix, or even for recommending advertisement to display to a user. If I'm not wrong, almost all of you must have used Amazon for shopping, right? So just to tell you, more than 35% of Amazon.com's revenue is generated by its recommendation engine. So what's their strategy? Amazon uses recommendation as a targeted marketing tool in both the email campaigns and on most of its website pages. Amazon will recommend many products from different categories based on what you're browsing, and it will pull those products in front of you which you're likely to buy, like the frequently bought together option that comes at the bottom of the product page to tempt you into buying the combo. Well, this recommendation has just one main goal, that is, increase average order value, or to upsell and cross-sell customers by providing product suggestion based on items in the shopping cart, or based on the product they are currently looking at on-site. So next industrial application of KNN algorithm is concept search, or searching semantically similar documents and classifying documents containing similar topics. So as you know, the data on the internet is increasing exponentially every single second. There are billions and billions of documents on the internet. Each document on the internet contains multiple concepts. That could be a potential concept. Now, there's a situation where the main problem is to extract concept from a set of documents, as each page could have thousands of combinations that could be potential concepts. An average document could have millions of concepts. Combine that to the vast amount of data on the web. Well, we are talking about an enormous amount of data set and sample. So what we need here, we need to find a concept from the enormous amount of data set and samples, right? So for this purpose, we'll be using KNN algorithm. More advanced example could include handwriting detection like in OCR or image recognition or even video recognition. All right. So now that you know various use cases of KNN algorithm, let's proceed and see how does it work. So how does a KNN algorithm work? Let's start by plotting these blue and orange point on our graph. So these blue points, they belong to class A, and the orange ones, they belong to class B. Now you get a star as a new point, and your task is to predict whether this new point, it belongs to class A or it belongs to class B. So to start the prediction, the very first thing that you have to do is select the value of K. Just as I told you, K in KNN algorithm refers to the number of nearest neighbors that you want to select. For example, in this case, K equals 3. So what does it mean? It means that I'm selecting 3 points which are the least distance to the new point. Or you can say I'm selecting 3 different points which are closest to the star. Well, at this point of time, you can ask, how will you calculate the least distance? So once you calculate the distance, you'll get 1 blue and 2 orange points which are closest to the star. Now, since in this case, as we have a majority of orange points, so you can say that for K equals 3, the star belongs to class B. Or you can say that the star is more similar to the orange points. Moving on ahead. Well, what if K equal to 6? Well, for this case, you have to look for 6 different points which are closest to the star. So in this case, after calculating the distance, we find that we have 4 blue points and 2 orange points which are closest to the star. Now, as you can see that the blue points are in majority, so you can say that for K equals 6, the star belongs to class A, or the star is more similar to blue points. So by now, I guess you know how a KNN algorithm works and what is the significance of K in KNN algorithm. So how will you choose the value of K? So keeping in mind this K is the most important parameter in KNN algorithm. So let's see, when you build a K nearest neighbor classifier, how will you choose the value of K? Well, you might have a specific value of K in mind, or you could divide up your data and use something like cross-validation technique to test several values of K in order to determine which works best for your data. For example, if n equal 1000 cases, then in that case, the optimal value of K lies somewhere in between 1 to 19. But yes, unless you try it, you cannot be sure of it. So you know how the algorithm is working on a higher level. Let's move on and see how things are predicted using KNN algorithm. Remember, I told you the KNN algorithm uses the least distance measure in order to find its nearest neighbors. So let's see how these distances calculated. Well, there are several distance measures which can be used. So to start with, we'll mainly focus on Euclidean distance and Manhattan distance in this session. So what is this Euclidean distance? Well, this Euclidean distance is defined as the square root of the sum of difference between a new point x and an existing point y. So for example, here we have point P1 and P2. Point P1 is 1, 1 and point P2 is 5, 4. So what is the Euclidean distance between both of them? So you can say that Euclidean distance is the direct distance between 2 points. So what is the distance between the point P1 and P2? So we can calculate it as 5 minus 1 whole square plus 4 minus 1 whole square, and we can root it over, which results to 5. So next is the Manhattan distance. Well, this Manhattan distance is used to calculate the distance between real vector using the sum of their absolute difference. In this case, the Manhattan distance between the point P1 and P2 is mod of 5 minus 1 plus mod value of 4 minus 1, which results to 3 plus 4, that is 7. So this slide shows the difference between Euclidean and Manhattan distance from point A to point B. So Euclidean distance is nothing but the direct or the least possible distance between A and B, whereas the Manhattan distance is the distance between A and B measured along the axis at right angle. Let's take an example and see how things are predicted using K-NN algorithm, or how the K-NN algorithm is working. Suppose we have a data set which consists of height, weight, and t-shirt size of some customers. Now when a new customer comes, we only have his height and weight as the information. Now our task is to predict what is the t-shirt size of that particular customer. So for this, we'll be using the K-NN algorithm. So the very first thing what we need to do, we need to calculate the Euclidean distance. So now that you have a new data of height 161 centimeter and weight as 61 kg, so the very first thing that we'll do is we'll calculate the Euclidean distance, which is nothing but the square root of 161 minus 158 whole square plus 61 minus 58 whole square. And square root of that is 4.24. Let's drag and drop it. So these are the various Euclidean distance of other points. Now let's suppose k equal to 5. Then the algorithm, what it does, it searches for the 5 customer closest to the new customer. That is more similar to the new data in terms of its attribute. For k equal 5, let's find the top 5 minimum Euclidean distance. So these are the distance which we are going to use: 1, 2, 3, 4, and 5. So let's rank them in the order. First, this is second, this is third, then this one is fourth, and again this one is 5. So this is our order. So for k equal 5, we have 4 t-shirts which come under size M and 1 t-shirt which comes under size L. So obviously, best guess or the best prediction for the t-shirt size of height 161 centimeter and weight 61 kg is M. Or you can say that our new customer will fit into size M. Well, this was all about the theoretical session, but before we drill down to the coding part, let me just tell you why people call K-NN as a lazy learner. Well, K-NN for classification is a very simple algorithm, but that's not why they are called lazy. K-NN is a lazy learner because it doesn't have a discriminative function from the training data, but what it does, it memorizes the training data. There is no learning phase of the model, and all of the work happens at the time a prediction is requested. So as such, this is the reason why K-NN is often referred to as lazy learning algorithm. So this was all about the theoretical session. Now let's move on to the coding part. So for the practical implementation of the hands-on part, I'll be using the IRIS dataset. So this dataset consists of 150 observation. We have 4 features and 1 class label. The 4 features include the sepal length, the sepal width, petal length, and the petal width, whereas the class label decides which flower belongs to which category. So this was the description of the dataset which we are using. Now let's move on and see what are the step-by-step solution to perform a K-NN algorithm. So first we'll start by handling the data. What we have to do, we have to open the dataset from the CSV format and split the dataset into train and test part. Next, we'll check the similarity, where we have to calculate the distance between 2 data instances. Once we calculate the distance, next we'll look for the neighbor and select k neighbors which are having the least distance from a new point. Now once we get our neighbor, then we'll generate a response from a set of data instances. So this will decide whether the new point belongs to class A or class B. Finally, we'll create the accuracy function, and in the end, we'll tie it all together in the main function. So let's start with our code. For implementing K-NN algorithm using Python, I'll be using Jupyter Notebook, Python 3.0 installed on it. Now let's move on and see how K-NN algorithm can be implemented using Python. So there's my Jupyter Notebook, which is a web-based interactive computing notebook environment with Python 3.0 installed on it. It's at the launch. Yeah, it's launching. So there's our Jupyter Notebook, and we'll be writing our Python codes on it. So the first thing that we need to do is load our file. Our data is in CSV format without a header line or any code. We can open the file, the open function, and read the data line using the reader function in the CSV module. So let's write a code to load our data file. Let's execute the run button. So once you execute the run button, you can see the entire training data set as the output. Next, we need to split the data into a training data set that KNN can use to make prediction and a test data set that we can use to evaluate the accuracy of the model. So we first need to convert the flour measure that were loaded as string into numbers that we can work. Next, we need to split the data set randomly into train and test. A ratio of 67:33 for test is to train is a standard ratio which is used for this purpose. So let's define a function as load dataset that loads a CSV with a provided file name and split it randomly into training and test dataset using the provided split ratio. So this is our function load dataset, which is using file name, split ratio, training dataset, and testing dataset as its input. All right, so let's execute the run button and check for any errors. So it's executed with 0 errors. Let's test this function. So this is our training set, testing set, load data set. So this is our function load data set, and inside that we are passing our file iris data with a split ratio of 0.66 and training data set and test data set. Let's see what our training data set and test data set it's dividing into. So it's giving a count of training data set and testing data set. The total number of training data set it has split into is 97 and total number of test data set we have is 53. So total number of training data set we have here is 97 and total number of test data set we have here is 53. All right. Okay. So our function load data set is performing well. So let's move ahead to step 2, which is similarity. So in order to make prediction, we need to calculate the similarity between any two given data instances. This is needed so that we can locate the k most similar data instances in the training data set and in turn make a prediction. Given that all 4 flour measurements are numeric and have same unit, we can directly use the Euclidean distance measure, which is nothing but the square root of the sum of squared differences between two arrays of the number. Given that all the 4 flour measurements are numeric and have same unit, we can directly use the Euclidean distance measure, which is nothing but the square root of the sum of squared difference between two arrays of the number. Additionally, we want to control which field to include in the distance calculation. So specifically, we only want to include first 4 attributes. So our approach will be to limit the Euclidean distance to a fixed length. All right. So let's define our Euclidean function. So this is our Euclidean distance function, which takes instance 1, instance 2, and length as parameters. Instance 1 and instance 2 are the 2 points of which you want to calculate the Euclidean distance, whereas this length and denote that how many attributes you want to include. Okay. So there's our Euclidean function. Let's execute it. It's executing fine without any errors. Let's test the function. Suppose the data 1 or the first instance consists of the data point as 222 and it belongs to class A, and data 2 consists of 444 and it belongs to class B. So when we calculate the Euclidean distance of data 1 to data 2, and what we have to do, we have to consider only first 3 features of them. All right, so let's print the distance. As you can see here, the distance comes out to be 3.464. All right, so this is nothing but the square root of 4 minus 2 whole square. So this distance is nothing but the Euclidean distance, and it is calculated as square root of 4 minus 2 whole square plus 4 minus 2 whole square. That is nothing but 3 times of 4 minus 2 whole square, that is 12. And square root of 12 is nothing but 3.464. All right, so now that we have calculated the distance, now we need to look for k nearest neighbors. Now that we have a similarity measure, we can use it to collect the k most similar instances for a given unseen instance. Well, this is a straightforward process of calculating the distance for all the instances and selecting a subset with the smallest distance value. And now what we have to do, we have to select the smallest distance values. So for that, we'll be defining a function as getNeighbors. So for that, what we'll be doing, we'll be defining a function as getNeighbors. What it will do, it will return the k most similar neighbors from the training set for a given test instance. All right. So this is how our getNeighbors function look like. It takes training data set and test instance and k as its input. Here the k is nothing but the number of nearest neighbor you want to check for. All right. So basically what you'll be getting from this getNeighbors function is k different points having least Euclidean distance from the test instance. All right, let's execute it. So the function executed without any errors. So let's test our function. So suppose the training data set includes the data like 222 and it belongs to class A, and other data includes 444 and it belongs to class B, and our testing instance is 555. And now we have to predict whether this test instance belongs to class A or it belongs to class B. All right. For k equal 1, we have to predict its nearest neighbor and predict whether this test instance, it will belong to class A or will it belong to class B. All right. So let's execute the run button. All right. So on executing the run button, you can see that we have output as 444 and B. Our new instance 555 is closest to point 444, which belongs to class B. All right. Now, once you have located the most similar neighbor for a test instance, next task is to predict a response based on those neighbors. So how we can do that? Well, we can do this by allowing each neighbor to vote for their class attribute and take the majority vote as a prediction. Let's see how we can do that. So we have a function as getResponse which takes neighbor as the input. Well, this neighbor was nothing but the output of this getNeighbor function. The output of getNeighbor function will be fed to getResponse. All right, let's execute the run button. It's executed. Let's move ahead and test our function getResponse. So we have a neighbor as 111, it belongs to class A, 222, it belongs to class A, 333, it belongs to class B. So this response, what it will do, it will store the value of getResponse by passing this neighbor value. All right, so what we want to check is we want to predict whether our test instance 555 it belongs to class A or class B when the neighbors are 111A, 222A and 333B. So let's check our response. Now that we have created all the different functions which are required for a KNN algorithm, so important main concern is how to evaluate the accuracy of the prediction. An easy way to evaluate the accuracy of the model is to calculate a ratio of the total correct prediction to all the prediction made. So for this, I'll be defining a function as getAccuracy, and inside that I'll be passing my test dataset and the predictions. GetAccuracy function, check it, executed without any error. Let's check it for a sample dataset. So we have our test dataset as 111, which belongs to class A, 222, which again belongs to class 333, which belongs to class B. And my predictions is for first test data, it predicted that it belongs to class A, which is true. For next, it predicted that it belongs to class A, which is again true. And for the next, again, it predicted that it belongs to class A, which is false in this case, because the test data belongs to class B. All right. So in total, we have 2 correct prediction out of 3. All right. So the ratio will be 2 by 3, which is nothing but 66.66. So our accuracy rate is 66.66. So now that you have created all the functions that are required for KNN algorithm, let's compile them into one single main function. All right. So this is our main function, and we are using iris dataset with a split of 0.67 and the value of k is 3. Let's see what is the accuracy score of this. Check how accurate our model is. So in training dataset, we have 113 values, and in the test dataset, we have 37 values. These are the predicted and the actual values of the output. Okay. So in total, we got an accuracy of 97.29%, which is really very good. All right. So I hope the concept of this KNN algorithm is clear to you guys.
In a world full of machine learning and artificial intelligence surrounding almost everything around us, classification and prediction is one of the most important aspects of machine learning. So before moving forward, let's have a quick look at the agenda. I'll start off this video by explaining you guys what exactly is naive Bayes. Then we'll understand what is Bayes' theorem, which serves as a logic behind the naive Bayes algorithm. Moving forward, I'll explain the steps involved in the naive Bayes algorithm one by one, and finally I'll finish off this video with a demo on the naive Bayes using the sklearn package. Now naive Bayes is a simple but surprisingly powerful algorithm from predictive analysis. It is a classification technique based on Bayes' theorem with an assumption of independence among predictors. It comprises of 2 parts, which is naive and Bayes. In simple terms, naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other feature, even if these features depend on each other or upon the existence of the other features. All of these properties independently contribute to the probability whether a fruit is an apple or an orange or a banana. So that is why it is known as naive. Now, naive Bayes model is easy to build and particularly useful for very large data sets. In probability theory and statistics, Bayes' theorem, which is alternatively known as the Bayes law or the Bayes rule, describes the probability of an event based on prior knowledge of the conditions that might be related to the event. Now, Bayes' theorem is a way to figure out conditional probability. The conditional probability is the probability of an event happening, given that it has some relationship to one or more other events. For example, your probability of getting a parking space is connected to the time of the day you park, where you park, and what conventions are you going on at that time. Bayes' theorem is slightly more nuanced. In a nutshell, it gives you an actual probability of an event given information about the tests. Now, if we look at the definition of Bayes' theorem, we can see that given a hypothesis H and the evidence E, Bayes' theorem states that the relationship between the probability of the hypothesis before getting the evidence, which is the P of H, and the probability of the hypothesis after getting the evidence, that is P of H given E, is defined as probability of E given H into probability of H divided by probability of E. It's rather confusing, right? So let's take an example to understand this theorem. So suppose I have a deck of cards, and if a single card is drawn from the deck of playing cards, the probability that the card is a king is 4 by 52, since there are 4 kings in a standard deck of 52 cards. Now if king is an event, this card is a king, the probability of king is given as 4 by 52, that is equal to 1 by 13. Now if the evidence is provided, for instance, someone looks at the card, that the single card is a face card, the probability of king, given that it's a face, can be calculated using the Bayes theorem by this formula. Now since every king is also a face card, the probability of face, given that it's a king, is equal to 1. And since there are 3 face cards in each suit, that is the jack, king and queen, the probability of the face card is equal to 12 by 52, that is 3 by 13. Now using Bayes theorem, we can find out the probability of king, given that it's a face. So our final answer comes to 1 by 3, which is also true. So if you have a deck of cards which is having only faces, now there are 3 types of faces, which are the jack, king and queen. So the probability that it's a king is 1 by 3. Now this is the simple example of how Bayes theorem works. Now if we look at the proof, as in how this Bayes theorem evolved. So here we have probability of A given B and probability of B given A. Now for a joint probability distribution over the sets A and B, the probability of A intersection B, the conditional probability of A given B is defined as the probability of A intersection B divided by probability of B. And similarly, probability of B given A is defined as probability of B intersection A divided by probability of A. Now we can equate probability of A intersection B and probability of B intersection A as both are the same thing. Now from this method, as you can see, we get our final Bayes theorem proof, which is the probability of A given B equals probability of B given A into probability of B divided by the probability of A. Now while this is the equation that applies to any probability distribution over the events A and B, it has a particular nice interpretation in case where A is represented as the hypothesis H and B is represented as some observed evidence E. In that case, the formula is P of H given E is equal to P of E given H into probability of H divided by probability of E. Now, this relates the probability of hypothesis before getting the evidence, which is P of H, to the probability of the hypothesis after getting the evidence, which is P of H given E. For this reason, P of H is known as the prior probability, while P of H given E is known as the posterior probability, and the factor that relates the two is known as the likelihood ratio. Now using these terms, Bayes theorem can be rephrased as the posterior probability equals the prior probability times the likelihood ratio. So now that we know the maths which is involved behind the Bayes theorem, let's see how we can implement this in a real life scenario. So suppose we have a data set in which we have the outlook, the humidity, and we need to find out whether we should play or not on that day. So the outlook can be sunny, overcast, rain, and the humidity are high, normal, and the wind are categorized into 2 features, which are the weak and the strong winds. So first of all, we'll create a frequency table using each attribute of the data set. So the frequency table for the outlook looks like this. We have sunny, overcast, and rainy. The frequency table of humidity looks like this, and the frequency table of wind looks like this. We have strong and weak for wind and high and normal ranges for humidity. So for each frequency table, we will generate a likelihood table now. Now the likelihood table contains the probability of a particular day. Suppose we take the sunny and we take the play as yes and no. So the probability of sunny, given that we play yes, is 3 by 10, which is 0.3. The probability of X, which is the probability of sunny, is equal to 5 by 14. Now these are all the terms which are just generated from the data which we have here. And finally, the probability of yes is 10 out of 14. So if we have a look at the likelihood of yes, given that it's a sunny, we can see using Bayes theorem, it's the probability of sunny given yes into probability of yes divided by the probability of sunny. So we have all the values here calculated. So if we put that in our Bayes theorem equation, we get the likelihood of yes as 0.59. Similarly, the likelihood of no can also be calculated here. is 0.40. Now similarly, we are going to create the likelihood table for both the humidity and the wind. So for humidity, the likelihood for yes, given the humidity is high, is equal to 0.42, and the probability of playing no, given the wind is high, is 0.58. Now similarly for table wind, the probability of yes, given that the wind is weak, is 0.75, and the probability of no, given that the wind is weak, is 0.25. Now suppose we have a day which has high rain, which has high humidity, and the wind is weak. So should we play or not? Now so for that, we use the Bayes theorem here again. The likelihood of yes on that day is equal to the probability of outlook rain, given that it's a yes, into probability of humidity, given that it's a yes, and the probability of wind that is weak, given that we are playing yes, into the probability of yes, which equals to 0.019. And similarly, the likelihood of no on that day is equal to 0.016. Now if we look at the probability of yes for that day of playing, we just need to divide it with the likelihood sum of both the yes and no. So the probability of playing tomorrow, which is yes, is 0.5, whereas the probability of not playing is equal to 0.45. Now this is based upon the data which we already have with us. Now that you have an idea of what exactly is naive Bayes, how it works, and we have seen how it can be implemented on a particular data set, let's see where it is used in the industry. Now starting with our first industrial use case, which is news categorization, or we can use the term text classification to broaden the spectrum of this algorithm. News in the web are rapidly growing in the era of information age, where each news site has its own different layout and categorization for grouping news. Now these heterogeneity of layout and categorization cannot always satisfy individual users' need. So to remove these heterogeneity and classifying the news articles according to the user preference is a formidable task. Companies use web crawler to extract useful text from HTML pages, the news articles, and each of these news articles is then tokenized. Now these tokens are nothing but the categories of the news. Now in order to achieve better classification result, we remove the less significant words, which are the stop words from the documents or the articles, and then we apply the naive Bayes classifier for classifying the news contents based on the news code. Now this is by far one of the best examples of naive Bayes classifier, which is spam filtering. Now the naive Bayes classifier are a popular statistical technique for email filtering. They typically use bag of words features to identify the spam email, an approach commonly used in text classification as well. Now it works by correlating the use of tokens with the spam and the non-spam emails, and then the Bayes theorem, which I explained earlier, is used to calculate the probability that an email is or not a spam. So naive Bayes spam filtering is a baseline technique for dealing with spam that can tailor itself to the email's need of an individual user and give low false positive spam detection rates that are generally acceptable to users. It is one of the oldest ways of doing spam filtering, with its roots in the 1990s. Particular words have particular probabilities of occurring in spam email and in illegitimate email as well. For instance, most emails users will frequently encounter the word lottery or the lucky draw in spam email, but will seldom see it in other emails. The filter doesn't know these probabilities in advance and must be trained so it can build them up. To train the filter, the user must manually indicate whether a new email is spam or not. For all the words in each training email, the filter will adjust the probability that each word will appear in a spam or legitimate email in the database. Now after training, the word probabilities, also known as the likelihood functions, are used to compute the probability that an email with a particular set of words, as it belongs to either category. Each word in the email contributes to the email's spam probability. This contribution is called the posterior probability and is computed again using the Bayes theorem. Then the email spam probability is computed over all the words in the email, and if the total exceeds a certain threshold, say 90 or 95%, the filter will mark the email as spam. Now object detection is the process of finding instances of real-world objects such as faces, bicycles, and buildings in images or video. Now, object detection algorithms typically use abstracted features and learning algorithm to recognize instance of an object category. Here again, naive Bayes plays an important role of categorization and classification of objects. Now, medical area produces increasingly voluminous amount of electronic data, which are becoming more and more complicated. The produced medical data have certain characteristics that make their analysis very challenging and attractive as well. Among all the different approaches, the naive Bayes is used. It is the most effective and the efficient classification algorithm and has been successfully applied to many medical problems. Empirical comparison of naive Bayes versus 5 popular classifiers on 15 medical data sets shows that naive Bayes is well suited for medical application and has high performance in most of the examined medical problems. Now, in the past, various statistical methods have been used for modeling in the area of disease diagnosis. These methods require prior assumptions and are less capable of dealing with massive and complicated nonlinear and dependent data. One of the main advantages of naive Bayes approach, which is appealing to physicians, is that all the available information is used to explain the decision. This explanation seems to be natural for medical diagnosis and prognosis. That is, it is very close to the way how physicians diagnose patients. Now, weather is one of the most influential factors in our daily life, to an extent that it may affect the economy of a country that depends on occupation like agriculture. Therefore, as a countermeasure to reduce the damage caused by uncertainty in weather behavior, there should be an efficient way to predict the weather. Now, weather predicting has been a challenging problem in the meteorological department since years. Even after the technological and scientific advancement, the accuracy in prediction of weather has never been sufficient. Even in current day, this domain remains as a research topic in which scientists and mathematicians are working to produce a model or an algorithm that will accurately predict the weather. Now, a Bayesian approach-based model is created by where posterior probabilities are used to calculate the likelihood of each class label for input data instance, and the one with the maximum likelihood is considered as the resulting output. Now, earlier we saw a small implementation of this algorithm as well, where we predicted whether we should play or not based on the data which we have collected earlier. Now, there is a Python library which is known as scikit-learn. It helps to build naive Bayes and model in Python. Now, there are 3 types of naive Bayes model under scikit-learn library. The first one is the Gaussian. It is used in classification and it assumes that the feature follow a normal distribution. The next we have is multinomial. It is used for discrete counts. For example, let's say we have a text classification problem and here we consider Bernoulli trials, which is one step further, and instead of word occurring in the document, we have count how often word occurs in the document. You can think of it as the number of times outcomes number is observed in the given number of trials. And finally, we have the Bernoulli type of naive Bayes. The binomial model is useful if your feature vectors are binary. Bag of words model where the ones and the zeros are words occur in the document and the words which do not occur in the document respectively. Based on your data set, you can choose any of the given discussed model here, which is the Gaussian, the multinomial, or the Bernoulli. So let's understand how this algorithm works and what are the different steps one can take to create a Bayesian model and use naive Bayes to predict the output. So here, to understand better, we are going to predict the onset of diabetes. Now, this problem comprises of 768 observations of medical details for Paima Indian patients. The record describes instantaneous measurement taken from the patients such as their age, the number of times pregnant, and the blood work group. Now, all the patients are women aged 21 and older, and all the attributes are numeric, and the units vary from attribute to attribute. Each record has a class value that indicate whether the patient suffered on onset of diabetes within 5 years or the measurements. Now, these are classified as 0. Now, I've broken the whole process down into the following steps. The first step is handling the data, in which we load the data from the CSV file and split it into training and test data sets. The second step is summarizing the data, in which we summarize the properties in the training data sets so that we can calculate the probabilities and make predictions. Now, the third step is making a particular prediction, we use the summaries of the dataset to generate a single prediction. And after that, we generate predictions given a test dataset and a summarized training datasets. And finally, we evaluate the accuracy of the predictions made for a test dataset as the percentage correct out of all the predictions made. And finally, we tie it together and form our own model of naive Bayes classifier. Now, the first thing we need to do is load our data. The data is in the CSV format without a header line or any quotes. We can open the file with the open function and read the data lines using the read functions in the CSV module. Now we also need to convert the attributes that were loaded as strings into numbers so that we can work with them. So let me show you how this can be implemented. Now for that you need to install Python on your system and use the Jupyter Notebook or the Python shell. Here I'm using the Anaconda Navigator, which has all the things required to do programming in Python. We have the Jupyter Lab, we have the notebook, we have the Qt console, even we have RStudio as well. So what you need to do is just install the Anaconda Navigator. It comes with the pre-installed Python also. So the moment you click launch on the Jupyter Notebook, it will take you to the Jupyter homepage in a local system, and here you can do programming in Python. So let me just rename it as PyMa India Diabetes. So first we need to load the data set. So I'm creating here a function load CSV. Now before that we need to import certain CSV, the math and the random method. So as you can see, I've created a load CSV function which will take the PyMa Indian Diabetes data.csv file using the csv.reader method, and then we are converting every element of that data set into float. Originally all the elements are in string, but we need to convert them into float for our calculation purposes. Now next we need to split the data into training data sets that naive Bayes can use to make the prediction and test data set that we can use to evaluate the accuracy of the model. We need to split the data set randomly into training and testing data set in the ratio of usually which is 70 to 30, but for this example I'm going to use 67 and 33. Now 70 and 30 is a common ratio for testing algorithms, so you can play around with this number. So this is our split dataset function. Now the naive Bayes model is comprised of summary of the data in the training dataset. Now this summary is then used while making predictions. Now the summary of the training data collected involves the mean, the standard deviation of each attribute by class value. Now for example, if there are 2 class values and 7 numerical attributes, then we need a mean and the standard deviation for each of these 7 attributes and the class value, which makes it the 14 attribute summaries. So we can break the preparation of this summary down into the following subtasks, which are the separating data by class, calculating mean, calculating standard deviation, summarizing the data sets, and summarizing attributes by class. So the first task is to separate the training dataset instances by class value so that we can calculate statistics for each class. We can do that by creating a map of each class value to a list of instances that belong to the class and sort the entire dataset of instances into the appropriate list. Now the separate by class function just does the same. So as you can see, the function assumes that the last attribute is the class value. The function returns a map of class value to the list of data instances. Next, we need to calculate the mean of each attribute for a class value. Now the mean is the central middle or the central tendency of the data, and we use it as the middle of our Gaussian distribution when calculating the probabilities. So this is our function for mean. Now we also need to calculate the standard deviation of each attribute for a class value. Now standard deviation is calculated as a square root of the variance, and the variance is calculated as the average of the squared differences for each attribute value from the mean. Now one thing to note that here is that we are using n-1 method, which subtracts 1 from the number of attributes values when calculating the variance. Now that we have the tools to summarize the data for a given list of instances, we can calculate the mean and standard deviation for each attribute. Now the ZIF function groups the values for each attribute across our data instances into their own lists so that we can compute the mean and standard deviation values for each attribute. Now next comes the summarizing attributes by class. We can pull it all together by first separating our training datasets into instances grouped by class, then calculating the summaries for each attribute. Now we are ready to make predictions using the summaries prepared from our training data. Making predictions involved calculating the probability that a given data instance belongs to each class, then selecting the class with the largest probability as the prediction. Now we can divide this whole method into 4 tasks, which are the calculating Gaussian probability density function, calculating class probability, making a prediction, and then estimating the accuracy. Now to calculate the Gaussian probability density function, we use the Gaussian function to estimate the probability of a given attribute value given the known mean and the standard deviation of the attribute estimated from the training data. As you can see, the parameters are x, mean, and the standard deviation. Now in the calculate probability function, we calculate the exponent first, then calculate the main division. This lets us fit the equation nicely into 2 lines. Now the next task is calculating the class probabilities. Now that we can calculate the probability of an attribute belonging to a class, we can combine the probabilities of all the attributes values for a data instance and come up with a probability of the entire data instance belonging to the class. Now that we have calculated the class probabilities, it's time to finally make our first prediction. Now we can calculate the probability of the data instance belonging to each class value, and we can look for the largest probability and return the associated class. And for that, we are going to use this function predict, which uses the summaries and the input vector, which is basically all the probabilities which are being input for a particular label. Now finally, we can estimate the accuracy of the model by making predictions for each data instances in our test data. For that, we use the getPredictions method. Now this method is used to calculate the predictions based upon the test data sets and the summary of the training data set. Now the predictions can be compared to the class values in our test dataset, and classification accuracy can be calculated as an accuracy ratio between the zeros and the 100%. Now the getAccuracy method will calculate this accuracy ratio. Now finally, to sum it all up, we define our main function, where we call all these methods which we have defined earlier one by one to get the accuracy of the model which we have created. So as you can see, this is our main function in which we have the file name, we have defined the split ratio, we have the data set, we have the training and test data set, we are using the split data set method. Next, we are using the summarize by class function, we are using the get prediction and the get accuracy method as well. So guys, as you can see, the output of this one gives us that we are splitting the 768 rows into 514, which is the training, and 254, which is the test dataset rows, and the accuracy of this model is 68%. Now we can play with the amount of training and test data sets which are to be used here. So we can change the split ratio to 70s to 30, 80s to 20 to get different sort of accuracy. So suppose I change the split ratio from 0.67 to 0.8. So as you can see, we get the accuracy of 62%. So splitting it into 0.67 gave us a better result, which was 68%. So this is how you can implement a naive Bayes Gaussian classifier. These are the step-by-step methods which you need to do in case of using the naive Bayes classifier. But don't worry, we do not need to write all this many lines of code to make a model. This is where the scikit-learn library comes into picture. The scikit-learn library has a predefined method, or I'll say a predefined function of naive Bayes, which converts all of these lines of code into merely just 2 or 3 lines of codes. So let me just open another Jupyter notebook. So let me name it as sklearn naive Bayes. Now here we are going to use the most famous dataset, which is the IRIS dataset. Now the IRIS flower dataset is a multivariate dataset introduced by the British statistician and biologist Roland Fisher. And based on this Fisher's linear discriminant model, this dataset became a typical test case for many statistical classification techniques in machine learning. So here we are going to use the Gaussian NB model, which is already available in the sklearn. As I mentioned earlier, there were three types of naive Bayes, which are the Gaussian, multinomial, and the Bernoulli. So here we are going to use the Gaussian NB model, which is already present in the sklearn library, which is the scikit-learn library. So first of all, what we need to do is import the sklearn datasets and the metrics, and we also need to import the Gaussian NB. Now once all these libraries are loaded, we need to load the dataset, which is the iris dataset. Now next what we need to do is fit a naive Bayes model to this dataset. So as you can see, we have so easily defined the model, which is the Gaussian NB, which contains all the programming which I just showed you earlier, all the methods which are taking the input, calculating the mean, the standard deviation, separating it by class, then finally making predictions and calculating the prediction accuracy. All of these comes under the Gaussian NB method, which is inside already present in the sklearn library. We just need to fit it according to the dataset which we have here. So next, if we print the model, we see which is the Gaussian NB model. Now next what we need to do is make the predictions. So the expected output is dataset.target and the predicted is using the predicted model. And the model we are using is the Gaussian NB here. Now to summarize the model which we created, we calculate the confusion matrix and the classification report. So guys, as you can see, the classification report, we have the precision of 0.96, we have the recall of 0.96, we have the F1 score and the support. And finally, if we print our confusion matrix, as you can see, it gives us this output. So as you can see, using the Gaussian NB method, just putting it under the model and using any of the data set, fitting the model which you created into a particular data set and getting the desired output is so easy with the scikit-learn library.
SVM or support vector machine is one of the most effective machine learning classifier, and it has been used in various fields such as face recognition, cancer classification, and so on. Today's session is dedicated to how SVM works, the various features of SVM, and how it is used in the real world. Alright, okay, now let's move on and see what SVM algorithm is all about. So guys, SVM or support vector machine is a supervised learning algorithm which is mainly used to classify data into different classes. Now, unlike most algorithms, SVM makes use of a hyperplane which acts like a decision boundary between the various classes. In general, SVM can be used to generate multiple separating hyperplanes so that the data is divided into segments. Okay, and each of these segments will contain only one kind of data. It's mainly used for classification purpose, wherein you want to classify a data into two different segments, depending on the features of the data. Now, before moving any further, let's discuss a few features of SVM. Like I mentioned earlier, SVM is a supervised learning algorithm. This means that SVM trains on a set of labeled data. SVM studies the label training data and then classifies any new input data depending on what it learned in the training phase. A main advantage of support vector machine is that it can be used for both classification and regression problems. Alright. Now, even though SVM is mainly known for classification, the SVR, which is the support vector regressor, is used for regression problems. Alright, so SVM can be used both for classification and for regression. Now, this is one of the reasons why a lot of people prefer SVM, because it's a very good classifier, and along with that, it is also used for regression. Okay. Another feature is the SVM kernel functions. SVM can be used for classifying non-linear data by using the kernel trick. The kernel trick basically means to transform your data into another dimension so that you can easily draw a hyperplane between the different classes of the data. Alright, non-linear data is basically data which cannot be separated with a straight line. Alright, so SVM can even be used on non-linear data sets. You just have to use the kernel functions to do this. Alright, so guys, I hope you all are clear with the basic concepts of SVM. Now let's move on and look at how SVM works. So guys, in order to understand how SVM works, let's consider a small scenario. Now for a second, pretend that you own a farm. Okay, and let's say that you have a problem and you want to set up a fence to protect your rabbits from the pack of wolves. Okay, but where do you build your fence? One way to get around the problem is to build a classifier based on the position of the rabbits and wolves in your pasture. So what I'm telling you is you can classify the group of rabbits as one group and draw a decision boundary between the rabbits and the wolf. All right. So if I do that and if I try to draw a decision boundary between the rabbits and the wolves, it looks something like this. Okay. Now you can clearly build a fence along this line. In simple terms, this is exactly how SVM works. It draws a decision boundary, which is a hyperplane between any two classes in order to separate them or classify them. Now I know you're thinking, how do you know where to draw a hyperplane? The basic principle behind SVM is to draw a hyperplane that best separates the two classes. In our case, the two classes are the rabbits and the wolves. So you start off by drawing a random hyperplane, and then you check the distance between the hyperplane and the closest data points from each class. These closest or nearest data points to the hyperplane are known as support vectors. And that's where the name comes from, support vector machine. So basically the hyperplane is drawn based on these support vectors. So guys, an optimum hyperplane will have a maximum distance from each of these support vectors. Alright. So basically the hyperplane which has the maximum distance from the support vectors is the most optimum hyperplane. And this distance between the hyperplane and the support vectors is known as the margin. Alright. So to sum it up, SVM is used to classify data by using a hyperplane such that the distance between the hyperplane and the support vectors is maximum. So basically your margin has to be maximum. Alright. That way you know that you're actually separating your classes. Alright. Because the distance between the two classes is maximum. Okay. Now let's try to solve a problem. Okay. So let's say that I input a new data point. Okay. This is the new data point. And now I want to draw a hyperplane such that it best separates the two classes. Okay. So I start off by drawing a hyperplane like this. And then I check the distance between the hyperplane and the support vectors. Okay, so I'm trying to check if the margin is maximum for this hyperplane. But what if I draw a hyperplane which is like this? Alright, now I'm going to check the support vectors over here. Then I'm going to check the distance from the support vectors. And for this hyperplane, it's clear that the margin is more. Alright, when you compare the margin of the previous one to this hyperplane, it is more. So the reason why I'm choosing this hyperplane is because the distance between the support vectors and the hyperplane is maximum in this scenario. Okay. So guys, this is how you choose a hyperplane. You basically have to make sure that the hyperplane has a maximum margin. Alright. It has to best separate the two classes. Alright. Okay. So far it was quite easy. Our data was linearly separable, which means that you could draw a straight line to separate the two classes. Alright. But what will you do if the data set is like this? You possibly can't draw a hyperplane like this. Alright. It doesn't separate the two classes at all. So what do you do in such situations? Now, earlier in the session, I mentioned how a kernel can be used to transform data into another dimension that has a clear dividing margin between the classes of data. Alright. So kernel functions offer the user this option of transforming non-linear spaces into linear ones. Non-linear data set is the one that you can't separate using a straight line. Alright. In order to deal with such data sets, you're going to transform them into linear data sets and then use SVM on them. Okay, so a simple trick would be to transform the two variables x and y into a new feature space involving a new variable called z. Alright. So guys, so far we were plotting our data on two-dimensional space. Correct? We were only using the x and the y axis. So we had only those two variables x and y. Now in order to deal with this kind of data, a simple trick would be to transform the two variables x and y into a new feature space involving a new variable called z. Okay, so we're basically visualizing the data on a three-dimensional space. Now when you transform the 2D space into a 3D space, you can clearly see a dividing margin between the two classes of data. Alright, now you can go ahead and separate the two classes by drawing the best hyperplane between them. Okay, that's exactly what we discussed in the previous slides. So guys, why don't you try this yourself? Try drawing a hyperplane which is the most optimum for these two classes. Alright. So guys, I hope you have a good understanding about nonlinear SVMs. Now let's look at a real world use case of support vector machines. So guys, SVM as a classifier has been used in cancer classification since the early 2000s. So there was an experiment held by a group of professionals who applied SVM in a colon cancer tissue classification. So the data set consisted of about 2000 transmembrane protein samples and only about 50 to 200 gene samples were input into the SVM classifier. Now, this sample, which was input into the SVM classifier, had both colon cancer tissue samples and normal colon tissue samples. Alright. Now, the main objective of the study was to classify gene samples based on whether they are cancerous or not. Okay, so SVM was trained using the 50 to 200 samples in order to discriminate between non-tumor from tumor specimens. So the performance of the SVM classifier was very accurate for even a small data set. Alright, we had only 50 to 200 samples, and even for the small data set, SVM was pretty accurate with its results. Not only that, its performance was compared to other classification algorithms like naive Bayes, and in each case, SVM outperformed naive Bayes. So after this experiment, it was clear that SVM classified the data more effectively, and it worked exceptionally good with small data sets.
Let's go ahead and understand what exactly is unsupervised learning. So sometimes the given data is unstructured and unlabeled, so it becomes difficult to classify the data into different categories. So unsupervised learning helps to solve this problem. This learning is used to cluster the input data in classes on the basis of their statistical properties. So for example, we can cluster different bikes based upon their speed limit, their acceleration, or the average that they are giving. So unsupervised learning is a type of machine learning algorithm used to draw inferences from datasets consisting of input data without labeled responses. So if you have a look at the workflow or the process flow of unsupervised learning, so the training data is collection of information without any label. We have the machine learning algorithm, and then we have the clustering models. So what it does is that distributes the data into different clusters. And again, if you provide any unlabeled new data, it will make a prediction and find out to which cluster that particular data or the data set belongs to, or the particular data point belongs to. So one of the most important algorithms in unsupervised learning is clustering. So let's understand exactly what is clustering. So clustering basically is the process of dividing the data sets into groups consisting of similar data points. And it means grouping of objects based on the information found in the data, describing the objects or their relationships. So clustering models focus on identifying groups of similar records and labeling records according to the group to which they belong. Now, this is done without the benefit of prior knowledge about the groups and their characteristics. And in fact, we may not even know exactly how many groups are there to look for. Now, these models are often referred to as unsupervised learning models, since there is no external standard by which to judge the model's classification performance. There are no right or wrong answers to these models. And if we talk about why clustering is used, so the goal of clustering is to determine the intrinsic group in a set of unlabeled data. Sometimes the partitioning is the goal, or the purpose of clustering algorithm is to make sense of an exact value from the large set of structured and unstructured data. So that is why clustering is used in the industry. And if you have a look at the various use cases of clustering in the industry, so first of all, it's being used in marketing. So discovering distinct groups in customer databases, such as customers who make a lot of long distance calls, customers who use internet more than calls. They're also used in insurance companies, so like identifying groups of corporation insurance policy holders with high average claim rate, farmers crash crops, which is profitable. They are used in seismic studies, identifying probable areas of oil or gas exploration based on seismic data. And they're also used in the recommendation of movies. If you'd say, they are also used in Flickr photos. They're also used by Amazon for recommending the product, which category it lies in. So basically, if we talk about clustering, there are three types of clustering. So first of all, we have the exclusive clustering, which is the hard clustering. So here an item belongs exclusively to one cluster, not several clusters, and the data point belong exclusively to one cluster. So an example of this is the k-mean clustering. So k-mean clustering does this exclusive kind of clustering. So secondly, we have overlapping clustering. So it is also known as soft clusters. In this, an item can belong to multiple clusters as its degree of association with each cluster is shown. And for example, we have fuzzy or the C-means clustering, which is being used for overlapping clustering. And finally, we have the hierarchical clustering. So when two clusters have a parent-child relationship or a tree-like structure, then it is known as hierarchical cluster. So as you can see here from the example, we have a parent-child kind of relationship in the cluster given here. So let's understand what exactly is k-means clustering. So k-means clustering is an algorithm whose main goal is to group similar elements of data points into a cluster. And it is the process by which objects are classified into a predefined number of groups so that they are as much dissimilar as possible from one group to another group, but as much as similar or possible within each group. Now, if you have a look at the algorithm working here, you're right. So first of all, it starts with identifying the number of clusters, which is k. Then again, we find the centroid. We find the distance objects to the distance object to the centroid, distance of objects to the centroid. Then we find the grouping based on the minimum distance. Has the centroid converged? If true, then we make a cluster. If false, we then again find the centroid. Repeat all of the steps again and again. So let me show you how exactly clustering works with an example here. So first we need to decide the number of clusters to be made. Now, another important task here is how to decide the important number of clusters or how to decide the number of clusters. We'll get into that later. So first, let's assume that the number of clusters we have decided is 3. So after that, then we provide the centroids for all the clusters, which is guessing. The algorithm calculates the Euclidean distance of the point from each centroid and assigns the data point to the closest cluster. Now, Euclidean distance, all of you know, is the square root of the distance, the square root of the square of the distance. So next, when the centroids are calculated again, we have our new clusters. For each data point, then again, the distance from the points to the new clusters are calculated, and then again, the points are assigned to the closest cluster. And then again, we have the new centroid is calculated. Now, these steps are repeated until we have a repetition in the centroids or the new centroids are very close to the very previous ones. So until and unless our output gets repeated or the outputs are very, very close enough, we do not stop this process. We keep on calculating the Euclidean distance of all the points to the centroids. Then we calculate the new centroids, and that is how k-means clustering works basically. So an important part here is to understand how to decide the value of k or the number of clusters, because it does not make any sense if you do not know how many clusters you're going to make. So to decide the number of clusters, we have the elbow method. So let's assume, first of all, compute the sum squared error, which is the SSE, for some value of a. For example, let's take 2, 4, 6, and 8. Now the SSE, which is the sum squared error, is defined as a sum of the squared distance between each member of the cluster and its centroid mathematically. And if you mathematically, it is given by the equation which is provided here. And if you plot the k against the SSE, you will see that the error decreases as k gets large. Now this is because the number of cluster increases, they should be smaller, so the distortion is also smaller. Now the idea of the elbow method is to choose the k at which the SSE decreases abruptly. So for example here, if we have a look at the figure given here, we see that the best number of cluster is at the elbow. So as you can see here, the graph here changes abruptly at the number 4. So for this particular example, we're going to use 4 as the number of cluster. So first of all, while working with k-means clustering, there are 2 key points to know. First of all, be careful about where you start. So choosing the first center at random, choosing the second center that is far away from the first center. Similarly, choosing the nth center as far away as possible from the closest of all the other centers. And the second idea is to do as many runs of k-means, each with different random starting points, so that you get an idea of where exactly and how many clusters you need to make, and where exactly the centroid lies, and how the data is getting converged. Now, k-means is not exactly a very good method, so let's understand the pros and cons of k-means clustering. We know that k-means is simple and understandable. Everyone learns it at the first go. The items automatically assigned to the clusters. Now, if we have a look at the cons. So first of all, one needs to define the number of clusters. This is a very heavy task as if we have 3, 4, or if we have 10 categories, and if we do not know what the number of clusters are going to be, it's very difficult for anyone to, to guess the number of clusters. Now, all the items are forced into the clusters. Whether they actually belong to any other cluster or any other category, they are forced to lie in that other category in which they are closest to. Now, this again happens because of the number of clusters with not defining the correct number of clusters or not being able to guess the correct number of clusters. And most of all, it's unable to handle the noisy data and the outliners, because anyways, machine learning engineers and data scientists have to clean the data. But then again, it comes down to the analysis what they are doing and the method that they are using. So typically people do not clean the data for k-means clustering, or even if they clean, there are noisy and outliners data which affect the whole model. So that was all for k-means clustering. So what we're going to do is now use k-means clustering for the movie data set. So we have to find out the number of clusters and divide it accordingly. So the use case is that, first of all, we have a data set of 5,000 movies, and what we want to do is group the movies into clusters based on the Facebook likes. So guys, let's have a look at the demo here. So first of all, what we're going to do is import deepcopy, numpy, pandas, seaborn, the various libraries which we're going to use now. And from matplotlib, we're going to use pyplot, and we're going to use this ggplot. And next, what we're going to do is import the dataset and look at the shape of the dataset. So if we have a look at the shape of the dataset, we can see that it has 5,043 rows with 28 columns. And if you have a look at the head of the dataset, we can see it has 5,043 data points. So what we're going to do is place the data points in the plot. We take the director Facebook likes, and if we have a look at the data columns, we have face, number, and poster, cast, total Facebook likes, director Facebook likes. So what we have done here now is taking the director Facebook likes and the actor 3 Facebook likes, right? So we have 5,043 rows and 2 columns. Now, using the k-means from sklearn, what we're going to do is import it first. We're going to import k-means from sklearn.cluster. Remember guys, sklearn is a very important library in Python for machine learning. And the number of cluster, what we're going to do is provide as 5. Now this again, the number of cluster depends upon the SSE, which is the sum squared errors, or we're going to use the elbow method. So I'm not going to go into the details of that again. So we're going to fit the data into the k-means.fit. And if we find the cluster centers then for the k-means and print it, so what we find is an array of 5 clusters, and if we print the label of the k-means cluster. Now next, what we're going to do is plot the data which we have with the clusters, with the new data clusters which we have found. And for this, we're going to use the seaborn, and as you can see here, we have plotted the data into the grid, and you can see here we have 5 clusters. So probably what I would say is that the cluster 3 and the cluster 0 are very, very close. So it might depend. See, that's exactly what I was going to say, is that initially the main challenge in k-means clustering is to define the number of centers, which are the k. So as you can see here, the third center and the 0th cluster, the third cluster and the 0th cluster are very, very close to each other. So guys, it probably could have been in one another cluster. And the another disadvantage was that we do not exactly know how the points are to be arranged. So it's very difficult to force the data into any other cluster, which makes our analysis a little different. Works fine, but sometimes it might be difficult to code in the k-means clustering. Now let's understand what exactly is c-means clustering. So the fuzzy c-means is an extension of the k-means clustering. The popular simple clustering technique. So fuzzy clustering, also referred as soft clustering, is a form of clustering in which each data point can belong to more than one cluster. So k-means tries to find the hard clusters where each point belongs to one cluster, whereas the fuzzy c-means discovers the soft clusters. In a soft cluster, any point can belong to more than one cluster at a time with a certain affinity value towards each. Fuzzy c-means assigns the degree of membership which ranges from 0 to 1 to an object to a given cluster. So there is a stipulation that the sum of fuzzy membership of an object to all the cluster it belongs to must be equal to 1. So the degree of membership of this particular point to both of these clusters are 0.6 and 0.4. And if we add up, we get 1. So that is one of the logic behind the fuzzy C-means. And this affinity is proportional to the distance from the point to the centroid of the cluster. Now then again, we have the pros and cons of fuzzy C-means. So first of all, it allows a data point to be in multiple clusters. That's a pro. It's a more neutral representation of the behavior of genes. Genes usually are involved in multiple functions. So it is a very good type of clustering when we're talking about genes. And again, if we talk about the cons, again, we have to define C, which is the number of clusters, same as K. Next, we need to determine the membership cutoff value also. So that takes a lot of time and it's time consuming, and the clusters are sensitive to initial assignment of centroids. So a slight change or a deviation from the centroids is going to result in a very different kind of, a funny kind of output we get from the fuzzy C-means. And one of the major disadvantages of C-means clustering is that it is a non-deterministic algorithm. So it does not give you a particular output as in such. That's that. Now let's have a look at the third type of clustering, which is the hierarchical clustering. So hierarchical clustering is an alternative approach which builds a hierarchy from the bottom up or the top to bottom and does not require to specify the number of clusters beforehand. Now the algorithm works as in, first of all, we put each data point in its own cluster, identify the closest two cluster and combine them into one more cluster. Repeat the above step till the data points are in a single cluster. Now there are two types of hierarchical clustering. One is agglomerative clustering and the other one is division clustering. So agglomerative clustering builds the dendrogram from bottom level, while the division clustering, it starts all the data points in one cluster, the root cluster. Now again, hierarchical clustering also has some sort of pros and cons. So in the pros, though no assumption of a particular number of clusters is required, and it may correspond to meaningful taxonomies. Whereas if we talk about the cons, once a decision is made to combine two clusters, it cannot be undone. And one of the major disadvantages of these hierarchical clustering is that it becomes very slow if we talk about very, very large data sets. And nowadays, I think every industry are using large data sets and collecting large amounts of data. So hierarchical clustering is not the apt or the best method someone might need to go for. So there's that. Now, when we talk about unsupervised learning, so we have k-means clustering, and again, there's another important term which people usually miss while talking about unsupervised learning, and there's one very important concept of market basket analysis. Now, it is one of the key techniques used by large retailers to uncover association between items. Now, it works by looking for a combination of items that occur together frequently in the transactions. To put it in another way, it allows retailers to identify the relationships between the items that the people buy. For example, people who buy bread also tend to buy butter. The marketing teams at the retail stores should target customers who buy bread and butter and provide them an offer so that they buy a third item like an egg. So if a customer buys bread and butter and sees a discount or an offer on eggs, he will be encouraged to spend more money and buy the eggs. Now, this is what market basket analysis is all about. Now, to find the association between the two items and make predictions about what the customers will buy, there are two algorithms, which are the association rule mining and the a priori algorithms. So let's discuss each of these algorithms with an example. First of all, if we have a look at the association rule mining, now it's a technique that shows how items are associated to each other. For example, customers who purchase bread have a 60% likelihood of also purchasing jam, and customers who purchase laptop are more likely to purchase laptop bags. Now, if we take an example of an association rule, if we have a look at the example here, A arrow B, it means that if a person buys an item A, then he will also buy an item B. Now, there are three common ways to measure a particular association because we have to find these rules on the basis of some statistics, right? So what we do is use support, confidence, and lift. Now these three common ways and the measures to have a look at the association rule mining and know exactly how good is that rule. So first of all, we have support. So support gives the fraction of the transaction which contains an item A and B. So it's basically the frequency of the item in the whole item set. Whereas confidence gives how often the item A and B occur together given the number of times A occur. So it's frequency A comma B divided by the frequency of A. Now, lift what indicates is the strength of the rule over the random co-occurrence of A and B. If you have a close look at the denominator of the lift formula here, we have support A into support B. Now, a major thing which can be noted from this is that the support of A and B are independent here. So if the value of lift or the denominator value of the lift is more, it means that the items are independently selling more, not together. So that in turn will decrease the value of lift. So what happens is that suppose the value of lift is more, that implies that the rule which we get, it implies that the rule is strong and it can be used for later purposes. Because in that case, the support A into support B value, which is the denominator of lift, will be low, which in turn means that there's a relationship between the items A and B. So let's take an example of association rule mining and understand how exactly it works. So let's suppose we have a set of items A, B, C, D, and E. And we have the set of transactions which are T1, T2, T3, T4, and T5. And what we need to do is create some sort of rules. For example, you can see A, D, which means that if a person buys A, he buys D. If a person buys C, he buys A. If a person buys A, he buys C. And for the fourth one is if a person buys B and C, he'll in turn buy A. Now, what we need to do is calculate the support, confidence, and lift of these rules. Now, here again, we talk about a priori algorithm. So a priori algorithm and the association rule mining go hand in hand. So what a priori does is algorithm, it uses the frequent item sets to generate the association rules. And it is based on the concept that a subset of a frequent item set must also be a frequent item set. So let's understand what is a frequent item set and how all of these work together. So if we take the following transactions of items, we have transaction T1 to T5, and the items are 134, 235, 1235, 25, and 135. Now, another more important thing about support, which I forgot to mention, was that when talking about association rule mining, there is a minimum support count, what we need to do. Now, the first step is to build a list of item set of size 1 using this transaction data set and use the minimum support count too. Now, let's see how we do that. If we create the table C1, if you have a close look at the table C1, we have the item set 1, which has a support 3 because it appears in the transaction 1, 3, and 5. Similarly, if we have a look at the item set, the single item 3, so it has a support of 4. It appears in T1, T2, T3, and T5. But if we have a look at the item set 4, it only appears in the transaction 1, so its support value is 1. Now, the item set with the support value which is less than the minimum support value, that is 2, have to be eliminated. So the final table, which is a table F1, has 1, 2, 3, and 5. It does not contain the 4. Now, what we're going to do is create the item list of the size 2. And all the combination of the item sets in F1 are used in this iteration. So we've left 4 behind. We just have 1, 2, 3, and 5. So the possible item sets are 1, 2, 1, 3, 1, 5, 2, 3, 2, 5, and 3, 5. Then again, we'll calculate the support. So in this case, if we have a closer look at the table C2, we see that the item set 1, 2 is having a support value 1, which has to be eliminated. So the final table F2 does not contain 1, 2. Similarly, if we create the item sets of size 3 and calculate the support values, but before calculating the support, let's perform the pairing on the data set. Now, what's pairing? So after all the combinations are made, we divide the table C3 items to check if there are another subset whose support is less than the minimum support value. This is a priori algorithm. So in the item sets 1, 2, 3, what we can see that we have 1, 2, and in the 1, 2, 5 again we have 1, 2. So we'll discard both of these item sets and we'll be left with 1, 3, 5 and 2, 3, 5. So with 1, 3, 5 we have 3 subsets 1, 5, 1, 3, 3, 5, which are present in table F2. Then again we have 2, 3, 2, 5, and 3, 5. which are also present in table F2. So we have to remove 1, 2 from the table C3 and create the table F3. Now, if we're using the items of C3 to create the items of C4, so what we find is that we have the item set 1, 2, 3, 5. The support value is 1, which is less than the minimum support value of 2. So what we're going to do is stop here and we're going to return to the previous item set, that is the table C3. So the final table F3 was 135 with the support value of 2 and 235 with the support value of 2. Now what we're going to do is generate all the subsets of each frequent item sets. So let's assume that our minimum confidence value is 60%. So for every subset S of I, the output rule is that S gives I to S, is that S recommends I and S. If the support of I divided by the support of S is greater than or equal to the minimum confidence value, then only we'll proceed further. So keep in mind that we have not used lift till now. We are only working with support and confidence. So applying rules to the item sets of F3, we get rule 1, which is 1, 3, which gives 135 and 1, 3. It means if you buy 1 and 3, there's a 66% chance that you'll buy item 5 also. Similarly, the rule 1, 5, it means that if you buy 1 and 5, there's 100% chance that you will buy 3 also. Similarly, if we have a look at rule 5 and 6, here the confidence value is less than 60%, which was the assumed confidence value. So what we're going to do is we'll reject these files. Now an important thing to note here is that have a closer look to the rule 5 and rule 3. You see it has 153, 153, 315. It's very confusing. So one thing to keep in mind is that the order of the item sets is also very important. That will help us create good rules and avoid any kind of confusion. So that's that. So now let's learn how association rules are used in market basket analysis problems. So what we'll do is we'll be using the online transactional data of a retail store for generating association rules. So first of all, what you need to do is import pandas, MLXDND libraries from the imported and read the data. So first of all, what we're going to do is read the data. What we're going to do is from mlxdnd.frequent patterns, we're going to import the a priori and the association rules. As you can see here, we have the head of the data. You can see we have invoice number, stock code, the description, quantity, the invoice detail, unit price, customer ID, and the country. So in the next step, what we will do is we will do the data cleanup, which includes removing spaces from some of the descriptions given. And what we're going to do is drop the rows that do not have the invoice numbers and remove the credit transactions. So here what we're going to do is remove which do not have an invoice number. If the string contains type C invoice number, then we're going to remove that. Those are the credits. Remove any kind of spaces from the descriptions. So as you can see here, we have like 532,000 rows with 8 columns. So next, what we're going to do is after the cleanup, we need to consolidate the items into one transaction per row with each product. For the sake of keeping the data set small, we're going to only look at the sales for France. So we're going to use the only France and group by invoice number, description with the quantity, sum up and see. So which leaves us with 392 rows and 1563 columns. Now there are a lot of zeros in the data, but we also need to make sure any positive values are converted to a 1 and anything less than 0 is set to 0. So for that, we're going to use this code defining encode units. If x is less than 0, return 0. If x is greater than 1, return 1. So what we're going to do is map and apply it to the whole data set we have here. So now that we have structured the data properly, so the next step is to generate the frequent item set that has support of at least 7%. Now this number is chosen so that you can get close enough. Now what we're going to do is generate the rules with the corresponding support, confidence, and lift. So we have given the minimum support as 0.7, the metric is lift, frequent item set, and threshold is 1. So these are the following rules. Now a few rules with a high lift value, which means that it occurs more frequently than would be expected given the number of transactions and the product combinations. most of the places the confidence is high as well. So these are few of the observations what we get here. If we filter the data frame using the standard pandas code for large lift 6 and high confidence 0.8, this is what the output is going to look like. These are 1, 2, 3, 4, 5, 6, 7, 8. So as you can see here, we have the 8 rules, which are the final rules which are given by the association rule mining. And that is how all the industries or any of these, we talk about large retailers, they tend to know how their products are used and how exactly they should rearrange and provide the offers on the products so that people spend more and more money and time in their shop. So that was all about association rule mining. So guys, that's all for unsupervised learning. I hope you got to know about the different formulas, how unsupervised learning works. Because we did not provide any label to the data. All we did was create some rules and not knowing what the data is. And we did clusterings, different types of clusterings, k-means, c-means, hierarchical clustering.
Reinforcement learning is a part of machine learning where an agent is put in an environment and he learns to behave in this environment by performing certain actions. Okay, so it basically performs actions and it either gets rewards on the actions or it gets a punishment and observing the reward which it gets from those actions. Reinforcement learning is all about taking an appropriate action in order to maximize the reward in a particular situation. So guys, in supervised learning, the training data comprises of the input and the expected output. And so the model is trained with the expected output itself. But when it comes to reinforcement learning, there is no expected output. Here, the reinforcement agent decides what actions to take in order to perform a given task. In the absence of a training data set, it is bound to learn from its experience itself. All right. So reinforcement learning is all about an agent who's put in an unknown environment and he's going to use a hit and trial method in order to figure out the environment and then come up with an outcome. Okay. Now let's look at reinforcement learning with an analogy. So consider a scenario wherein a baby is learning how to walk. This scenario can go about in two ways. Now in the first case, the baby starts walking and makes it to the candy. Here the candy is basically the reward it's going to get. So since the candy is the end goal, the baby is happy. It's positive. Okay, so the baby is happy and it gets rewarded a set of candies. Now another way in which this could go is that the baby starts walking but falls due to some hurdle in between. The baby gets hurt and it doesn't get any candy and obviously the baby is sad, so this is a negative reward, okay, or you can say this is a setback. So just like how we humans learn from our mistakes by trial and error, reinforcement learning is also similar. Okay, so we have an agent which is basically the baby and a reward which is the candy over here, okay, and with many hurdles in between. The agent is supposed to find the best possible path to reach the reward. So guys, I hope you all are clear with the reinforcement learning. Now let's look at the reinforcement learning process. So generally, a reinforcement learning system has two main components. All right, the first is an agent and the second one is an environment. Now in the previous case, we saw that the agent was the baby and the environment was the living room wherein the baby was crawling. Okay, the environment is the setting that the agent is acting on and the agent over here represents the reinforcement learning algorithm. So guys, the reinforcement learning process starts when the environment sends a state to the agent and then the agent will take some actions based on the observations. In turn, the environment will send the next state and the respective reward back to the agent. The agent will update its knowledge with the reward returned by the environment and it uses that to evaluate its previous action. So guys, this loop keeps continuing until the environment sends a terminal state, which means that the agent has accomplished all his tasks and he finally gets the reward. Okay, this is exactly what is depicted in this scenario. So the agent keeps climbing up ladders until he reaches his reward. To understand this better, let's suppose that our agent is learning to play Counter-Strike. Okay, so let's break it down. Now, initially the RL agent, which is basically the player one, let's say it's the player one who is trying to learn how to play the game. Okay, he collects some state from the environment. Okay, this could be the first state of Counter-Strike. Now, based on this state, the agent will take some action. Okay, and this action can be anything that causes a result. So if the player moves left or right, it's also considered as an action. Okay, so initially the action is going to be random because obviously the first time you pick up Counter-Strike, you're not going to be a master at it. So you're going to try with different actions and you're just going to pick up a random action in the beginning. Now the environment is going to give a new state. So after clearing that, the environment is now going to give a new state to the agent or to the player. So maybe he's crossed stage 1, now he's in stage 2. So now the player will get a reward R1 from the environment because it cleared stage 1. So this reward can be anything. It can be additional points or coins or anything like that. Okay, so basically this loop keeps going on until the player is dead or reaches the destination. Okay, and it continuously outputs a sequence of states, actions, and rewards. So guys, this was a small example to show you how reinforcement learning process works. So you start with an initial state, and once the player clears that state, he gets a reward. After that, the environment will give another stage to the player, and after it clears that state, it's going to get another reward, and it's going to keep happening until the player reaches his destination. Alright, so guys, I hope this is clear. Now let's move on and look at the reinforcement learning definitions. So there are a few concepts that you should be aware of while studying reinforcement learning. Let's look at those definitions over here. So first we have the agent. Now an agent is basically the reinforcement learning algorithm that learns from trial and error. Okay, so an agent takes actions like, for example, a soldier in Counter-Strike navigating through the game, that's also an action. Okay, if he moves left, right, or if he shoots at somebody, that's also an action. Okay, so the agent is responsible for taking actions in the environment. Now the environment is the whole Counter-Strike game. Okay, it's basically the world through which the agent moves. The environment takes the agent's current state and action as input, and it returns the agent's reward and its next state as output. Alright, next we have action. Now all the possible steps that an agent can take are called actions. So like I said, it can be moving right, left, or shooting, or any of that. Alright, then we have state. Now state is basically the current condition returned by the environment. So whichever state you are in, if you're in state 1 or if you're in state 2, that represents your current condition. Alright. Next we have reward. A reward is basically an instant return from the environment to appraise your last action. Okay, so it can be anything like coins or it can be additional points. So basically a reward is given to an agent after it clears the specific stages. Next we have policy. Policy is basically the strategy that the agent uses to find out his next action based on his current state. Policy is just the strategy with which you approach the game. Then we have value. Now value is the expected long-term return with discount. So value and action value can be a little bit confusing for you right now, but as we move further, you'll understand what I'm talking about. Okay, so value is basically the long-term return that you get with discount. Okay, discount I'll explain in the further slides. Then we have action value. Now action value is also known as Q value. Okay, it's very similar to value except that it takes an extra parameter which is the current action. So basically here you'll find out the Q value depending on the particular action that you took. Alright, so guys, don't get confused with value and action value. We'll look at examples in the further slides and you'll understand this better. Okay, so guys, make sure that you're familiar with these terms because you'll be seeing a lot of these terms in the further slides. Alright. Now, before we move any further, I'd like to discuss a few more concepts. Okay, so first we'll discuss the reward maximization. So if you haven't already realized it, the basic aim of the RL agent is to maximize the reward. Now, how does that happen? Let's try to understand this in depth. So the agent must be trained in such a way that he takes the best action so that the reward is maximum. Because the end goal of reinforcement learning is to maximize your reward based on a set of actions. So let me explain this with a small game. Now in the figure you can see there is a fox, there's some meat and there's a tiger. So our agent is basically the fox and his end goal is to eat the maximum amount of meat before being eaten by the tiger. Now since the fox is a clever fellow, he eats the meat that is closer to him rather than the meat which is closer to the tiger. Now this is because the closer he is to the tiger, the higher are his chances of getting killed. So because of this, the rewards which are near the tiger, even if they are bigger meat chunks, they will be discounted. So this is exactly what discounting means. So our agent is not going to eat the meat chunks which are closer to the tiger because of the risk. Alright. Now even though the meat chunks might be larger, he does not want to take the chances of getting killed. Okay, this is called discounting. Okay, this is where you discount because you improvise and you just eat the meat which are closer to you instead of taking risks and eating the meat which are closer to your opponent. Alright. Now the discounting of reward works based on a value called gamma. We'll be discussing gamma in our further slides, But in short, the value of gamma is between 0 and 1. Okay, so the smaller the gamma, the larger is the discount value. Okay, so if the gamma value is lesser, it means that the agent is not going to explore and he's not going to try and eat the meat chunks which are closer to the tiger. Okay, but if the gamma value is closer to 1, it means that our agent is actually going to explore and it's going to try and eat the meat chunks which are closer to the tiger. All right. Now I'll be explaining this in depth in the further slides, so don't worry if you haven't got a clear concept yet. But just understand that reward maximization is a very important step when it comes to reinforcement learning, because the agent has to collect maximum rewards by the end of the game. All right. Now let's look at another concept which is called exploration and exploitation. So exploration, like the name suggests, is about exploring and capturing more information about an environment. On the other hand, exploitation is about using the already known exploited information to heighten the rewards. So guys, consider the fox and tiger example that we discussed. Now here the fox eats only the meat chunks which are close to him, but he does not eat the meat chunks which are closer to the tiger. Okay, even though they might give him more rewards, he does not eat them. If the fox only focuses on the closest rewards, he will never reach the big chunks of meat. Okay, this is what exploitation is about. You're just going to use the currently known information and you're going to try and get rewards based on that information. But if the fox decides to explore a bit, it can find the bigger reward, which is the big chunks of meat. This is exactly what exploration is. So the agent is not going to stick to one corner. Instead, he's going to explore the entire environment and try and collect bigger rewards. All right. So guys, I hope you all are clear with exploration and exploitation. Now let's look at the Markov's decision process. So guys, this is basically a mathematical approach for mapping a solution in reinforcement learning. In a way, the purpose of reinforcement learning is to solve a Markov decision process. Okay, so there are a few parameters that are used to get to the solution. So the parameters include the set of actions, the set of states, the rewards, the policy that you're taking to approach the problem, and the value that you get. Okay, so to sum it up, the agent must take an action A to transition from a start state to the end state S. While doing so, the agent will receive a reward R for each action that he takes. So guys, a series of actions taken by the agent define the policy, or it defines the approach. And the rewards that are collected define the value. So the main goal here is to maximize the rewards by choosing the optimum policy. Alright, now let's try to understand this with the help of the shortest path problem. I'm sure a lot of you might have gone through this problem when you were in college. So guys, look at the graph over here. So our aim here is to find the shortest path between A and D with minimum possible cost. So the value that you see on each of these edges basically denotes the cost. So if I want to go from A to C, it's going to cost me 15 points. Okay, so let's look at how this is done. Now, before we move and look at the problem, in this problem, the set of states are denoted by the nodes, which is A, B, C, D. And the action is to traverse from one node to the other. So if I'm going from A to B, that's an action. Similarly, A to C, that's an action. Okay. The reward is basically the cost, which is represented by each edge over here. All right. Now, the policy is basically the path that I choose to reach the destination. So let's say I choose A, C, D. Okay. That's one policy. In order to get to D, I'm choosing A, C, D, which is a policy. Okay. It's basically how I'm approaching the problem. So guys, here you can start off at node A and you can take baby steps to your destination. Now, initially you're clueless, so you can just take the next possible node which is visible to you. So guys, if you're smart enough, you're going to choose A to C instead of A, B, C, D or A, B, D. Alright. So now if you're at node C, you want to traverse to node D. You must again choose a wise path. Alright. You just have to calculate which path has the highest cost or which path will give you the maximum rewards. So guys, this is a simple problem. We're just trying to calculate the shortest path between A and D by traversing through these nodes. So if I traverse from A, C, D, it gives me the maximum reward. Okay, it gives me 65, which is more than any other policy would give me. Okay, so if I go from A, B, D, it would be 40. When you compare this to A, C, D, it gives me more reward. So obviously, I'm going to go with A, C, D. Okay, so guys, this was a simple problem in order to understand how Markov decision process works. All right. So guys, I want to ask you a question. What do you think I did here? Did I perform exploration or did I perform exploitation? Now, the policy for the above example is of exploitation because we didn't explore the other nodes. Okay, we just selected 3 nodes and we traversed through them. So that's why this is called exploitation. We must always explore the different nodes so that we can find a more optimal policy. But in this case, obviously ACD has the highest reward and we're going with ACD. But generally, it's not so simple. There are a lot of nodes. There are hundreds of nodes to traverse and there are like 50, 60 policies. Okay, 50, 60 different policies. So you make sure you explore through all the policies and then decide on an optimum policy, which will give you a maximum reward.
Now, for a robot, an environment is a place where it has been put to use. Now remember, this robot is itself the agent. For example, an automobile factory where a robot is used to move materials from one place to another. Now the tasks we discussed just now have a property in common. Now these tasks involve an environment and expect the agent to learn from the environment. Now this is where traditional machine learning fails and hence the need for reinforcement learning. Now it is good to have an established overview of the problem that is to be solved using the Q-learning or the reinforcement learning. So it helps to define the main components of a reinforcement learning solution, that is the agent, environment, action, rewards, and states. So let's suppose we are to build a few autonomous robots for an automobile building factory. Now these robots will help the factory personnel by conveying them the necessary parts that they would need in order to build the car. Now these different parts are located at 9 different positions within the factory warehouse. The car part include the chassis, wheels, dashboard, the engine, and so on. And the factory workers have prioritized the location that contains the body or the chassis to be the topmost. But they have provided the priorities for other locations as well, which we will look into the moment. Now these locations within the factory look somewhat like this. So as you can see here, we have L1, L2, L3, all of these stations. Now, one thing you might notice here that there are little obstacles present in between the locations. So L6 is the top priority location that contains the chassis for preparing the car bodies. Now the task is to enable the robots so that they can find the shortest route from any given location to another location on their own. Now the agents in this case are the robots. The environment is the automobile factory warehouse. So let's talk about the states. So the states are the location in which a particular robot is present in the particular instance of time, which will denote its states. Now machines understand numbers rather than letters, so let's map the location codes to number. So as you can see here, we have mapped location L1 to the state 0, L2 and 1, and so on. We have L8 as state 7 and L9 at state 8. Well, next, what we're going to talk about are the actions. So in our example, the action will be the direct location that a robot can go from a particular location, right? Consider a robot that is at L2 location, and the direct locations to which it can move are L5, L1, and L3. Now, the figure here may come in handy to visualize this. Now, as you might have already guessed, the set of actions here is nothing but the set of all possible states of the robot. For each location, the set of actions that a robot can take will be different. For example, the set of actions will change if the robot is in L1 rather than L2. So if the robot is in L1, it can only go to L4 and L2 directly. Now that we are done with the states and the actions, let's talk about the rewards. So the states are basically 0, 1, 2, 3, 4, and the actions are also 0, 1, 2, 3, 4 up till 8. Now the rewards now will be given to a robot if a location, which is the state, is directly reachable from a particular location. So let's take an example. Suppose L9 is directly reachable from L8, right? So if a robot goes from L8 to L9 and vice versa, it will be rewarded by 1. And if a location is not directly reachable from a particular location, we do not give any reward, a reward of 0. Now the reward is just a number here and nothing else. It enables the robots to make sense of their movements, helping them in deciding what locations are directly reachable and what are not. Now with this queue, we can construct a reward table which contains all the reward values mapping between all possible states. So as you can see here in the table, the positions which are marked green have a positive reward. And as you can see here, we have all the possible rewards that a robot can get by moving in between the different states. Now comes an interesting decision. Now remember that the factory administrator prioritized L6 to be the topmost. So how do we incorporate this fact in the above table? Now this is done by associating the topmost priority location with a very higher reward than the usual ones. So let's put 999 in the cell L6, L6. Now the table of rewards with a higher reward for the topmost location looks something like this. We have now formally defined all the vital components for the solution we are aiming for the problem discussed now. We will shift gears a bit and study some of the fundamental concepts that prevail in the world of reinforcement learning and Q-learning. So first of all, we'll start with the Bellman equation. Now consider the following square of rooms, which is analogous to the actual environment from our original problem, but without the barriers. Now suppose a robot needs to go to the room marked in the green from its current position A using the specified direction. Now how can we enable the robot to do this programmatically? One idea would be introduce some kind of a footprint which the robot will be able to follow. Now here a constant value is specified in each of the rooms which will come along the robot's way if it follows the direction specified above. Now in this way, if it starts at location A, it will be able to scan through this constant value and will move accordingly. But this will only work if the direction is prefixed and the robot always starts at the location A. Now consider the robot starts at this location rather than its previous one. Now the robot now sees footprints in two different directions. It is, therefore, unable to decide which way to go in order to get the destination, which is the green room. It happens primarily because the robot does not have a way to remember the directions to proceed. So our job now is to enable the robot with a memory. Now this is where the Bellman equation comes into play. So as you can see here, the main reason of the Bellman equation is to enable the robot with a memory. That's the thing we're going to use. So the equation goes something like this. V of S gives maximum of A, R of S comma A plus gamma of V S dash, where S is a particular state, which is a room, A is the action moving between the rooms, S dash is the state to which the robot goes from S, and gamma is the discount factor. Now we'll get into it in a moment, and obviously R of S comma A is a reward function which takes a state S and action A and outputs the reward. Now V of S is the value of being in a particular state, which is the footprint. Now we consider all the possible actions and take the one that yields the maximum value. Now there is one constraint, however, regarding the value footprint, that is the room marked in the yellow just below the green room. It will always have the value of 1 to denote, that is, one of the nearest room adjacent to the green room. Now this is also to ensure that a robot gets a reward when it goes from a yellow room to the green room. Let's see how to make sense of the equation which we have here. So let's assume a discount factor of 0.9. As you remember, gamma is the discount value or the discount factor, so let's take it 0.9. Now for the room which is marked just below the 1 or the yellow room, which is the asterisk mark, for this room, what will be the V of S? That is the value of being in a particular state. So for this, V of S would be something like maximum of A will take 0, which is the initial of R S comma A, plus 0.9, which is gamma, into 1. That gives us 0.9. Now here the robot will not get any reward for going to a state marked in yellow, hence the R S comma A is 0 here. But the robot knows the value of being in the yellow room, hence V of S dash is 1. Following this, for the other states, we should get 0.9. Then again, if we put 0.9 in this equation, we get 0.81, then 0.729, and then we again reach the starting point. So this is how the table looks with some value footprints computed from the Bellman equation. Now a couple of things to notice here is that the max function helps the robot to always choose the state that gives it the maximum value of being in that state. Now the discount factor gamma notifies the robot about how far it is from the destination. This is typically specified by the developer of the algorithm that would be installed in the robot. Now the other states can also be given their respective values in a similar way. So as you can see here, the boxes adjacent to the green one have 1. And if we move away from 1, we get 0.9, 0.81, 0.729, and finally we reach 0.66. Now the robot now can proceed its way through the green room, utilizing these value footprints even if it's dropped at any arbitrary room in the given location. Now if a robot lands up in the highlighted sky blue area, it will still find two options to choose from. But eventually, either of the paths will be good enough for the robot to take because of the way the value footprints are now laid out. Now, one thing to note here is that the Bellman equation is one of the key equations in the world of reinforcement learning and Q-learning. So if we think realistically, our surroundings do not always work in the way we expect. There is always a bit of stochasticity involved in it. Now, this applies to robot as well. Sometimes it might so happen that the robot's machinery got corrupted. Sometimes the robot may come across some hindrance on its way, which may not be known to it beforehand, right? And sometimes even if the robot knows that it needs to take the right turn, it will not. So how do we introduce this stochasticity in our case? Now here comes the Markov decision process. Now consider the robot is currently in the red room and it needs to go to the green room. Now let's now consider the robot has a slight chance of dysfunctioning and might take the left or the right or the bottom turn instead of taking the upper turn in order to get to the green room from where it is now, which is the red room. Now the question is, how do we enable the robot to handle this when it is out in the given environment, right? Now, this is a situation where the decision making regarding which turn is to be taken is partly random and partly under the control of the robot. Now, partly random because we are not sure when exactly the robot might dysfunctional, and partly under the control of the robot because it is still making a decision of taking a turn right on its own and with the help of the program embedded into it. So, a Markov decision process is a discrete time stochastic control process. It provides a mathematical framework for modeling decision making in situations where the outcomes are partly random and partly under the control of the decision maker. Now we need to give this concept a mathematical shape, most likely an equation, which then can be taken further. Now, you might be surprised that we can do this with the help of the Bellman equation with a few minor tweaks. So if we have a look at the original Bellman equation, V of x is equal to maximum of R s comma a plus gamma V of s dash. What needs to be changed in the above equation so that we can introduce some amount of randomness here. As long as we are not sure when the robot might not take the expected turn, we are then also not sure in which room it might end up, in which is nothing but the room it moves from its current room. At this point, according to the equation, we are not sure of the S dash, which is the next state, or the room, but we do know all the probable turns the robot might take. Now, in order to incorporate each of these probabilities into the above equation, we need to associate a probability with each of the turns to quantify the robot if it has got any X% chance of taking this turn. Now, if we do so, we get Ps is equal to maximum of Rs comma a plus gamma into summation of S dash Ps comma a comma S dash into V of S dash. Now the Ps, A and S dash is the probability of moving from room S to S dash with the action A. And the summation here is the expectation of the situation that the robot incurs, which is the randomness. Now let's take a look at this example here. So when we associate the probabilities to each of these turns, we essentially mean that there is an 80% chance that the robot will take the upper turn. Now if we put all the required values in our equation, we get V of S is equal to maximum of R of S comma A plus gamma of 0.8 into V of room up plus 0.1 into V of room down, 0.03 into room of V of room left plus 0.03 into V of room right. Now note that the value footprints will now change due to the fact that we are incorporating stochastically here. But this time we will not calculate those value footprints. Instead, we will let the robot to figure it out. Now up until this point, we have not considered about rewarding the robot for its action of going into a particular room. We are only rewarding the robot when it gets to the destination. Now ideally there should be a reward for each action the robot takes to help it better assess the quality of the actions, but the rewards need not to be always be the same. But it is much better than having some amount of reward for the actions than having no rewards at all, right? And this idea is known as the living penalty. In reality, the reward system can be very complex, and particularly modeling sparse rewards is an active area of research in the domain of reinforcement learning. So by now we have got the equation which we have here. So what we're going to do is now transition to Q-learning. So this equation gives us the value of going to a particular state, taking the stochasticity of the environment into account. Now we have also learned very briefly about the idea of living penalty, which deals with associating each move of the robot with a reward. So Q-learning possesses an idea of assessing the quality of an action that is taken to move to a state rather than determining the possible value of the state which is being moved to. So earlier we had 0.8 into V of S1, 0.03 into V of S2, 0.1 into V of S3, and so on. Now if we incorporate the idea of assessing the quality of the action for moving to a certain state, so the environment with the agent and the quality of the action will look something like this. So instead of 0.8 V of S1, we'll have Q of S1, A1, we'll have Q of S2, A2, Q of S3. Now the robot now has 4 different states to choose from, and along with that there are 4 different actions also for the current state it is in. So how do we calculate Q of S, A, that is the cumulative quality of the possible actions the robot might take? So let's break it down. Now from the equation V of S equals maximum of A R S, A plus gamma summation S dash P S A S dash into V of S dash. If we discard the maximum function, we have R S of A plus gamma into summation P and V. Now essentially in the equation that produces V of S, we are considering all possible actions and all possible states from the current state that the robot is in. And then we are taking the maximum value caused by taking a certain action, and the equation produces a value footprint which is for just one possible action. In fact, we can think of it as the quality of the action. So Q of S, A is equal to R S, A plus gamma of summation P and V. Now that we have got an equation to quantify the quality of a particular action, we are going to make a little adjustment in the equation. We can now say that V of S is the maximum of all the possible values of Q of S, A, right? So let's utilize this fact and replace V of S dash as a function of Q. So Q S, A becomes R of S, A plus gamma of summation P S A S dash and maximum of the Q S dash A dash. So the equation of V is now turned into an equation of Q, which is the quality. But why would we do that? Now this is done to ease our calculations because now we have only one function Q, which is also the core of the dynamic programming language. We have only one function Q to calculate, and R of S, A is a quantified metric which produces reward of moving to a certain state. Now the qualities of the actions are called the Q values, and from now on we will refer to the value footprints as the Q values. An important piece of the puzzle is the temporal difference. Now temporal difference is the component that will help the robot calculate the Q values with respect to the changes in the environment over time. So consider our robot is currently in the mark state and it wants to move to the upper state. One thing to note that here is that the robot already knows the Q value of making the action, that is moving to the upper state. And we know that the environment is stochastic in nature and the reward that the robot will get after moving to the upper state might be different from an earlier observation. So how do we capture this change, the real difference? We calculate the new Q S, A with the same formula and subtract the previously known Q S A from it. So this will in turn give us the new QA. Now the equation that we just derived gives the temporal difference in the Q values, which further helps to capture the random changes in the environment which may impose. Now the new Q S, A is updated as the following. So Qt of S, A is equal to Qt minus 1 S, A plus alpha TDT of A, S. Now here alpha is the learning rate which controls how quickly the robot adapts to the random changes imposed by the environment. The Qt S, A is the current state Q value, and the q t minus 1 s comma a is the previously recorded q value. So if we replace the td s comma a with its full form equation, we should get qt of s comma a is equal to qt minus 1 of s comma a plus alpha into r of s comma a plus gamma maximum of q s dash a dash minus qt minus 1 s comma a. Now that we have all the little pieces of q learning together, let's move forward to its implementation part. Now this is the final equation of q learning, right? So let's see how we can implement this and obtain the best path for any robot to take. Now to implement the algorithm, we need to understand the warehouse location and how that can be mapped to different states. So let's start by recollecting the sample environment. So as you can see here, we have L1, L2, L3 till L9. And as you can see here, we have certain borders also. So first of all, let's map each of the above locations in the warehouse to numbers or the states so that it will ease our calculations, right? So what I'm going to do is create a new Python 3 file in the Jupyter notebook, and I'll name it as qlearning numpy. Okay, so let's define the states. But before that, what we need to do is import numpy because we're going to use numpy for this purpose. And let's initialize the parameters, that is the gamma and alpha parameters. So gamma is 0.75, which is the discount factor, whereas alpha is 0.9, which is the learning rate. Now next what we're going to do is define the states and map it to numbers. So as I mentioned earlier, L1 is 0 and till L9 we have defined the states in the numerical form. Now the next step is to define the actions, which is, as mentioned above, represent the transition to the next state. So as you can see here, we have an array of actions from 0 to 8. Now what we're going to do is define the reward table. So as you can see here, it's the same matrix that we created just now, that I showed you just now. Now if you understood it correctly, there isn't any real barrier limitation as depicted in the image. For example, the transition L4 to L1 is allowed, but the reward will be 0 to discourage that path. Or in tough situation, what we do is add a -1 there so that it gets a negative reward. Now in the above code snippet, as you can see here, we took each of the states and put ones in the respective state that are directly reachable from the certain state. Now if we refer to that reward table once again, what we created, the above array construction will be easy to understand. But one thing to note here is that we did not consider the top priority location L6 yet. We would also need an inverse mapping from the states back to its original location, and it will be cleaner when we reach to the utter depths of the algorithms. So for that, what we're going to do is have the inverse map location. State to location, we will take the distinct state and location and convert it back. Now what we'll do is we'll now define a function getOptimal, which is the getOptimal route, which will have a start location and an end location. Don't worry, the code is big, but I'll explain you each and every bit of the code. Now the getOptimal route function will take two arguments, the starting location in the warehouse and the end location in the warehouse respectively. And it will return the optimal route for reaching the end location from the starting location in the form of an ordered list containing the letters. So we'll start by defining the function by initializing the q values to be all zeros. So as you can see here, we have given the q values to be 0, but before that, what we need to do is copy the reward matrix to a new one. So this is the rewards new. And next again, what we're going to do is get the ending state corresponding to the ending location. And with this information, automatically we'll set the priority of the given ending state to the highest one. Right? We are not defining it now, but we'll automatically set the priority of the given ending state as 999. So what we're going to do is initialize the q values to be 0. And in the q learning process, what you can see here, we are taking I in range 1000, and we're going to pick up a state randomly. So we're going to use the np.random rand int. And for traversing through the neighbor location in the same maze, we're going to iterate through the new reward matrix and get the actions which are greater than 0. And after that, what we're going to do is pick an action randomly from the list of the playable actions nearest to the next state. We're going to compute the temporal difference, which is TD, which is the rewards plus gamma into the queue of next state, and we'll take np.argmax of queue of next state minus queue of the current state. We're going to then update the queue values using the Bellman equation. As you can see here, we have the Bellman equation, and we're going to update the queue values. And after that, we're going to initialize the optimal route with the starting location. Now, here we do not know what the next location yet. So initialize it with the value of the starting location, which again is the random location. Now, we do not know about the exact number of iterations needed to reach to the final location. Hence, while loop will be a good choice for the iteration. So we're going to fetch the starting state, fetch the highest queue value penetrating to the starting state. We go to the index of the next state, but we need the corresponding letter. So we're going to use that state to location function we just mentioned there. And after that, we're going to update the starting location for the next iteration. And finally, we'll return the route. So let's take the starting location of L9 and the end location of L1 and see what part do we actually get. So as you can see here, we get L9, L8, L5, L2, and L1. And if you have a look at the image here we have, if we start from L9 to L1, we got L8, L5, L2, L1, L8, L5, L2, L1. That would yield us the maximum value or the maximum reward for the robot. So now we have come to the end of this Q-learning session. The past year has seen a lot of great examples for machine learning, and many new high-impact applications of machine learning were discovered and brought to light, especially in the healthcare, finance, the speech recognition, augmented reality, and much more complex 3D and video applications. Now, natural language processing was easily the most talked about domain within the community, with the likes of ULMFIT and BERT being open sourced. So let's have a look at some of the amazing machine learning projects which are open sourced. The code is available for you, and those were discussed in this 2018 to 19 spectrum. So the first and the foremost is TensorFlow.js. Now, machine learning in the browser, a fictional thought a few years back and a stunning reality now. A lot of us in this field are welded to our favorite IDEs, but TensorFlow.js has the potential to change your habits. It's become a very popular release since its release earlier this year and continues to amaze with its flexibility. Now, as the repository states, there are primarily three major features of TensorFlow.js. Develop machine learning and deep learning models in your browser itself, run pre-existing TensorFlow models within the browser, retrain or fine-tune these pre-existing models as well. And if you're familiar with Keras, the high-level layers API will seem quite familiar. Now, there are plenty of examples available on GitHub repository, so do check out those links to quicken your learning curve. And as I mentioned earlier, I'll leave the links to all of these open source machine learning projects in the description below. Now, next, what we're going to discuss is Detectron. It is developed by Facebook and made a huge splash when it was earlier launched in 2018. It was developed by Facebook's AI research team, which is FAIR, and it implements the state-of-the-art object detection frameworks. It is written in Python and has helped enable multiple projects, including the DensePose. Now, we'll know what exactly is DensePose after this example, and this repository contains the code of over 70 pre-trained models. So it's a very good open source model, guys, so do check it out. Now, the moment I talked about DensePose, that's the next one I'm going to talk about. So DensePose is dense human pose estimation in the wild. Now, the code to train and evaluate your own DensePose using the RCNN model is included here. And I've given the link to the open source code in the description below. And there are notebooks available as well to visualize the DensePose COCO dataset. Now, next in our list, we have deep painterly harmonization. Now, I want you to take a moment to just admire the above images. Can you tell which ones were done by a human and which one by a machine? I certainly could not. Now here, the first frame is the input image, the original one, and the third frame, as you can see here, has been generated by this technique. Amazing, right? The algorithm adds an external object to your choosing to any image and manages it to make it look like nothing touched it. Now make sure you check out the code and try to implement it on different sets of images yourself. It is really fun. Now talking about images, we have image out painting. Now, what if I give you an image and ask you to extend its boundaries by imagining what it would look like when the entire scene was captured? You would understandably turn to some image editing software. But here's the awesome news. You can achieve it in few lines of code, which is the image outpainting. Now, this project is a Keras implementation of Stanford image outpainting paper, which is incredibly cool and an illustrated paper, and this is how most research papers should be. I have given the links in the description below. Do check it out, guys, and see how you can implement it. Now let's talk about audio processing, which is another field where machine learning has started to make its mark. It is not just limited to generate music. You can do tasks like audio classification, fingerprinting, segmentation, tagging, and much more. And there is a lot that's still yet to be explored, and who knows, perhaps you could use this project to pioneer your way to the top. Now, what if you want to discover your own planet? Now, that might perhaps be overstating things a bit, but the Astronet repository will definitely get you close. The Google Brain team discovered 2 new planets in December 2017 by applying the Astronet. It's a deep neural network meant for working with astronomical data. It goes to show the far-ranging application of machine learning and was a truly monumental development. And now the team behind the technology has open sourced the entire code. So go ahead and check out your own planet, and who knows, you might even have a planet on your name. Now, I could not possibly let this section pass by without mentioning the BERT. The Google AI's release has smashed record on its way to winning the hearts of NLP enthusiasts and experts alike. Following ULMFIT and ELMO, BERT really blew away the competition with its performance. It obtained the state-of-art result on 11 NLP tasks. Apart from the official Google repository, there is a PyTorch implementation of BERT, which is worth checking out. Whether it makes a new era or not in natural language processing, we will soon find out. Now, AdaNet, I'm sure you guys might have heard of it. It is a framework for automatically learning high-quality models without requiring programming expertise. Since it's a Google invention, the framework is based on TensorFlow, and you can build Ansible models using AdaNet and even extend it to use to train a neural network. Now, the GitHub page contains the code, an example, the API documentation, and other things to get your hands dirty. Now, trust me, AutoML is the next big thing in our field. Now, if you follow a few researchers on social media, you must have come across some of the images I am showing here in a video form. A stick human running across a terrain, or trying to stand up, or some sort. Now, that, my friends, is reinforcement learning in action. Now here's a signature example of it, a framework to train a simulated humanoid to imitate multiple motion skill. So let's have a look at the top 10 skills which are required to become a successful machine learning engineer. So starting with programming languages, Python is the lingua franca of machine learning. You may have had exposure to Python even if you weren't previously in programming or in a computer science related field. However, it is important to have a solid understanding of classes and data structures. Sometimes Python won't be enough. Often, you'll encounter projects that need to leverage hardware for speed improvements. Now make sure you're familiar with the basic algorithms as well as the classes, memory management, and linking. Now if you want a job in machine learning, you will probably have to learn all of these languages at some point. C++ can help in speeding code up, whereas R works great in statistics and plots. And Hadoop is Java-based, so you probably need to implement mappers and reducers in Java. Now next we have linear algebra. You'll need to be intimately familiar with matrices, vectors, and matrix multiplication. If you have an understanding of derivatives and integrals, you should be in the clear. Otherwise, even simple concepts like gradient descents will elude you. Statistics is going to come up a lot. At least make sure you are familiar with the Gaussian distributions, means, standard deviation, and much more. Every bit of statistical understanding beyond this helps. Now, theories help in learning about algorithms. Great samples are naive Bayes, Gaussian mixture models, and hidden Markov models. You need to have a firm understanding of probability and stats to understand these models. Just go nuts and study measure theory. And next we have advanced signal processing techniques. Now, feature abstraction is one of the most important parts of machine learning. Different types of problems need various solutions. You may be able to utilize really cool advanced signal processing algorithms such as wavelets, shearlets, curvelets, and bandlets. You need to learn about the time frequency analysis and try to apply it in your problems. Now this skill will give you an edge over all the other skills. Now this skill will give you an edge while you're applying for a machine learning engineer job over others. Now next we have applied maths. A lot of machine learning techniques out there are just fancy types of functional approximation. Now these often get developed by theoretical mathematicians and then get applied by people who do not understand the theory at all. Now the result is that many developers might have a hard time finding the best techniques for the problem. So even a basic understanding of numerical analysis will give you a huge edge. Having a firm understanding of algorithm theory and knowing how the algorithm works, you can also discriminate models such as SVMs. Now you will need to understand subjects such as gradient descent, convex optimization, Lagrange, quadratic programming, partial differentiation equations, and much more. Now all this math might seem intimidating at first if you've been away from it for a while. Yes, machine learning is much more math intensive than something like front-end development. Just like any other skill, getting better at math is a matter of focused practice. The next skill in our list is the neural network architectures. We need machine learning for tasks that are too complex for human to code directly. That is, tasks that are so complex that it is impractical. Now, neural networks are a class of models within the general machine learning literature. Now, neural networks are a specific set of algorithms that have revolutionized machine learning. They are inspired by biological neural networks, and the current so-called deep neural networks have proven to work quite well. The neural networks are themselves general function approximations, which is why they can be applied to almost any machine learning problem about learning a complex mapping from the input to the output space. Of course, there are still good reasons for the surge in the popularity of neural networks, but neural networks have been by far the most accurate way of approaching many problems like translation, speech recognition, and image classification. Now coming to our next point, which is the natural language processing. Now, since it combines computer science and linguistics, there are a bunch of libraries like the NLTK, GenSysm, and the techniques such as sentimental analysis and summarization that are unique to NLP. Now, audio and video processing has a frequent overlap with the natural language processing. However, natural language processing can be applied to non-audio data like text. Voice and audio analysis involves extracting useful information from the audio signals themselves. Being well versed in math will get you far in this one. And you should also be familiar with the concepts such as the fast Fourier transforms. Now these were the technical skills that are required to become a successful machine learning engineer. So next I'm going to discuss some of the non-technical skills or the soft skills which are required to become a machine learning engineer. So first of all, we have the industry knowledge. Now the most successful machine learning projects out there are going to be those that address real pain points. Whichever industry you are working for, you should know how that industry works and what will be beneficial for the business. If a machine learning engineer does not have business acumen and the know-how of the elements that make up a successful business model or any particular algorithm, then all those technical skills cannot be channeled productively. You won't be able to discern the problems and potential challenges that need solving for the business to sustain and grow. You won't really be able to help your organization explore new business opportunities. So this is a must-have skill. Now next we have effective communication. You'll need to explain the machine learning concepts to the people with little to no expertise in the field. Chances are you'll need to work with a team of engineers as well as many other teams. So communication is going to make all of this much more easier. Companies searching for a strong machine learning engineer are looking for someone who can clearly and fluently translate their technical findings to a non-technical team, such as marketing or sales department. Now next on our list we have rapid prototyping. So iterating on ideas as quickly as possible is mandatory for finding one that works. In machine learning, this applies to everything from picking up the right model to working on projects such as A/B testing. You need to do a group of techniques used to quickly fabricate a scale model of a physical part or assembly using the three-dimensional computer-aided design, which is the CAD. So last but not the least, we have the final skill, and that is to keep updated. You must stay up to date with any upcoming changes. Every month, new neural network models come out that outperform the previous architecture. It also means being aware of the news regarding the development of the tools, the changelog, the conferences, and much more. You need to know about the theories and algorithms. Now this you can achieve by reading the research papers, blogs, the conferences, videos, And also you need to focus on the online community, which changes very quickly. So expect and cultivate this change. Now this is not the end. Here we have certain skills, the bonus skills, which will give you an edge over other competitors or the other persons who are applying for a machine learning engineer position. On the bonus point, we have physics. Now you might be in a situation where you would like to apply machine learning techniques to a system that will interact with the real world. Having some knowledge of physics will take you far. Now next we have reinforcement learning. So this reinforcement learning has been a driver behind many of the most exciting developments in the deep learning and the AI community. From the AlphaGo Zero to the OpenAI's Dota 2 bot. This will be critical to understand if you want to go into robotics, self-driving cars, or other AI-related areas. And finally, we have computer vision. Out of all the disciplines out there, there are by far the most resources available for learning computer vision. This field appears to have the lowest barriers to entry, but of course this likely means you'll face slightly more competition. So having a good knowledge of computer vision, how it works, will give you an edge over other competitors. Now I hope you got acquainted with all the skills which are required to become a successful machine learning engineer. As you know, we are living in the worlds of humans and machines. In today's world, these machines or the robots have to be programmed before they start following your instructions. But what if the machine started learning on its own from their experience, work like us and feel like us, and do things more accurately than us? Now, well, here's where a machine learning engineer comes into picture to make sure everything is working according to the procedures and the guidelines. Now, in my opinion, machine learning is one of the most recent and exciting technologies there is. You probably use it a dozen of times every day without even knowing it. So before we indulge into the different roles, the salary trends, and what should be there on the resume of a machine learning engineer while applying for a job, let's understand who exactly a machine learning engineer is. So machine learning engineers are sophisticated programmers who develop machines and systems that can learn and apply knowledge without specific direction. Artificial intelligence is the goal of a machine learning engineer. They are computer programmers, but their focus goes beyond specifically programming machines to perform specific tasks. They create programs that will enable machines to take actions without being specifically directed to perform those tasks. Now, if we have a look at the job trends of a machine learning engineer, so as you can see in Seattle itself, we have 2,000 jobs. In New York, we have 1,100. In San Francisco, we have 1,100. In Bengaluru, India, we have 1,100. And then we have Sunnyvale, California, where we have 500 number of jobs. So as you can see, the number of jobs in the market is too much. And probably with the emergence of machine learning and artificial intelligence, this number is just going to get higher. Now, if we have a look at the job opening salary-wise percentage, so we can see for the $90,000 per annum bracket, we have 32.7%. And that's the maximum. So be assured that if you get a job as a machine learning engineer, you'll probably get around $90,000 a year. That's safe to say. Now for the $110,000 per year, we have 25%, $120,000, we have 20% almost. Then we have $130,000, which are the senior machine learning engineers. That's a 13.67%. And finally, we have the most senior machine learning engineer, or we have the data scientists here, which have the salary of $140,000 per annum, and the percentage for that one is really low. So as you can see, there is a great opportunity for people who are trying to go into machine learning field and get started with it. So let's have a look at the machine learning engineer's salary. So the average salary in the US is around $111,490, and the average salary in India is around 7,19,646 rupees. That's a very good average salary for any particular profession. So moving forward, if we have a look at the salary of an entry-level machine learning engineer, so the salary ranges from $76,000 or $77,000 to $151,000 per annum. That's a huge salary. And if we talk about the bonus here, we have like $3,000 to $25,000 depending on the work you do and the project you are working on. Let's talk about the profit sharing now. So it's around $2,000 to $50,000. Now this again depends upon the project you are working, the company you are working for, and the percentage that they give to the engineer or the developer for that particular project. Now the total pay comes around $76,000 or $75,000 to $162,000. And this is just for the entry level machine learning engineer. Just imagine if you become an experienced machine learning engineer, your salary is going to go through the roof. So now that we have understood who exactly is a machine learning engineer, the various salary trends, the job trends in the market, and how it's rising, let's understand what skills it takes to become a machine learning engineer. So first of all, we have programming languages. Now, programming languages are a big deal when it comes to machine learning because you don't just need to have proficiency in one language. You might require proficiency in Python, Java, R, or C++. Because you might be working in a Hadoop environment where you require Java programming to do the MapReduce codings, and sometimes R is very great for visualization purposes, and Python, as you know, is one of the favorite languages when it comes to machine learning. Now, next skill that a particular individual needs is calculus and statistics. So a lot of machine learning algorithms are mostly maths and statistics. And a lot of statistics is required, majorly the matrix multiplication and all. So a good understanding of calculus as well as statistics is required. Now next we have signal processing. Now advanced signal processing is something that will give you an upper edge over other machine learning engineers if you are applying for a job anywhere. Now the next skill we have is applied maths. As I mentioned earlier, many of the machine learning algorithms here are purely mathematical formulas. So a good understanding of maths and how the algorithm works will take you far ahead. Now next on our list we have neural networks. Now neural networks are something that has been emerging quite popularly in the recent years, and due to its efficiency and the extent to which it can work and get the results as soon as possible, neural networks are a must for a machine learning engineer. Now moving forward, we have language processing. So a lot of times machine learning engineers have to deal with text data, the voice data, as well as video data. Now processing any kind of language, audio, or the video is something that a machine learning engineer has to do on a daily basis. So one needs to be proficient in this area also. Now these were only some of the few skills which are absolutely necessary, I would say, for any machine learning engineer. So let's now discuss the job description or the roles and responsibilities of a particular machine learning engineer. Now, depending on their level of expertise, machine learning engineers may have to study and transform data science prototypes. They need to design machine learning systems. They also need to research and implement appropriate machine learning algorithms and tools, as it's a very important part of the job. They need to develop new machine learning application according to the industry requirements. They need to select the appropriate data sets and the data representation methods, because if there is a slight deviation in the data set and the data representation, that's going to affect the model a lot. They need to run machine learning tests and experiments. They need to perform statistical analysis and fine-tuning using the test results. So sometimes people ask, what exactly is the difference between a data analyst and a machine learning engineer? So statistical analysis is just a small part of a machine learning engineer's job, whereas it is a major part, or it probably covers a large part of a data analyst's job rather than a machine learning engineer's job. So machine learning engineers might need to train and retrain the systems whenever necessary, and they also need to extend the existing machine learning libraries and frameworks to their full potential so that they could make the model work superbly. And finally, they need to keep abreast of the developments in the field. Needless to say that any machine learning engineer or any particular individual has to stay updated to the technologies that are coming in the market, and every now and then a new technology arises which will overthrow the older one, so you need to be up to date. Now coming to the resume part of a machine learning engineer, so any resume of a particular machine learning engineer should consist like clear career objective, the skills which a particular individual possesses, the educational qualification, certain certification, the past experience if you are an experienced machine learning engineer, the projects which you have worked on, and that's it. So let's have a look at the various elements that are required in a machine learning engineer's resume. So first of all, you need to have a clear career objective. So here you need not stretch it too much and keep it as precise as possible. So next we have the skills required, and these skills can be technical as well as non-technical. So let's have a look at the various technicals and the non-technical skills out here. So starting with the technical skills, First of all, we have programming languages as in R, Java, Python, and C++. Now, the first and the foremost requirement is to have a good grip on any programming languages, preferably Python, as it is easy to learn and its applications are wider than any other language. Now, it is important to have a good understanding of topics like data structures, memory management, and classes. Although Python is a very good language, it alone cannot help you. So you will probably have to learn all these languages like C++, R, Python, Java, and also work on MapReduce at some point of time. Now, next on our list, we have calculus and linear algebra and statistics. So you'll need to be intimately familiar with matrices, the vectors, and the matrix multiplication. So statistics is going to come up a lot, and at least make sure you're familiar with Gaussian distribution, mean, standard deviations, and much more. So you also need to have a firm understanding of probability and stats to understand the machine learning models. Now next, as I mentioned earlier, it's signal processing techniques. So feature extraction is one of the most important parts of machine learning. Different types of problems need various solutions. So you may be able to utilize the really cool advanced signal processing algorithms such as wavelets, shearlets, curvelets, and the bandlets. So try to learn about the time frequency analysis and try to apply it to your problems, as it gives you an upper edge over other machine learning engineers. So just go for it. Now next we have mathematics, and a lot of machine learning techniques out there are just fancy types of function approximation. Having a firm understanding of algorithm theory and knowing how the algorithm works is really necessary, and understanding subjects like gradient descent, convex optimization, quadratic programming, and partial differentiation will help a lot. The neural networks, as I was talking earlier, so we need machine learning for tasks that are too complex for humans to code directly. So that is the tasks that are so complex that it is impractical. The neural networks are a class of models within the general machine learning literature. They are a specific set of algorithms that have revolutionized machine learning. Deep neural networks have proven to work quite well, and neural networks are themselves general function approximations, which is why they can be applied to almost any machine learning problem out there, and they help a lot about learning a complex mapping from the input to the output space. Now next we have language processing. Since natural language processing combines two of the major areas of work that are linguistic and computer science, and chances are at some point you are going to work with either text or audio or the video. So it's necessary to have a control over libraries like GenSim, NLTK, and techniques like word-to-vec, sentimental analysis, and text summarization. Now, voice and audio analysis involves extracting useful information from the audio signals themselves. Being well versed in maths and concepts like Fourier transformation will get you far in this one. Now, these were the technical skills that are required, but be assured that there are a lot of non-technical skills also that are required to land a good job in a machine learning industry. So, first of all, you need to have an industry knowledge. So, the most successful machine learning projects out there are going to be those that address real pain points. Don't you agree? So, whichever industry you are working for, you should know how that industry works and what will be beneficial for the industry. Now, if a machine learning engineer does not have business acumen and the know-how of the elements that make up a successful business model, all those technical skills cannot be channeled productively. You won't be able to discern the problems and the potential challenges that need solving for the business to sustain and grow. Now, next on our list, we have effective communication, and now this is one of the most important parts in any job requirement. So you'll need to explain machine learning concepts to people with little to no expertise in the field. The chances are you will need to work with a team of engineers as well as many other teams like marketing and the sales team. So communication is going to make all of this much easier. Companies searching for a strong machine learning engineer are looking for someone who can clearly and fluently translate their technical findings to a non-technical team. Now, rapid prototyping is another skill which is very much required for any machine learning engineer. So, iterating on ideas as quickly as possible is mandatory for finding the one that works. In machine learning, this applies to everything, from picking the right model to working on projects such as A/B testing and much more. Now, you need to do a group of techniques used to quickly fabricate a scale model of a physical part, or assembly using the three-dimensional computer-aided design, which is the CAD data. Now, coming to the final skills which will be required for any machine learning engineer is to keep updated. Now you must stay up to date with any upcoming changes. Every month, new neural network models come out that outperform the previous architecture. It also means being aware of the news regarding the development of the tools, theory, and algorithms through research papers, blogs, conference videos, and much more. Now, another part of any machine learning engineer's resume is the educational qualification. So, a bachelor's or a master's degree in computer science or IT, economics, statistics, or even mathematics can help you land a job in machine learning. Plus, if you are an experienced machine learning engineer, so probably some standard company certifications will help you a lot while landing a good job in machine learning. And finally, coming to the professional experience, you need to have experience in computer science, statistics, data analysis. If you are switching from any other profession to a machine learning engineer, or if you have a previous experience in machine learning, that is very well. Now, finally, if we talk about the projects, so you need to have not just any project that you have worked on, you need to have working on machine learning related projects that involve a certain level of AI and working on neural networks to a certain degree to land a good job as a machine learning engineer. Now, if we have a look at the companies hiring machine learning engineers, so every other company is looking for machine learning engineers who can modify their existing model to something that need not need much more of maintenance and can self-sustain. So basically working on artificial intelligence and new algorithms that can work on their own is what every company desires. So Amazon, Facebook, we have tech giants like Microsoft, IBM. Again, in the gaming industry, we have, or the GPU industry, graphics industry, we have NVIDIA. In banking industry, we have JP Morgan Chase. Again, we have LinkedIn, and also we have Walmart. So all of these companies require machine learning engineer at some point of the time. So be assured that if you are looking for a machine learning engineer post, every other companies, be it a big shot company or even the new startups, are looking for machine learning engineers. So be assured you will get a job. Now, with this, we come to an end of this video. So I hope you got a good understanding of who exactly a machine learning engineer is, the wages, job trends, the salary trends, what are the skills required to become a machine learning engineer, and once you become a machine learning engineer, what are the roles and responsibilities, or the job description, what appears to be on the resume, or the job description, what appears to be on the job application of any machine learning engineers. And also, I hope you got to know how to prepare your resume or how to prepare it in a correct format and what all to keep there in the resume, the career objectives, the skills, the technical and non-technical, previous experience, education qualification, and certain projects which are related to it. So that's it, guys. Edureka, as you know, provides a machine learning engineer master's program. Now that is aligned in such a way that will get you acquainted in all the skills that are required to become a machine learning engineer, and that too in the correct format.
As part of the machine learning interview series, I wanted to let you know that over the market right now, there is a lot of openings in the machine learning field. So every company is trying to use machine learning to understand and get gems from their data. They have a data, but they don't know what to do with their data, and they want machine learning engineers to have them understand the data so that their company revenues can be increased. So on top of that, I wanted to also let you know that over the openings, you will see that there are openings for data scientists, machine learning engineers, deep learning engineers, data analysts. Many people are confused with the terms as which one should we choose? Like, should we go with the data scientist? Should we go with the machine learning engineering? But these are all the terms that these companies use to attract some good talent. So this name they just use to attract the talent. But what you should focus is the job description. So what is the job description that they are providing, and are you satisfied with that? So whenever in the interview, try to ask the HR, try to ask the person who's taking the interviews, what will be the role? And based on that, take your decisions. Names are okay, but what you're going to do, try to focus on that. So that is one thing that I wanted to let everyone know, because this is the thing that I see mostly in the internet that people are confused with. Okay, so let's start with the interview questions. So first thing is, this session is divided into three components, so three broad components. So first thing is machine learning core interview questions. So within this core interview questions, we are more interested with the theoretical aspects of the machine learning, like how interview is going to ask you the theoretical questions and you can explain those in an efficient manner. Then second is the technical part where we're going to see the interview questions related to the Python. So how we use the Python in the machine learning field. And last is the scenario based questions. So where the interviewer will be interested to see how you can solve the real world problems using machine learning. So you'll get some scenarios, and based on the scenarios, you have to make your judgments and try to give the answers. So let's start with the core interview questions. First thing, how will you explain machine learning to a school going kid? So in this case, the interviewer is interested to see how you can explain the concepts in machine learning in a very simple manner so that even a school going kid can understand. You can give an example to a kid saying that, okay, your friend has invited you to a party and you meet completely strangers there. So you have not seen them previously, they are just completely strangers to, and you're going to meet them. Since you have no idea about them previously, so you will try to classify them based on the available things that you can visualize. That is like what is the gender, what is the age group, so how are they dressed, how do they behave with you, like what is their attitude. So he will try to classify them based on those features. So this is a pure example of unsupervised learning. So in this case, we don't have any prior knowledge. So in this case, they are completely totally strangers. How is it different from the supervised learning? So in supervised learning, the benefit will be you will have some prior knowledge, and based on that, you will try to go. So you can explain to the kid that as you already got identified to those kids, in future you know their names, so you will try to classify them whenever you see them. So that will be the example of supervised learning. So let's move on to the next thing. What are various types of machine learning? So first of all, you have to say that the machine learning is categorized into majorly three components. First is the supervised learning, second is the unsupervised learning, and third is the reinforcement learning. So in the supervised learning, it is like learning with a teacher. So training data set is like a teacher is giving you like training the machine. So teacher is trying to train based on the whatever teacher knows. So model is like trained on this predefined data which you have, and it start to make decisions based on the, again based on this rule that it has identified from the existing data. It will try to make some predictions and decisions on the new data. You can give some examples as we have here. In this case, when we have apples and bananas, we feed machine apples and bananas with the label saying that, okay, this is the apple, this is how it looks, this is the set of bananas, and this is how they look. So when you feed it to the machine learning supervised algorithm, so what it does is it tries to identify the patterns which are there with each category. So it will say set the rule that, okay, apple looks like this, banana looks like this. So this is the training data that we have provided based on which our supervised learning learns it. And we use this model on the new data set. So for example, in this case, we are using this green apple, and based on the structure which is already there, the green apple is still going to be predicted as an apple based on the shape it has. Okay, so that is the example of supervised learning. Let's move to the next thing, which is unsupervised learning. So in this case, it is like learning without a teacher. So model learns through the observations which are there, and it tries to identify some patterns and structure which will be hidden within the data. So in this case, we are not labeling the data. So model is given a data, and model is left on itself to learn the patterns and relationships out of the data by creating clusters. So clustering is one of the major techniques which are used in the unsupervised learning. There are many, but it is the most popularly used within the unsupervised. So for example, when we feed the apples, bananas, and the mangoes here again, but in this case, we are not labeling them. We are not telling the machine that, okay, these are the apples, these are the bananas. We're just giving it the data, saying, okay, this is what it is. We don't know anything about it. So when we feed it to the algorithm tries to learn the patterns out of it and tries to classify them. It won't say this is apple, this is banana, but it will say, okay, these are similar. So apples are similar, and it'll try to cluster them together. Bananas are similar, it will try to separate them in a different cluster. And mangoes are similar, it will try to cluster them in a separate cluster. So it will try to understand the patterns which are there within the data and give you the clusters out of it. So that is the unsupervised learning. Third part is reinforcement learning. So in this case, model learns with hit and trial method. So assume that we are playing the Mario game, and in the Mario game, the player is called as the agent in the reinforcement learning. we have an environment which is nothing but a game. There will be some predefined actions which agent can take. For example, in the game of Mario, it will be he can move forward, he can jump, he can go into the tunnels, he can fire the bombs. So those are the steps. And based on the steps, your environment will try to reward you. Either it will reward you or it will penalize you. Based on that, your model will get created, which will say, okay, these are the best actions, where when you do these actions, you will get your score more, which is like a reward. And when you don't, you do this kind of action, your score will get penalized. So based on this environment, your reinforcement learning will try to learn those things. So that is one example, and you can also give some examples related to the AlphaGo, which is a Go playing game which recently was developed by a Google-based company. And you can also say that chess-based games can be automated with the reinforcement learning. So there is one more category within machine learning which is not much talked about, which is the semi-supervised algorithm. So which are basically combination of supervised plus unsupervised. So in this case, what happens is you have a data set which is half of it is labeled and half of it is not labeled. So in this case, both supervised plus semi-supervised are used to create your models. So you can also give this so that it will be more confident on you. Okay, so let's move on to the next thing. What's your favorite algorithm and can you explain it in a minute? In this case, interview is trying to understand as how you can explain some complicated techniques and technologies in a very simple and simplistic manner to some higher up people or the clients or those kind of things. So make sure you have some choice and you can explain different algorithms in a simple manner. You keep for every example, try to keep some simple examples so that you can effectively and you can easily explain it so that even a small kid can understand as how you're explaining those things. So how deep learning is different from machine learning? In this case, first thing is you have to know that deep learning is not completely different from machine learning. You have to say that okay, deep learning is a small part of machine learning, and in the core machine learning, based on the input, first you have to do the feature extractions. You have to classify the features which are the good, which are trying to explain your model better based on some exploratory data analysis, and based on that you will feed it to the algorithms, and those algorithms will try to identify the patterns within those and give you the output. In deep learning, it is a bit simplified. What happens is based on the input, the model will try to extract the features on itself and will try to create a model based on those. So it is trying to combine both the things of feature extraction and classification into a single thing, and it will give you the output. So that's why it is recently being very popular. So that is one thing. And deep learning is basically, if you know, the deep learning is constructed most of the neural networks. So and neural networks are basically borrowed from the idea of the human brain. So how the human brain works and how the neurons within the brain really works in a very complicated and effective manner. So those are the things which have been taken and being implemented in the deep learning. And machine learning is about the algorithms that basically parses and learns the data and tries to identify the patterns within the data, apply whatever pattern learned from the data to the new data whichever is coming. So that is the most of the thing which was related with the machine learning, but deep learning has come a bit more advanced to it. Okay, so explain classification and regression. So classification and regression is part of supervised learning. So you have to say this first, that this is part of the supervised learning. Supervised learning is broadly categorized into these two parts, and regression is mostly dealing with the continuous variable. So in continuous variable, it's like you're trying to predict the sales, you're trying to predict the stock market values. So wherever there are continuous predictions, you're trying to do the regression of your data. So classification is like you're trying to predict the different classes which are there within the data. So for example, the classes could be like, is the student going to pass or not? Is my customer going to buy my product or not? And is my salary is within like high, medium, low? So those are the different classes. And when we're dealing with the classes, we say it is classification. And we're dealing with the continuous values, we say it is regression. So in this case, if you see, the regression is like size of your house, area, and the location which are there. And classification is like when you're trying to give it a classes. So very cheap, affordable. So you're creating a 5 classes here, and that becomes the classification. What do you understand by selection bias? In the statistical term, sampling is basically trying to sample some data from your population. So you are trying to take some portion of the data from the population, and when you have some bias to some specific set of data. So let's assume we want to take a population of all the data scientists within India. When you're talking about India, you have to take data from all parts of India. But let's assume you just take the sample from the Gurgaon. So when you just take the sample from the Gurgaon, you're getting a selection bias. You're getting bias to the Gurgaon and you're just selecting the data from there. So in this case, you're getting bias to those conclusions of your inaccurate conclusions of yours, and you're not making the accurate decisions based for the population. Okay, so that is the selection bias. So what do you understand by precision and recall? So in this case, let's go on with the example. So let's imagine that your girlfriend keep on giving you surprises from last 10 years of your birthdays, and one sudden day she comes to you and asks you, do you remember all birthday surprises from me? And you just get shocked. And in this case, to extend your life, what you do is you try to recall all the 10 surprising events that you had in your previous birthdays, and this recall that you're doing is nothing but the number of events you actually correctly trying to recall it and the actual events which have happened. So this is the ratio that you're trying to capture of all the recalls that you're doing correctly and the number of the correct events which happened. So for example, if you are trying to recall out of 10 all the 10 correctly, then your recall ratio is nothing but 1. So which is again 100%. But if you're trying to recall only 7 events correctly, so as per the ratio, what will happen is the number of events you can correctly recall is 7, and the total number of events which are there is 10. So in this case, your ratio will be 0.7, which will be 70%. But let's assume you might be wrong in some answers. So for example, you answered you remember 15 times, but out of this only 10 were correct and 5 events were actually wrong. So you remembered from some another events. So in this case, so you recall all the events which are there, but it's not completely precise. So in this case, the precision is the ratio that the number of events you are recalling correctly to the number of events you recall. So which is like out of 15, you're trying to recall the 10 as a correctly. So that is the precision which we have. So 10 real events and 15 answers. So the ratio is the 66% in this case, which is 10 divided by 15. Okay. In the formulas, you can represent all those things in a simple formula. So number of events you can correctly recall are called as the true positive. So which you said as true, you said as a positive, you are able to recall them correctly and they're actually there. So number of all correct events. So this is also again the true positive which you recall correctly plus the false negative which you didn't recall. Okay, and the next thing is the number of events you recall. So which is true positives plus the false positives. In this case, what's happening is the correct recall that you did, all the events that you correctly remembered, and some which are not correct. So you said, okay, I recall them. So for example, when we had it 15, so in that case, there were some like 10 were correct and 5 were the false positive, which was you didn't recall them correctly. So based on all this above, recall is true positive divided by true positive plus false negative. So true positive plus false negative is nothing but the number of correct events, as we already saw that. So number of events you can correctly recall divided by number of correct events. And precision is true positive divided by true positive plus false positive, which is the number of events you can correctly recall divided by number of all events you recall. Okay. So the next question is explain false negative, false positive, true negative, and true positive with a simple example. So previously we just saw the example where we had an example of the birthday surprises. So you can also go with the example where it will be more realistic as it will give some impact to it. So for example, the true positive. So in this case, we can take some real example where what the model that we are trying to build, what it does is based on the fire is there or not, it will try to raise an alarm. So in the first case, it's true positive. So in true positive, what will happen is you said you have to do the alarm and there is actually a fire. So there is actual fire and you try to do it. It is the right condition. So that is the true positive. Second is the false positive. In this case, you raise an alarm, but there is no fire. So in this case, what will happen when you raise the alarm? There is no fire, but still people are running. So that is not a good thing, and that is called the false positive. Third example is false negative. So false negative, if you're not raising an alarm even when there is a fire. This is the worst condition that we have in all the situations. So your aim is to raise an alarm when there is actual fire. But this condition says when there is still a fire, you're not raising any alarm. So this is the most harmful thing which can be there and where your model is not working. So you have to be very careful with this thing one. And true negative is something where there is no fire and you have not raised any alarm, which is still good. Okay. What is confusion matrix? So to explain this confusion matrix to your interview, you can take some simple examples such as you want to create a model where what you are trying to look is you have a bank and that bank wants to identify who are the customers I should be giving loan to so that they won't default me. So I have a training data where I know that okay, these are the customers who were good, who didn't default, and these are the customers to whom I gave loan but they defaulted. So that data is used in making these predictions, and you have a model which has done this also. So assume that we have 165 people in the training set, and after doing the prediction, so in the training set, what we have got is in actual 105 people can be given loan who didn't defaulted, and 60 people who bank gave loan they defaulted. So what your model is predicting in this case is it says 110 people can be given loan who will not default and 55 people can be rejected so as they are going to default. But this is on a higher level. But when you look at a confusion matrix, what will happen is you will try to see, okay, how my model is performing and where are the true positives, true negatives, and how should I take care? Not take care, but how is it performing at the part of the false positive and the false negative. So assume we have a true positive. So in actual, there are 105 people who the bank's training data says can be given loan who didn't default, but out of that model has identified 100 people, so which is a good thing. And for the no case, for the rejection case, out of 60 people the model says 50, which is again a good thing. But your model says for 10 people who are actually defaulters, but model says you should give them loan. So those are the things which can be looked into the future, but confusion matrix will help you to understand how your model is performing based on the predicted the model output and the actual data which you have. So what is the difference between inductive and deductive learning? So to help this concept, you can give some good examples such as a father want to explain his son how the fire can burn him. So there are two ways that he can teach his kid as how he can get impacted from the fire. So first thing is he will show him some examples, like he will show him some videos or he will show some demo as how the fire will get him burned. So based on the observations, the kid will learn and make some conclusions out of it. So that is the example for inductive learning where he will do the observation and see how the things are going to be and make some conclusions out of it. And for the deductive learning, it is like father is letting the kid play with the fire. So the father will wait till kid will get burned and try to make some conclusions out of it and have the observations after it. Like he will get himself burned and then he will say that okay, fire makes us burn. So that is the deductive learning where what happens is first you will make some conclusions and then you draw the observations. Similarly, in the field of machine learning, it is like out of the data you will try to do some observations and these observations are stored as a model, which is like you have observed all the things and kept it as a model. And the deductive learning is like you are giving it a data and based on the previous inductive learning that it has already done, it will try to deduce the output of it. So how is KNN different from K-means clustering? One important thing happens is people are really confused with what is KNN. Sometimes like is KNN clustering or is K-means a clustering? In this question, the clustering is given to you as K means clustering, but sometimes the interview will just ask you how is KNN different from K means. First thing you have to do is you have to understand the difference, as K means is a unsupervised technique algorithm and KNN is a supervised technique. In KNN is used as a supervised algorithm, KNN is used for classification and regression, and K means is used for clustering. As it's a clustering algorithm, it is used to create the clusters of your data. K within KNN basically means it tries to observe the K neighbors. So in the case of regression, it will try to identify the surrounding K neighbors and take the average and give you the output. And in the case of classification, what it will do is it will try to see the surrounding neighbors, K neighbors, and whatever the majority of the class is there, it will assign the class to that. So in this case, K is your neighbors based on which your regression and classification will be done. In the case of K means, it is the K clusters that you're going to create out of your data. So K in the both cases is different, and you have to give this differences to the interviewer. So one thing is, once you know that okay, K means is an unsupervised and KNN is a supervised, you can further go on top of that. Okay. Can you explain me what is ROC curve and what does it represent? So in this case, interviewer is interested to know how good you understand the ROC curve and how you can use it to understand your model's output. So interviewer is very much interested as how you are trying to use this in your model performance. So as ROC is also one of the performance parameters for your model, and this is used in the cases of binary classification. The full form for the ROC is Receiver Operating Characteristics Curve, and its fundamental use started with the diagnostic test evaluations. So in the medical field, its application started and it is used in the machine learning field to do the classification related algorithms performance evaluation. So in simplistic term, it is the plot of true positive rates, which is also called as the sensitivity, against the false positive rate. So what happens is once you get the output in the probabilities, you can use the different cutoffs, and you can use the cutoffs to distinguish as what is going to be the true cases and what is going to go for a false cases. And you can plot the ROC curve, and ROC curve says when your curve is having 1, your model is good. And the plot with the 50% like 0.5, which is nothing but this blue line, which is the worst case. It's like your model is saying you have a 50% chance in the prediction. It's just saying it's just a normal guessing work. So you're either guessing 1 or 2 with a 50% probability. The more closer to this and more area this curve is trying to cover, the better is the algorithm. So better you're trying to predict the true positive rates than the false negative rates. Your true positive rates should increase faster than the false positive rates in this case. So first we saw like what actually ROC curve does, and we will see like how you can interpret it now. So you can give the interviewer some idea about what is really ROC curve, give some details about it, and you can give the technical details like how you can interpret it. So first of all, it is like trade-off. There is always a trade-off between sensitivity and specificity, and one will increase in one will create a decrease in another. So it is really important with the ROC curve. You will see these differences as how they are getting impacted. The closer the curve follows to the true positive rate line and the more area it covers, such as the yellow one, as it is covering the highest area, that is more better than the pink one. And pink one is more better than the blue one. The blue one is, as we already said, is like just a random guessing with a 50% of probability. And the slope of the tangent line at the cut points gives you the likelihood ratio as how likelihood your model is. What's the difference between type 1 and type 2 error? So this is one of the very important concepts which you interviewers trying to understand as how you try to distinguish between the type of errors, or do you understand as how this type 1 and type 2 errors are impacting the performance of your model. So interviewers trying to understand those things, so you can give some good examples to say how these are going to impact. So first thing is type 1 error is false positives. So when something is not true, which in actuality is not true, but your model is saying it is true. So as we have the example, if a doctor says to a male person that he's pregnant, so it is like something is not true, but you are saying it as true. So which is the false positive and is an example for the type 1 error. And the type 2 is a false negative. So when something you are saying is not there, but in actuality it is there. So when you're saying negative, so you are saying it is not there, but in actuality it is false. So that is the false positive. Similar example comes to where female is pregnant and the doctor says she is not pregnant. So this is like your model says something is not true, which is in the negative case, but in reality it is there. Is it better to have too many false positives or too many false negatives? This case really depends on the domain and the type of problem that you're solving. So based on the different problems and the different business requirements, you have to decide on what to have. So there is always a trade-off. You have to maintain the trade-off between these false positives and false negatives, and you have to decide which one we can keep as a more. As we already saw in the previous case, where you can imagine that where a doctor says a male person that he is a pregnant person. So these kind of model is always going to be a problem, and you have to decide like how many of these cases you can manage. So is it like out of 100, can you say that you can manage 10 false positives, or how many you can consider for those, and you can move on with the model. So similarly, there is example wherein the spam filtering. So can you say a good mail as a spam or not? So that trade-off you have to manage, and based on that it will go. So this you have to define beforehand which one you can go on with, and you have to create a model as per that. So these kind of questions are mostly related with the domain specific questions. So you cannot just select any one of it and just give example. So beforehand, just try to understand what domain you're trying to explain. And before that, try to first be clear with what is false positives and what is false negatives. After that, select some specific domains and give the examples. So for example, in the medical testing, negatives may provide a false reassuring messages to the patients and physicians that some disease is absent, but you are actually saying it is present. So what will happen in this case is you are trying to give inadequate treatments to both the patients and the disease, which is not required. And these things will cost patients to the medical and the medical agencies, and these kind of things has to be managed. So it is desirable to have many false positives in this case. The other example could be the spam filtering. So in this case, a false positive occurs when spam filtering is blocking or wrongly classifying the legitimate emails. So you can't have that as many times. So users will get irritated when your actual mails are getting into the spam. So in this case, we prefer to many false negatives over the many false positives. So based on the domain, it differs, and you have to give the example specific to those domains. Okay. So which is more important to you, the model accuracy or the model performance? This question the interviewer is trying to understand how better you know these terms. So do you really know the differences between these terms? So first thing, try to understand what these terms are. In actually, the model accuracy is part of model performance. It is subset of the model performance. There are different model performance measures, and model accuracy is one of them. So for example, let's consider the case of fraud detection. So in this case, what will happen is you will have millions of rows, and within those only very less percentage of rows will have actual frauds. So in those cases, if you look for the model accuracy, your model accuracy will mostly be higher, and it won't give you a complete picture of your model performance. So model accuracy is just a subset of the model performance, and there are more metrics that you have to look to understand the model performance. Next question is, what is the difference between Gini impurity and entropy in decision tree? So both, first thing, both the things are used as a impurity measure in decision tree. What do we mean by impurity measure? So first you have to tell the interviewer what is really impurity in the decision tree. So impurity is something as how disclassified your classes are within the tree. As when you make a splits, how your classes are getting split. So Gini is one thing where what it does is it tries to see as when you pick a random sample out of the different labels, what is the chance of it getting picked. It tries to add those probabilities and create an impurity. So it is basically 1 minus those probabilities. The lesser it is, you're more confident that your labels are getting clustered in a different groups and different nodes. Entropy is a measurement of lack of information. So when you're making a split within your data, it tries to identify as how disorganized this data is. Basically, both are trying to do a similar thing, but they are just doing it in a different manner with different mathematics. What happens is, performance-wise, they both are same, but mostly people would go with Gini as it is less computationally overheading, as entropy uses a log function within the calculations, and that is a bit computationally expensive. So, using Gini, it can be reduced, so mostly people would go with the Gini. So what is difference between entropy and information gain? So when we're trying to make a split within the data, entropy is an indicator like how messy is your data within the nodes which you have. So as you keep on splitting the data based on the different features, you have the nodes and within those you have the labels. And entropy is giving you the measure as how disclassified those are within your nodes. Information gain is something which says how better you are achieving the goal of separating your labels into different nodes. So as your entropy keeps on decreasing, your information gain keeps on increasing. So both are related with each other, and as your entropy is decreasing, your information gain will keep on increasing. Your information gain will keep on increasing as your nodes are getting pure and pure. So node purity basically says as you're getting specific classes within the nodes, those nodes are getting purer. So when we are trying to take specific classes, like our classes are getting segregated based on the tree and the nodes are getting purer and purer. So information gain will keep on increasing as we are moving toward the leaf nodes and the nodes are getting purer, and our entropy will keep on decreasing as we are reaching closer to the leaf nodes. What is overfitting and how do you ensure you are not overfitting with a model? So overfitting is really important concept within the modeling performance, and your interviewer is really interested to understand as how you are confident with those terms and how you can explain those, so that once you explain those things, interviewer is interested to see as you know the machine learning models in the right terms or not. So once you do the fitting of your model, there could be three different ways that your model is getting fitted. So first is the case of underfitting. In underfitting, what is happening is your model is not learning completely what is there within the data. It is biased to a specific set of data and it is not learning the patterns which are there within the data. So when new data comes in, it won't be able to classify it properly or regress it properly. Balanced is a balanced condition where what's happening is your model is learning the patterns within the data in a very generalized manner. What do you mean by generalized is your model is learning it on the training data, plus when you give it a new testing data, it is still able to generalize it what was there in the training data. Overfitting is something which is like very much closely getting fitted with the data which is there within the training set. So it is getting very much closer. It's creating a curve as you see in the diagram, very much closer to the data which is there within the training. So when you give it a new testing data, it won't generalize it very well. So you have to be sure in overfitting, it's trying to create a model which is very much learning all the parameters in an exact manner from the training data, which shouldn't be the case. The next part is how do we ensure our model is not overfitting. So for this, there are multiple ways that we can control the overfitting. First is we collect more data. So as we have lesser data, our model will try to get very much exact to what is there within the training data. Getting more data may help it to generalize well. Second is using ensemble methods that average the models. So when we split our data into multiple components or we use multiple models which will try to understand data in a different manner, each model within ensemble will try to understand the data in a different manner. They'll try to capture the different patterns, and when you try to average those, your overfitting will reduce a bit. Choosing simpler models. So simpler models are like logistic regressions where you understand what is happening. In logistic regression, you will get a parameters as how the coefficients are there with each of your features. So you can try to understand what is really happening and try to make some tweaking to the model with the simpler models. Few more thing is you can try to add regularization. So there are regularizations called L1 and L2, which basically penalizes your model when it tries to overfit or underfit. It tries to balance your data and it doesn't let it overfit or underfit. You can set the boundaries as how stricter you want to be with the regularization. So that is the fourth step. Explain ensemble learning technique in machine learning. So first of all, you have to explain. So interviewer is interested to see how you can explain the theoretical part of it plus the practical part of it. First, as a theory, ensemble is nothing but different models combined together, and each model is trying to understand the data in a different manner. So each model will try to capture different patterns within the data. All are weak learners. So in this case, they are called all are weak learners, and when we combine them together, they become a better model. A single model is created out of it, which is a better predictor model. So if you see the example which is there below, it is like we are feeding a different set of data and we are creating different models. So these are the different models which are creating out of the different samples of our data. And this all models are combined into a single model. And based on the new data, output of all these models are combined together and your single output is created by merging all the outputs of different models. So in the case of regression, it is mostly like you try to average those values and create a new value. In the case of classification, you try to take the majority of all those. So ensemble learning is basically learning from committee or crowd. So you basically train a large number of models and then try to combine their predictions and create a single conclusion out of it. So for example, when we split our data set into different samples and those each sample is fed into a similar kind of algorithm. For example, the decision trees. So we create 100 decision trees on 100 samples of our data and each model is trying to capture different patterns of your data. In the end, we try to average all the outputs of these 100 models and we take a single output. So the ensemble models power is very different and they are very popularly used to control the overfitting of your models. So there are two components. There are two types which are there in the ensemble model. One is the bagging and the other is the boosting. So you can just give the theory about like how both of them works. So boosting is something where what we are doing is we are trying to sample the data. Different samples are trained on similar kind of algorithms such as the decision trees, the logistic regression, or the SVM. On all samples, a single algorithm is used. And at the end, you combine all the outputs of these models, and that is the output of the bagging. And boosting is the algorithm where what happens is your each model is trying to understand the misclassifications which are there within the previous model and try to learn those. So each model, the next model will try to learn the misclassifications which are there within the previous model and become better and better. And again, the combined output of all this is taken to create an ensemble of it and use it. Yeah. So this example is similar to a bagging algorithm where what is happening is we have a different samples of data and we are using a model. So let's assume we are using a decision tree in this case. So we are training decision trees on each of these models and in the end, output of these models are being fed to a whole ensemble and ensemble model. It will try to aggregate all the responses from these models and give a single output. So as a single learner can't do, this whole together would do. So that is the power of ensembles as each one is trying to learn different parts of it and give you a single output which is more powerful than the single algorithm. So what is bagging and boosting in machine learning? Both bagging and boosting are nothing but the types within the ensemble models. And as we know, ensemble models are nothing but collection of different models. They are also called as the weak learners. And we combine all these weak learners output to create a single learner, which is a better predictor of your than the all weak learners. So both generate data from the sample. So you take a random samples out of your data. It is mostly with the replacement as you take a data and you again replace it and you again take a different sample of it. So it's called the random sampling of your data. So in both the cases, all the weak learners are aggregated to create the final output. So in the case of classification, you try to take the class which is coming as the highest. If you're training 100 models, and you have a binary classification. Assume that out of 100 models, if 80 models are predicting that your class 1 should be there and 20 models are predicting your class 2 should be there, then in ensemble class 1 would be selected as the output. In the case of regression, it is like you're trying to average all the outputs. As it's a continuous data, you try to aggregate all the output from the different models. So both are good at reducing the variance. So as both are good at reducing the variance, as they are trying to learn different models, they reduce the overfitting of your data, and in effect, they also reduce the variance which is available within the model. So as part of the differences, boosting what it does is it tries to learn different weak learners. Is different samples are created and each sample is trained on a similar model. So for example, if we are using decision tree, on all sample we use decision tree and each one predicts their performance. Whereas in boosting, what it does is it tries to learn from the mistakes that the previous model has performed. Each model is a better version of the previous model. So boosting tries to weight the misclassified classes which were there in the previous model. And so as it keeps on moving, it tries to change their weight and create a new model so that the new model will give more weightage to the ones which were misclassified in the previous model. So with this, it keeps on improving itself. Bagging gives equal weightage to each model's output while creating ensemble output of your model. Whereas boosting gives a different weightage to each model. As each model is an improved version of the previous one, they have a different weightage. And the data weights are also changed as within the each bagging model. So your weightage is also changed while you are aggregating the output of your boosting data. So as an ensemble model, both bagging and boosting helps you to solve the problem of overfitting and in effect helping to reduce the variance. Boosting tries to also reduce your bias, which is nothing but underfitting. As you keep on learning from the previous mistakes, you are getting better and better with the instances which are not much good, which is the bias. How do you screen for outliers and what should you do if you find one? In this case, your interviewer is interested to know as how you give importance to the outliers, how you understand them, and when you find them, how you are trying to improve your models with the outliers, how you take your decisions once you know you get the outliers. So first thing, you screen the outliers using different ways. So some of the ways are, one is the box plot. So box plot really helps you to understand when you plot the data, you see that box plot uses an formula of IQR, which is interquartile range, multiplied by 1.5 plus your third quartile minus your first quartile. This 1.5 multiplied by IQR is added to the third quartile to create the outliers on the top, and from the first quartile it is subtracted to create the outliers in the bottom line. So that is one way to screen the outliers using box plots. Second is the probabilistic and statistical model. So using the properties of different distribution models, such as the normal distribution, the exponential distribution, the way your data follows it, you can see if your model is following those distributions or not. And the cases where it is following very outside boundaries of your distribution, you can treat them as the outliers. Third is the linear models. So with the linear models, you can try to see as, for example, in the time series linear model. So when in the time series linear model, when you're learning the data, whenever a new outlier comes in, you will try to screen those. For the linear models, such as the logistic regression, you can try to flag them pre-hand as, okay, these are the outliers, flag them as 1. These are the non-outliers, flag them as 0. And your model will try to learn which are the outliers and which are not. And in future, you can use those models to screen your outliers within the data. And the last is the proximity based models. So proximity based models is like k-means clustering. So you use the k-means clustering to create a clusters within your data, and the ones who fall outside of your clusters or outliers will form themselves their own cluster, and you will see that you will have your classified versions of your outliers. So that is with the proximity based models. How do you handle these outliers? You have to take a decision very carefully in this case as how important are these outliers to your data. And When you have a very high data and you can risk dropping those outliers, then you can go on with that, or you can cap your data using the percentile. So mostly what people do is they use the 99 percentile or 95 percentile. So whatever the values are above those percentiles, your outliers are capped to those. So your outliers will get reduced. The last option is impute based on some rules. So based on some business rules or the data exploration that you do, using those, you can impute your outliers so that you can go on with the model creation. What is collinearity and multicollinearity? So this is one really interesting thing as what happens in this cases. So collinearity occurs when you're trying to do a regression on a multi-features and you see that your two of the predictors are correlated with each other. For example, let's assume you have a date of birth and the age. So when you have both of this, your date of birth and age is always going to be correlated with each other. So in those cases, these two features are part of collinearity within the regression. Multicollinearity is something which occurs when you have more than two variables which are correlated with each other. So we can extend the previous example, which is we have the age, we have the year on which he was born on, and the class that he is on currently. So for example, if he is on fifth class, he is on seventh class. So those are also going to be correlated with each other. So in this case, we have three predictors which are correlated with each other. So what do you understand by eigenvectors and eigenvalues? So let's just see a bit of example to understand what is really happening in this. So in the left case, if you see, we have a square matrix which is being multiplied by a non-zero column matrix equal to again some a non-zero vector. And on the right side, if you see, we are getting an equation where our original square matrix is being replaced with 3 and we are still having the column vector. So we are able to represent the whole thing which is there on the left side to the right side by replacing the scalar. So the scalar in this case is called as the eigenvalue in the original vector, and the multiplication that we are doing, the second vector is called as the eigenvector. So let's see the mathematical definition for this. If you see this equation, ax is equal to lambda x. So in this case, eigenvector of your square matrix A is a non-zero vector x such that for some number lambda we have this equation. So in this case we have this square matrix A multiplied by our eigenvector gives us a lambda multiplied by eigenvector. So we are getting a scaled down version of the scalar square matrix as a scalar and which have its own applications. So for example, how is this thing used? So a few of these use cases are eigenvectors are used to understand the linear transformations which is there within your original square matrix. So in data analysis, we visually calculate the eigenvectors for the correlation and covariance matrix of the original data. So whenever we have any data, we can calculate the correlation matrices, covariance matrices, and we can calculate their eigenvectors from those matrices. What this basically gives you is how much of your transformations are there and within the data, and these eigenvectors calculated from these correlation matrices can be used in the further algorithms called the PCA and the factor analysis. And these algorithms really helps you to reduce the dimensions which is there within your data. So that is from the point of data analysis. The other applications are eigenvectors are the directions along which a particular linear transformation acts. So when you apply some linear transformation, this eigenvectors are actually giving you like in which direction those transformations are being applied. So this is like when you apply those transformation, what is the direction which is being there. It can also be used to do the compressions within the data. So eigenvalues and eigenvectors are also used in the image field where images can be compressed using those values. What is A/B testing? So A/B testing is a statistical hypothesis testing which tries to compare different cases. So in our cases, we want to measure how different model performs as compared to each other. So assume that in production, you have a model which is already running and tries to see how your users are clicking through your products and they're buying those products. So your model basically predicts some recommendations of the products and captures like how what is the ratio that once you recommend them and they buy it, you introduce another model into the system which is just limited to few users, and which also does is it recommends few products and captures how many of them are actually buying those products. And using some hypothesis testing such as the t-test, ANOVA test, and different tests, A/B testing tries to identify which model is better, which is trying to give you a better output in a comparison. So you can give the examples to the interviewer as in the cases where we want to identify when a user clicks on the pages to increase the outcome of the interest. So some websites, what they do, they try to introduce different functionalities to different users and see how different functionalities are creating a better outcome and better revenues. And they use those things in the future. So what is cluster sampling? So when you have a population and within a population, you have different clusters available. So for example, the previous example that we saw when we want to find out salaries of all the data scientists within India. So we have different clusters like we have a cluster of Gurgaon, we have a cluster of Bangalore, we have a cluster of Mumbai, Pune, Hyderabad. So these are the different clusters which we have within which there are different data scientists. When we try to randomly select those clusters for our analysis, that is called as the cluster sampling. So in this case, the sample is nothing but different clusters and we are trying to select those samples. So for example, if managers are your samples, then companies are basically clusters and we do the clustering of these different companies. When we select random clusters of these companies, that is called as the cluster sampling. So running a binary classification tree algorithm is quite easy. But do you know how does the tree decide on which variable to split at the root node and its succeeding child node? So you can explain the things we have discussed already about the Gini and the entropy parameters. So what Gini does is it calculates for subnodes what is the probability and success for each classes, and that is done by it squares the probabilities of success like p square with the q square, which is the probability of success for each class and the probability of failure for other class. Once these probabilities are calculated, your weighted Gini score is calculated for each node. So whenever you have a lesser Gini score, you go with that feature for the splitting of your nodes. So entropy is the measure of impurity or randomness within your data. It's like how misclassified your classes are within the nodes. So it's for the binary classification. When you have the binary classification, we have the probability of success, we have the probability of failure. So for the positive class, we have the probability of success, and the other one, we have the probability of failure. So we use the entropy formula to calculate which one to split. So for whichever variable we have the lesser entropy, we go with the split of that node. So entropy is basically zero when a node is homogeneous. So when everything is within a single node and your node is completely pure, your entropy becomes zero, where a node completely contains a single class. When a node contains a 50-50% of your classes, your class 1 is like if it is 100 rows and 50 of them are class 1, 50 of them are class 2. At that point, your entropy value is highest. So the maximum value it will take when you have both the classes in an equal number within the nodes. The final agenda is to lower the Gini or the entropy. For whichever feature we have the lower value, go with the split of those for the current parent node. So now we are done with the core machine learning, so which were mostly related to the theoretical aspects of the machine learning. Now we will start with the Python related questions with the machine learning. As machine learning can be done with different languages like R, Python, SAS, but currently we are more focusing on the Python, and we will start with our practical questions which are there with the machine learning. So first question is name a few libraries in Python used for data analysis and scientific computations. In this case, interview is trying to understand. So in the initial level, he will try to ask you these questions to gauge you if you really know about the core libraries which are used for the data analysis in the Python or not. So the core libraries which are there within Python are NumPy, SciPy, Pandas, and Scikit. So first of all, NumPy. NumPy is a numerical library to deal with the data. So as the name suggests, it's a numerical pie. So it tries to deal with the numbers. So all the core libraries such as the SciPy, Pandas, Scikit uses NumPy to store the data. So those are the core storage format for all the data in data analysis. So SciPy, its full form is basically scientific Python. So it basically gives you a library to deal with all the different kind of mathematical functions. So you can do Fourier transforms for the audio related data. You can go with the optimizations. You can go with the interpolation. So these are just a few examples, but all the mathematical related tasks you can go with the SciPy, and SciPy uses, as we already discussed, in a core NumPy to store the data. So Pandas is a data analysis library again where you can store the data in a tabular manner, which is called as a data frames, and data frames are very powerful function within Pandas. So data frames gives you a data manipulation access. You can access the CSVs, you can load the databases, you can load the Excel files, and you can do your operations on top of it. You can do the aggregations, merging, and all those kind of analysis related to the data you can do with the Pandas. Scikit is purely a machine learning library. What it gives you is access to the different machine learning models you can use. So it contains a different components. It contains a pre-processing component where you can do the pre-processing of your data. It provides a library for that, and it also provides you a different modeling library where you can access all the core machine learning models. So on top of that, we have Matplotlib, which is a purely a data visualization tool. So with the Matplotlib, you can visualize your data in a very efficient manner and in a faster manner. And Seaborn is something which is built on top of Matplotlib and gives you a more better visualization of the data and gives you different new kinds of visualizations which are not there within the Matplotlib. So you just can give this detail to the interviewer, just list them all and give a bit of the description about each of them. So that would be enough in this case. Which library would you prefer for plotting in Python language? Seaborn or Matplotlib or Bouquet? So all these three have their own applications. So preference is something that would come based on the thing that you are currently performing with the data analysis stage. So for example, when you're doing a quick analysis within your data, so you want to have a quick access to the charts, then you can use the Matplotlib. For example, Matplotlib provides you a quick access to the bar charts, pie charts, histogram, line charts, scatter plot. So for the quick analysis and your data exploration, you can go with the Matplotlib. Seaborn is something which is built on top of the Matplotlib. And you can use this when you want to do a bit in-depth analysis of your data. For example, when you want to have a statistical analysis within the data, and Seaborn gives you a bit more types of graphs which are not there within the Matplotlib. So for example, when you want to have a distribution charts with a more detail, so Seaborn provides you charts such as the violin plots, it gives you a KD plots. So for the detailed explanation of your data, you can go with the Seaborn. Bouquet is something which is an interactive visualization. Bouquet you go when you want to present your data to something of the outside world, when you want to publish it on a web and you want your user to interact with the data, then you use Bouquet. So when you go to the outside and you want to publish your visualization to the outside public, you use Bouquet for that purpose. So how are NumPy and SciPy related to each other? So this thing you can give a bit of detail as what is really NumPy first and what is really SciPy. And the thing is SciPy is a bigger library and NumPy is part of it. So NumPy is a smaller part of SciPy. NumPy helps you to define arrays and you can perform some operations on top of those arrays using the NumPy libraries. So different types of operations are like indexing, sorting. You can change the shape of it. You can change the matrices. You can create a splits within your data. You can merge different arrays together. So NumPy will help you with all those. SciPy, you can go to a next level when you using on top of those NumPy arrays when you want to create some mathematical formulation. You can go with the SciPy. So when you want to do the optimization, you want to do the Fourier transform. If you have audio data for those kind of applications, you can go with the SciPy. So what is the main difference between a Panda series and a single column data frame in Python? So interviewer, he would like to really understand if you know the core concepts within the Python or not. And Pandas is something which is the core of the data analysis, as all your data is stored within Pandas and you're dealing with Pandas most of the time. So in this case, interviewer will try to gauge you as you know the basic terms which are there within the Pandas or not. So first thing, data frame is something which can store multiple columns, but a series cannot store multiple columns. So series is just a single column But with the data frame, even if it's a single column, you can go with the multiple columns, you can add the columns to it. And there are some limited functions which are there with the series, and data frame has additional functions on top of series. So for example, LOC is a function which is there on top of this. So data frame is the upper level layer on top of series and gives you more control to the data. But the basic difference is with the series, you just have a single column, but with the data frame, you still can add more columns to the data. How can you handle duplicate values in data set for a variable in Python? So in this case, you may have to write a code and show to the interviewer that how you can really achieve this thing. So you can just import the pandas library, show that you're just reading a random file using the pd.read_csv, and you use the build data frame.duplicated to get the list of all the duplicate values which are there within the data, and just show that you can also drop those columns if sometimes we want to drop those. They are by some mistake created by the collector. So the duplicate values can be removed using the drop_duplicate columns. So these two functions you can try to show and explain them what they do. That would help you in that. Write a basic machine learning program to check the accuracy of the data set, importing any data set using any classifier. So in this case, you're not limited with what data set you're loading, what data classifier. The important thing which you have to show is how you are loading your performance parameters, and things that the interviewer will gauge is how you are trying to use the performance metrics. Are you trying to use it on the test set or the training set? Or you're trying to use it on the trained data or just the test data? So you have to be very sure, as you don't have the computer to do the output, you just want to write it. So you have to be sure that you are using a test set to show the accuracy parameter, and you have to use both training y and test y in this case. So you have to start with the complete program. You have to show all the steps which are involved within the accuracy part. So you have to start importing your data. Just take some random data. You can just show that you are reading some data and try to separate your data into the X and Y, the target data and the predictor data, and try to create a split within the data of train and test validations. You can use whatever ratio you want to use. You can use 80%, 70%, 50% as you like, but you need to give some justification to that also if your interviewer asks for it. Once we have split our data into train and test set, the next task is to use the classifiers to train the data and create a model out of it. So you can use any classifiers here, but choose something which you already know better, because interviewer will ask you whatever model you're going to use in the next step. So you have to be sure whatever you're using, you know it better. So once you have created an instance, you can use it to fit it on the training data. So use the X train data and the Y train data, create a model. Once you have done that, you use it to make predictions on top of the test data. So you use the X test and create a predictions out of it. And accuracy tries to compare your data, like your original data and whatever predictions you have done, and give you a score out of it. So you will load the metric accuracy score from the sklearn metrics. Once you have done that, you use the print to use the accuracy score, and accuracy score will take two parameters. One is the original matrix, which is the y-test, comma the predictions which you have currently made. So once you get that, it will create an accuracy measure for that. So accuracy will be nothing but the true positive plus true negative upon the all data. So it will calculate that and give you. The interviewer in the next step may ask you, like, how can you improve the accuracy score? So once you put the accuracy score, the next thing the interviewer may ask you is, how can you improve the accuracy score? So you can go for three simple steps where you can try to increase the accuracy of your model. First simple step would be try to see if you can make some tweaking into your probability cutoff. So the default probability cutoff is 50%. So the ones which are above the 50% is tagged as 1, and the ones below the 50% probabilities are tagged as 0. So if you are changing it to something like 0.8 and then checking the accuracy, if it makes changes to your model, it is still good. If it doesn't, the next step would be try to see if you can find out some better features using some feature importance algorithms, such as random forest, and different tree models are available which will give you the better features as per the target. So you can use those features and train a model so that you will have your accuracy increased. And next step would be create some new features and see if your model makes any improvement in your accuracy. You can make some new features or you can add some more data so that it will help your model to generalize better. For this part, we have completed with the Python related interview questions of the machine learning. So this was more of a technical part of it where we saw how we can code, how we can show the interviewer that interview is more interested to see how you can code the things and how confident you are with those things. Okay, so now we are done with that. We will now move on to the scenario based questions where we will see some puzzle kind of things and the other are real problems where the interview is related to understand as how you try to solve those problems. Let's start with those. So you are given a data set consisting of variables having more than 30% of missing values. Let's say out of 50 variables, 8 variables have missing values higher than 30%. How will you deal with them? So missing values could be of any reasons. So something like it's your data got corrupted while storing and you got a missing data. The person who collected the data may have done some mistakes and that data is treated as a missing data. Or it could be like there is nothing for those kind of values. So it's like it is supposed to be blank and it's supposed to be missing. So there are different conditions for those. So let's see how we can try to handle those things. First, we can create a new feature which will say, okay, this much of the part is non-missing and this much of the part is missing. So we can assign it 1 and 0. We can create a new binary variable. It's possible that this thing is trying to give you some idea about the data and there will be some hidden pattern within your data because of this some missing values. So it's possible that creating this new feature will help your model to give the better accuracy and give the better performance. Second thing, we can remove that completely. If you have a high count of data, so for example, if you have a very good amount of data and you can say that, okay, I can leave with removing this 30% of the data, then you can bluntly remove this. If it is not giving any value to you and you can't spend much time on trying to improve it or trying to impute it, then you can bluntly remove it. Or you can check the distribution. So for example, there are different ways to check how your missing values are to the similar cluster. So some examples are you can see your missing values are clustered on some other values. So can we give those cluster values to those missing values? So it's like identifying clusters and based on those clusters we give values to the missing data. Or the second thing is we use the distribution. So if they are continuous in nature, we can use the distribution to assign some data to them. So write an SQL query that makes recommendations using pages that your friends like. So assume you have two tables. First table is a column table of users and their friends. Second table is a two column table of users and the pages they like. It should not recommend pages you already like. So why would interviewer ask an SQL question in this case? So it is like he's trying to understand how better you know the recommendation engines from the database point of view. So it's like he's trying to understand your knowledge in a different term. So first thing you have these two tables. So first table is including, you can assume you have to make some assumptions and draw the picture of this two tables first. So first table will include a user ID and a friend ID. Second table will include a user ID, the page ID they have liked. And then once you have this structure of these two tables ready, the next step is to merge them together based on the friends. So as we are interested to know as which friends are liking which pages and based on that we want to recommend it to the original user. So first thing is we have to combine these two tables using a unique key which is the friends ID. So we join these two in the SQL using the friends ID. That is one condition. Second condition says it should not recommend pages you already like. So what you do, you have to have a way where you can exclude the pages which were already liked by that user. So this can be done by an inner query which you can use here to select the pages which that user has already selected. And in the where condition, you can say the page should not include this. So if you look at the whole query again, we are first selecting the first table user ID, the friends table user ID, and the likes table page ID from friends F join like L. So we are trying to join them together on friend ID and the user ID. Second is, as we mentioned, that was the first thing. And the second thing is we try to remove the recommendations, the pages which he has already liked. So which we'll do by page ID, not in the pages which he has already liked. So this is the condition which is trying to do this, and this is how you can explain this thing to the interviewer. So there is a game where you are asked to roll two fair six-sided dice. If the sum of the values on the dice equals 7, then you win $21. However, you must pay $5 to play each time you roll both dice. Do you play this game? And in follow-up, what is the probability of making money from this game if you're playing it for 6 times? So the first condition says if the sum of the values on the dice equals 7, then you win $21. But for all other cases, you have to pay $5. So in this case, if we first assume all the possible cases, as we have fair six-sided dice and we have two of them. So there is 6 multiplied by 6. We have 36 different cases. And out of it, having two dices equal to 7 is like we have 1 and 6, we have 2 and 5, we have 3 and 4, we have 4 and 3, we have 5 and 2, and we have 1 and 6 again. So those are nothing but 6 possible chances are there out of 36. If we take a ratio, 6 by 36 will give us 1 by 6 ratio. So this says we have a chance of winning $21 1 in 6 games. So assume that we are playing 6 games and out of it we win 1 game of $21 and 5 games we lose. So in this case for 5 games we have to pay $5 and this will be $25 and we are winning one time which is $21. In this case if you see there is a loss. So we are paying $25 and we are winning $21 in this case. So for the first question, do you play this game? This is no, as we are getting a loss as per the probability. The second question says, what is the probability of making money from this game when you are playing it for 6 times? If you assume in this case, we are making 6 games and out of that, the winning probability, if we just have a win in one case, it be a loss. If we win 2 games out of 6, we are going to win. If we win 3 games, it will be profitable again. So 2, 3, 4, 5, 6 are the cases where we will see a profit. So this case can be simulated with the binomial distribution. So binomial distribution takes 3 parameters. First is your probability of winning and losing. So that is in our case nothing but 1 by 6. The second is the number of plays, which is 6. And the third is the number of cases that we want to identify. So for example, in our case, we want to have a condition where the number of wins is greater than 2. So we want to identify. The first case is a failure where in the first case we are always losing. But in the second, if we win 2, 3, 4, 5, 6 times, we will always be winning. We will have a extra money. We have to find a probability where we will have more than 2 wins. So that can be simulated with the probability to get the answer for the second question. So the next question, we have 2 options for serving ads with newsfeed. So first is out of every 25 stories, one will be an ad. Second is every story has a 4% chance of being an ad. The question says for each option, what is the expected number of ads shown in 100 news stories? If we go with the option 2, what is the chance a user will be shown only a single ad in 100 stories? What about no ads at all? So in this question, if we look at the first part, which says for each option, what is the expected number of ads shown in 100 news stories? So let's check it for the first one. So for the first one, out of every 25 stories, one will be an ad. So this is like 1 out of 25. In the second case, every story has 4% chance of being an ad. So this is like 4 out of 100, and which is again nothing but when we divide 4 by 100, we will have 1 by 25. So for the first question, the answer is both are similar. So both the cases have expected number of ads in 100 similar, which is 1 by 25 or 4%. Both are equivalent to each other. For the second question, you have to see is the question asks what is the chance a user will be shown only a single ad in 100 stories. If you see this question, it is an example of binomial distribution. So as we just saw in the question 3, binomial distribution takes 3 parameters. First is the probability of success and failure, which is in our case is 4%. Second is the number of total cases, which as the question says 100 stories. Last is the case that we want to identify, means probability that we want to find out. So the question says, what is the chance a user will be shown only a single ad in 100 stories? So we want to have the three parameters as 4%, 100 stories as our n, and single ad as our probability chance. So if you see, the probability can be calculated as 0.96 is basically not getting selected, which is 1 minus 0.96 raised to 99. So 99 cases are not going to selected. Multiply the chance of selecting, which is 0.04 raised to 1. So we are calculating a probability of not getting selected of 99 samples and getting selected of one sample. So this is the binomial distribution for selecting one ad out of 100 stories. The second question just says what is the probability of no ad at all. So in that case 0 and 99 would become 100. So 100 multiplied by probability of one case. So it will become 7.03%. The only thing is you have to identify like which distribution is highlighted from your question. So sometimes you will see that normal distribution kind of questions will be there where you have mean, standard deviation, and based on that you have to identify different things. In this case it was binomial, so based on the parameters which are there in your question, you have to identify which distribution you can use for that and try to solve it. How would you predict who will renew their subscription next month? What data would you need to solve this? What analysis would you do? Would you build predictive models? If so, which algorithms? This question is very generic, and interviewer is really trying to understand how you try to approach your problem. So when you are given a problem, how you try to identify different components which are there within your problem, how you try to solve each of those confidently, as how much of your knowledge is there within each of it. So what you have to do is, let's assume something as first thing. How would you predict who will renew the subscription next month? Let's assume we are trying to predict the subscription for Dish TV subscription. So who is going to renew the subscription next month for the Dish TV? So that is the problem statement. First we define it. What data would you need to solve this? So in the case of Dish TV subscription, we would like to identify how many number of hours for that household the channels are active, how many number of kids are there in the home, how many number of adults are there in the home, which are the different channels they use, for how much time, and from previous month how much increase or decrease has happened in this month. So this all variables would help you to understand if in the next month again that customer is going to buy or not. So if there are kids in the home, there are chances that because of kids, whenever there are kids, they will look for the TV, and kids will always help you in understanding if there will be subscription or not. And if the subscription has either increased or decreased from the previous month, will also help you to understand if that user usage has increased or decrease. So that will help you to understand the trend and make your prediction better. So what analysis would you do? So we would like to do the classification analysis in this case. We want to identify, okay, this customer is going to subscribe next month. This customer is not going to subscribe. So this is a pure classification related problem. Would you build predictive models? Yes. So for the classification related problem, we would like to build a predictive model. So we would already have a historical data. We will gather the data which is already existing and use that to train our model. So we can use any algorithm. So we can use any classification related algorithms in this case. So we can use random forest, we can use logistic regression, we can use neural networks, whichever. We can try different models and see which one performs better, and based on that we can continue with the model which performs better and tune it further. So you have to start with the step by step and show that okay, this is the next step, this is the next step, till the end of your model. So even in this case, if so, which algorithm would not end the problem? Algorithm you have selected, after that you have to validate your algorithm. It will even go that in production, and within production you will also validate again and see in real life how it's working, make again changes to the model. So those things may change again as the interviewer may keep on asking you the further things, and you have to be ready for those things. Interviewer may start with few questions, But as you keep on solving the problem, interviewer would keep on digging further as what would you do next. So you have to be ready for all those things. So be prepared for those things. How do you map nicknames Pete, Andy, Nick, Rob, etc. to real names? So this is like understanding how you try to solve a problem where there is not much of data is there. So this example is just you have just a nicknames and you want to identify the real names to them. So this can have different answers. It is not related to a single answer and there is no generic fixed answer. But interview would be interested to know as how you are trying to approach the problem and solve it. So few things could be like, as you don't have any data, first you try to gather as to which components these things are related. So for example, if you are trying to understand these nicknames from a Twitter tweets, try to see who is trying to refer to who, and based on these nicknames, see the relation as which person is trying to talk with which person, and you can try to identify based on the NLP algorithms as what is the real names for those people. So similarly, you can try to identify in the Facebook, or if you have some customer feedbacks and within those customer feedbacks you want to understand this, you can do it that way. But this would be more like you have to understand in the context. So in which context people are talking to whom, and based on that, you can try to identify the real names. So this is just a one example, but it is not related to just single one. You can create your own, as I said, there is no single answer to this problem, but it mostly depends on how you are trying to approach that problem and solve it. A jar has 1,000 coins, of which 999 are fair and one is double-headed. Pick a coin at random and toss it 10 times. Given that you see 10 heads, what is the probability that the next toss of that coin is also a head? So let's first try to split the problem statement that we have. So the different components are, we have 1,000 coins, of which 999 are fair. So for the fair case, we can say that, okay, there is 0.5% probability that it could be head or it could be tail. And one is double headed. So it is not having probability and it is just 100% probability that it's a head. We pick a coin at random out of this 1,000 and toss it 10 times. So each time we select a coin, we toss it. We select a coin, we toss it. So we try to do it 10 times. Given that you see 10 heads, what is the probability that the next toss of that coin is also a head? So let's see what we can do in this case. So basically we have two types of coin which can be chosen in a two different ways basically, and there are probabilities associated with each and they are different. So for the first type of coin, which is fair, we have 999 out of 1,000, so which is 0.999. And the chances of selecting the second coin, which is unfair in nature, is 1 out of 1,000. So these are the probabilities that we have got first. Now, as the question says, we have already chosen 10 heads. We have already done some experiment and we have got 10 heads. So what is the probability of selecting those? So selecting 10 heads in a row is equal to the chances of selecting fair coin multiplied by getting 10 heads plus selecting an unfair coin. So if we see that, first thing is selecting 10 coins from the 999 fair coins is, we have the probability 0.999 multiplied by the fairness is basically probability 0.5 raised to 10, which will give us 0.999 multiplied by 1 by 1024. So when we multiply this, we will get a chance of selecting coin A, which is nothing but selecting the 10 coins from the fair coins. The second part is the probability of selecting the second coin, unfair coin, multiplied by 1, which is basically everything is head there, as we don't have anything, everything is head, so it is 1. So probability of here is 0.001. Probability of A says selecting the 10 coins from the fair coins. Probability of B says selecting the 10 coins from the double-headed ones. Now the second question says, given probability of fair coins, what is the chance of selecting the coin from that? It is like a conditional probability, and in this conditional probability, what we are doing is we are dividing the probability of A given probability of A and B. So given both of them, what is the probability of selecting the coins from the fair coins? This is the probability. And the second part basically says, given double-headed sided coins, what is the probability of selecting from that. So these are the two individual cases. Once we have got that, we have to create a combined probability, which will include the chances of selecting the coin from the fair coins multiplied by 0.5 plus the chances of selecting the coin given it is the double headed multiplied by 1, and this would create a combined probability and give you the output as 0.7531. So for this case, we have to go step by step, divide the problem into smaller parts and get to the answer of it. Suppose you are given a data set which has missing values spread along one standard deviation from the median. What percentage of data would remain unaffected and why? In this case, there is not much details about how is the distribution of data. It is just said that there is a one standard deviation from the mean which is missing data. So we have to make some assumptions. So as most of the data follows a normal distribution, we would assume that this data is also following a normal distribution. And we would say that, okay, a normal distribution has within one standard deviation, 68% of the values. So as per the normal distribution, within one standard deviation, around the mean, median and mode. As for the normal distribution, all are equal. All mean, median, mode are at the same location. And from the mean, around one standard deviation, we would have 68% of the values. And as the question says, missing values are spread along one standard deviation. So 68% of the values are basically missing, and question asks what percentage of data would remain unaffected and why. So everything left after the 68% would remain unaffected. So we would say 100 minus 68, that would be 32. So 32% of the values would remain unaffected by missing values. You are given a cancer detection data set. Let's suppose when you build a classification model, you achieved an accuracy of 96%. Why shouldn't you be happy with your model performance? What can you do about it? So first thing is, as this thing is mostly related to the domain of cancer detection, interview is trying to gauge you as how better you know as so how the accuracy of the models works in a different data distributions. So if we look at the cancer detection domain, in the cancer detection domain, very few of your data points would have actual cancer. So for example, if you have a 1 million patients data, out of that you would have like around 1,000 of them would be having cancer. So it's like a very small set of data is having actual cancer. So let's assume we are creating a confusion matrix. So when we create a confusion matrix, we see that in the true positive, which is just 1,000 values. So even if our model tries to identify like 500 of them, so we'll get in the true positive 500. And let's assume in the true negative, we are getting all the negative values, which is 1 million minus 500, which went into the positives, and everything remaining will go into negative. So if you create the accuracy, it is like 500 divided by whatever is there in the remaining parts. So 500 is what you got the true positive values, and something you will get in the true negative. And when you divide it, you'll have a bigger accuracy. So your model give like 98%, 96%. As your true positive is actually very small, your true negative would be very large, and small components will be there in the false positive and false negative. So when you try to divide them, you will have a bigger accuracy always. So accuracy is not used in those cases where your distribution of positive cases is very less. So in this case, accuracy won't be helpful for us to evaluate the performance of our model. So we have to go with other performance metrics which are available. So for example, we have recall, we have precision. Recall is again called as the sensitivity. Again, we have another as the specificity and F1 score. So this different performance metrics will try to identify the model performance based on different components. So accuracy is mostly useful when you have the classes which have some similar count. When you have some similar count but not very smaller classes, then your accuracy will be helpful. But when you have very small positive class, such as the cancer detection or the anomaly detection. So again, anomaly detection is a similar case where fraud detection basically. So fraud detection is again a case of this case where we have very small number of values. So we can't use accuracy in that case, and we have to use the different performance metrics. You are working on a time series data set. Your manager has asked you to build a high accuracy model. You start with the decision tree algorithm since you know it works fairly well on all kinds of data. Later, you tried a time series regression model and got higher accuracies on the decision tree model. Can this happen? Why? So first thing, as it is a time series data are mostly linear in nature. So as the next value would be related with the previous value. So let's assume we want to look at the stock prices. So stock prices which are today are related with the yesterday. So whatever value was there yesterday, it is the either higher or lower as compared to what was there in the yesterday. So as compared to this, what decision models would do, decision models would just try to identify some rules within your data. So they would just do some rules which is very non-linear in nature. If there is actually some proper patterns within rule, the decision tree would really helpful. But what the time series related regression should do it, they would try to regress it based on the historic value as they are linearly correlated with the previous values. The time series regressions would work by regressing it on the historic values. So that's why time series regressions would be more accurate than the decision trees because we have a linearity available within the time series data. Suppose you found that your model is suffering from low bias and high variance. Which algorithm you think could tackle this situation and why? So first thing, so low bias and high variance. So bias and variance are the term mostly used when, so bias basically means you're getting bias to a specific set. So when you have a higher bias, your model is getting underfit. It's not preferring anything and it's just underfitting your data. And high variance is something where your model is very much overfitting to your data. So in our case, it says there is low bias and there is a high variance. So our model is doing a overfit. So first thing is we can use some kind of bagging algorithms. So what these bagging algorithms do is they try to divide your data into multiple samples. So those are samples with the replacement and each sample is trained with a decision tree. So now what happens? We are creating multiple trees which are trying to understand different patterns within the data set. Whatever data you are feeding, whichever sample you are feeding, whatever the patterns available within that sample, each model is learning those things. So now you have a weak learners and when you combine those weak learners, you create a strong learner which will also try to reduce your overfitting. And how it reduces the overfitting is as you're creating more and more models, if some of them is trying to overfit, the others will try to help to get balanced variance in this case. The other technique that we have is we can use the regularization technique. So regularization, there are two types of regularization. There is L1 regularization and there is L2 regularization. Those techniques we can use to penalize the model. So what happens? Those try to penalize whenever your model goes for a higher variance, it tries to penalize it by some parameters that we provided. So based on those parameters, it tries to restrict your model for going beyond the limited threshold of the overfitting. So the regularization is the second technique. And third is we can use the feature importance. So we can use the different tree based techniques like we can use the random forest like feature importance techniques to select top features and we can use those to create a model so that our model will try to fit with those important features. So when we try to add all the features, some features may make our model very much overfitted and when we have a newer data, it may not generalize well. So when we try to identify which are the important features, then our model will try to generalize well to the actual patterns which are there within the data. So it's always better to go with feature importance, try to select the features which are important, then create our model on top of it. So these are the three techniques that we can use to reduce the variance. You are given a data set. The data set contains many variables, some of which are highly correlated and you know about it. Your manager has asked you to run PCA. Would you remove correlated variable first and why? So most of the people would say that, okay, PCA we are using to reduce the multicollinearity. So removing the collinear variables, we won't use the PCA. But what happens is with the PCA, we are not just interested with the multicollinearity of the variables. Sometimes we are also interested with the variance which is available within the data. So what happens is PCA tries to explain a complete variance available within your data. So variance is something which says like the distributions within your data. So once you know that, PC also gives you the eigenvector through this variance, and you can use this variance to reduce the features which are available to you even when there is no multicollinearity. Even if you have some thousand features, there is no collinearity within the variables. When you use the PCA, still in this case also, you will be able to reduce the size of your features to a lesser number. So PCA doesn't just has to be with the correlated variables. We can use it also just to reduce the column's length using the variances which are explained in the model. So you're asked to build a multiple regression model, but your model R square isn't as good as you wanted. For improvement, you remove the intercept term. Now your model R square becomes 0.8 from 0.3. Is it possible, and how? So first thing, what is R square? So R square says how your linear regression model, how much of the variance out of the data it's trying to explain. So your data contains a variance and what percentage of variance your model is trying to explain. The more the variance it is trying to explain, the better is your model trying to represent your data. So the formula if we see for the R square is R square is equal to 1 minus summation of y minus y hat, which is the predicted values, square upon y minus y mean square. So intercept basically refers to the y mean. So in actual, the intercepts are representing the y mean and they're helping the model to maintain based on the y mean. So in the presence of it, we are creating a R square, which is something different. And when we are removing the y mean, so when we are removing the intercept, we are removing the y mean. In our case, as a denominator becomes small, our R square would become big. So as we remove the y mean, our denominator would become small. And as we are dividing by that, our R square would become big. But one thing that you have to be very sure in this case is this: both the models are different. You cannot compare the model without the intercept and the model with the intercept. So both the models are different and you have to tune them separately and you have to measure them separately. They cannot be compared as the one with the intercept and without the intercept are completely different in nature. You are asked to build a random forest model with 10,000 trees. So during its training, you got training error as 0.0, but on testing, the validation error was 34.23. What is going on in this case? Haven't you trained your model perfectly? So this was very good. That right got a 0.00, like 100% accuracy with the training data. But when we try on the validation data set, we say that there is an error of 34.23 of some metric. What this case basically says is you are getting very much good performance on the training data, but when you check it on the unseen data, this unseen data is showing some different performance. So this is a pure example of complete overfitting. So what you are doing is your model is trying to mimic actual data within the training set. It's just learning every pattern, every corner of your data, and it's trying to make actual and accurate predictions out of it. But when we go for a newer data, as it has got very much mimicking the training data, so newer data may get the outer bounds and may not get a better prediction. So we have to reduce the overfitting and try to make a model generalize. So we can use these things that we have discussed earlier to reduce the overfitting within the data. So we can use different techniques that we've already discussed, such as we can provide more data or we can reduce the number of trees which are there. So as we are using more and more trees, our model is getting overfitted to the data. So in our case, we have to use the lesser number of trees and see if our model gets generalized or not. So people who brought this also brought recommendations seen on Amazon is based on which algorithm. So we have all seen on Amazon that when we are looking at some product, we get that, okay, people have also brought this kind of product. What basically this means is whatever you are currently looking, people who have brought that product or who have already viewed that product have also looked at the different products. So based on those, you are getting recommendations. So there are two types of recommendation systems. First is the collaborative filtering and second is the content-based filtering. In content-based filtering, what happens is whatever you have rated previously, so based on that, you will get a future recommendations. So for example, let's take an example of Netflix. In Netflix, you have watched some genre movie. You have watched romantic movie for 2 to 3 times and you have given a better rating. So what Netflix would do, based on whatever you have done, whatever the content we have viewed earlier, it will create a new recommendation for you. So based on whatever you have done previously, you will get a newer recommendations. So that is the content based recommendation. What we are seeing currently for this example, it is collaborative filtering. In collaborative filtering, what happens is whatever you are doing or whatever you have done previously, based on that, you will be checked with the other users who have done similar activity, and it will also check what are all different activities they have done and you have not done that. It will try to recommend those things to you. So if you see the example which is here, it says that the user who's on bicycle has brought pizza and pasta. Similarly, he is trying to be compared with the user who has done similar activity. So in our case, there is this user who has brought pizza, pasta plus a Coke. So as this user has not brought Coke, he will be recommended this Coke. So this is the core of collaborative filtering. So this is the technique which all the major e-commerce related companies use to recommend products to the users. So even Netflix is just uses the content based filtering for recommending the products based on the history that he have done, but also he'll be recommended based on the collaborative filtering as what all other users have done similarly and what they have done as a additional things. So that's how the recommendation systems works. Just to summarize what we have done today, so basically we have started with the three components, three types of interview questions. We started with the core machine learning components, which involved more of a theoretical components in the machine learning. The second was we looked into the Python related questions on machine learning. We saw some practical aspects. What are the different components within Python? How we can write some Python code? How interviewer will try to gauge you? How you can write the code and those things. And the last part was scenario based questions. So in that case, we were trying to understand how, based on the scenario which is given, how would we choose different models? How would we do the machine learning related tasks based on the scenario which is available to us? So I hope you all enjoyed this session, and best of luck to you all for your interviews and have a good luck.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!